Hi, this is Vijay. Can you hear me all right? Hello? Hello? Can you hear me? Hello? Can you hear me? Hello? Hello, checking. One, two. Hello, hello. Hello? Testing.
Hello, Dr. Chandru, can you hear us?
Yeah.
Okay.
Can you hear
Okay, so
me?
it was a mic testing.
Yeah. And will I be able to share my presentation?
Sure, sir, you'll be able to share.
Okay, great. So we're all set.
No, no. Yes, sharing rights, no issue.
Okay, great. Thanks.
Would you like to test the sharing, sir, as of now?
Yeah, sure. Let me just do that.
Okay. Start.
Did that work? Are you able to see my screen?
Yes, sir, we are able to see your screen.
Okay, great.
If you can switch to that presentation mode. Yeah, that will be visible.
All
Issues, sir.
good. Okay, great. You want me to leave it on or bring it
No, no,
up?
sir. You can switch to sharing mode whenever you want, sir. No issues.
Okay, great. Thanks. I'm just stopping.
Thank you, sir.
Okay. So how much longer before we start? Oh, there we go.
We are almost ready, sir. Good to go.
Good morning. I request all the guests to kindly take their seats. We'll begin with the program shortly. Namaskar, ladies and gentlemen, and welcome to the Industry Day 2023 at IIT Jodhpur. I am Dr. Katyayani, a master's PhD student of medical technologies, and I am delighted to welcome all of you to this warm winter morning dedicated to MedTech and healthcare. The postgraduate programs in medical technologies jointly offered by IIT Jodhpur and AIMS Jodhpur are uniquely placed, wherein the major objective is to foster innovation and to develop globally competitive medical and healthcare technologies to address the current as well as emerging challenges of the future. These programs have been conceived and designed in a way to not only knit together the relevant key elements of medical science and engineering, but also have desired emphasis on translational research and development, innovation, and entrepreneurship. The key objective of this thematic session is to strengthen the industry academia collaboration and explore the potential pathways towards redefining the future of healthcare in a smarter and more sustainable way. For this very occasion, we have here with us our distinguished guests. Professor Vijay Chandru, Chairman, Strand Life Sciences, joins us online. Welcome, sir.
Thank you.
We welcome Mrs. Isha Ray and Mr. Nimesh Ray from Inaltech Labs Private Limited and Anaya Foods. Welcome, sir. Welcome, ma'am. We also welcome Dr. Vijay Narayan Tiwari, Director at Samsung R&D Institute, Bangalore, and Mr. Satyendra Johari, Chairman, Johari Digital Healthcare. Thank you for your gracious presence, sir. Ladies and gentlemen, our keynote speaker, Professor Vijay Chandru, is the co-founder and chairman of Strand Life Sciences. He is an academic entrepreneur recognized as a technology pioneer by the World Economic Forum. His academic career has spanned over 2 decades at Purdue University and IISc. He holds a PhD from MIT. Dr. Chandru is the recipient of several awards and honors, like Fellow of Indian Academy of Sciences, MCIT Devang Mehta Award for Innovation in IT, UGC Hariom Trust Award for Science and Society, the President's Medal of Informs, Distinguished Alumni Award by the MIT India Program, and he is a recognized biospectrum biotech entrepreneur. Dr. Chandru was the elected honorary president of the Association of Biotech-Led Enterprises, the apex trade body that represents the Indian biotech industry. He also serves as an advisor to the Karnataka State Council on Science and Technology and on the Atal Innovation Mission at the Niti Aayog in New Delhi. We're honored to have you here with us, sir. I request Dr. Chandru to proceed with his talk.
Thank you. Good morning, and my apologies for not being there in person. I hope you can all hear the audio, and I'll shortly share a presentation as well. Um, it's I was told that there was a slot till about 10:45, but I'll try to make a 30-minute presentation and then have a little time for interaction. So with that, let me just get started. As was mentioned in the introduction, I come from both an information technology and a biotechnology uh, background. Is there, are you able to see the screen? Just want to check before. Are you able to see my PowerPoint slide, the title slide?
Yes, sir. Yes, sir. We're able
Okay,
to do
okay,
that.
great, great. Thank you. So the theme that I've picked up here is, essentially at the interface of digital and biotechnologies, and obviously with a view towards thinking about the applications to healthcare, and my affiliations, of course, were already mentioned. I am still an adjunct professor at the Indian Institute of Science. Uh, I serve as an advisor to Art Park uh, at the institute, and Strand. I, as a co-founder, I continue on the board and chair the science advisory board. Um, so with that, let me just jump in. The this in this extraordinary time that we were fortunate enough to be on this earth. I think we've actually seen two extraordinary revolutions. One being the what you might call the second machine age, where uh, computation, information science, and technology took us on a very, very accelerated path from very uh, sort of the middle part of last century, when World War II ended and computational machines were first conceived and built, and then later on, of course, with things like the internet being born, and today we are at this cusp of the AI revolution, and it's starting to impact biology as well, as we have seen through protein folding, and the solution by DeepMind and others on rapid prediction of structure from sequence of amino acids to structure of proteins, the so-called AlphaFold technique, uh, which is again leveraging information technology. I've sort of laid out a timeline of how I feel this will play out over the next 30 years, or I guess as a country now we're all focused on 2047 as our centennial sort of anniversary. And so if we how far is this technology going to take us uh, over that period? This is, of course, crystal ball gazing, and I've just laid out a few things there, which I believe are achievable if we really focus on this leveraging this technology revolution. Uh, just like everyone is doing these days, I of course went to Chat GPT-3. This was like a couple of months ago. When it was first out, and I had typed in AI in applied biotechnology, and this was the response I got, that applied biotechnology is a field that uses biological systems and organisms to develop and make products that can benefit society. And, and this could include everything from developing new machines to improving health, of course, agricultural crops and food production, and so on, right? This has now become everybody's new search engine. So I think we should, of course, I'm sure Alphabet is going to come back with something very strong as well, and capture back some of its lost luster with Google search. But it's exciting times in that sense. Well, as a computer scientist, um, I was like many others of my generation. Um we were guided by this extraordinary scientist and intellectual, Donald Knuth, at Stanford, who was kind of the for those of us in computer science, he was like the Einstein of computer science. And if you see what he says biology easily has 500 years of exciting problems to work on. And um, and you know and he's urging computer scientists to look more closely at biology. So that's exactly what we did. We were a group of computer scientists at IISc, sometimes called the Gang of Four, and we were running a lab called the Perceptual Computing Lab at IISc in the Computer Science and Automation department, and we decided to uh, work on problems, translational problems that could impact society. And so we began working on both on the computing side. We built a handheld computer called the Simputer, and we jumped into computational biology, and that was the creation of Strand Life Sciences. Mr. Ratan Tata was our the president of the court at IISc at that time, and he encouraged IISc to take this step of allowing professors to start companies, and the rest is history. Yeah, I mean, this was all in the year 2000, so uh, a good 20 plus years back. Of course, IISc continues to interact with us. We're back. Ramesh and I still teach courses there. So the Gang of Four, just to acknowledge them, standing up there next to the wooden post, uh, Vinay to the left, V. Vinay, who's also gone on to create Sherpa, the autonomous vehicle, Swami Manohar, who leads a group on user interfaces at Microsoft Research now, myself and Ramesh Hariharan, and Ramesh now leads Strand. We worked out the succession, and over the last 4 or 5 years now, he's been leading Strand. On This whole interface between biology and computation, I think it'll actually eventually get recorded in the history of science. I think as an extraordinary uh, confluence of achievements. On the one side, you had the extraordinary impact of Moore's law and making computation, the internet, AI now possible. And, sort of along with this revolution, there was the discovery of the double helical structure of DNA, figuring out how to sequence with Sanger techniques. Um, Eventually, that getting into the Human Genome Project, which was another big, public infrastructure, public goods infrastructure, created by the scientific establishments, and eventually leading uh, President Obama to launch the precision medicine initiative, which is now sequencing millions of human genomes and correlating it with various health parameters, and we'll see more about that, right? So just to step back a little bit into this biology and why we think of it almost as an information processing science is because in some ways there's almost a digital aspect to how we think now of the DNA, its transcription through RNA into proteins, which actually then go and do the work, and how the cell is kind of representative of organism, right? And I think this viewing this as a factory within a cell, or as Siddhartha Mukherjee, uh, you know, eloquently calls it, the song of the cell. And by the way, his book will come up in my reading references. I strongly recommend everyone reads it. Um, and um, and I think it's an extraordinary understanding now that is leading us to very rapid advances in molecular biology, which is driving biotechnology. And so, just very quickly, I think this is all pretty elementary for all of you, but of course, reading the genome, the DNA code, the ACGT code that every organism carries. That's one of the universal laws. I think was an extraordinary project to undertake, actually reading the human genome. And it, of course, has resulted in a reference genome. And now the Chinese are trying to create a Chinese reference genome. Indian scientists are hard at work to create an Indian reference genome, South Asian reference genomes, and so on. So, of course, again, we all know that these are organized into 23 chromosomes. Hence, you have companies with names like 23andMe, which essentially says that I am defined by my chromosome, but that's my chromosomes, but that's a little far-fetched, as we'll see. But as we know, the genomic code, it has a lot of coding that we don't fully understand, and but what we've focused on is the fraction comprising genes, because it is this fraction that seems to determine the structure of proteins that are expressed. And and in order to even understand what this code means and to take it forward, uh, for the first 10 years after the human genome reference was created, we were largely, the research community was largely engaged in trying to understand and annotate what this meant. And for that task of annotating the human genome, we really needed a lot of curation, modeling, statistical learning, and so on. And this is where we thought Donald Knuth's advice to go look at biology made a lot of sense to us as computer scientists, to jump in and create the tools that would help biology make these advances. So that's what we did at Strand. We built tools that could access, visualize, analyze, to discover uh, the uh, data that was coming out of high throughput experimental platforms and make sense of it and interpret it to understand disease biology, to understand biological function, and so forth. So Strand was really created to, in a way, we used to think of it as
It seems like there's been some connectivity issue. So can we connect back to Dr. Chandru?
and so forth. And so we built a whole sentence parsing NLP engine called Grammatica. And remember, this is before deep learning came about. So this was actually built with classical sort of NLP technologies. And is everything still okay? You're able to hear? And
Sir, just a second. So we lost you for a few minutes.
oh,
There was some connectivity issue.
okay. Where do you want
But
me to?
sir, it's all right. You can
It's
continue.
okay. It's flowing.
Yeah.
Okay.
Yes,
Right.
sir.
Let's keep going. Yeah.
Yes,
Yeah.
sir.
Okay. And so anyway, I mean, I think you get the sense. Strand went on to build all these platforms. Gene Spring, for example, has become kind of a gold standard for integrated biology that Agilent, distributes and so forth. Right? I'll pass on. And integrated biology across omics. So for doing not just genomics, but also metabolomics, proteomics, and being able to put all this information together. Well, I want to move on now to uh, the interesting uh, change that happened around 2007, 2008 or so, when Shankar at Cambridge came up with a next generation sequencing platform called Solexa. And Solexa was acquired by Illumina to create what are called next generation sequencers. And this was really kind of a tipping point for genome sequencing, where genome sequencing actually started moving faster than Moore's law. Until 2007 or so, the cost of sequencing was coming down at the rate of Moore's law, but then after that, it actually accelerates. And if you try to fit a curve, it might look like the square of Moore's law. So that's pretty significant. And today we are at this very, very exciting tipping point, which is several sequencing technologies now are starting to announce a whole genome sequence that can be done at $100. This is a human genome. So and this tipping point is essentially a point at which we will likely see an explosion of sequencing all over the world and of all kinds of organisms, and diagnostics will become within reach using sequencing technologies. And if you think about it in a different way, we are uh, reaching a kind of singularity, right? When you keep doubling your technology, uh, and you've doubled it maybe about 32 times, you've entered the second half of the chessboard. And at that second half of the chessboard, you're essentially getting almost a vertical takeoff, and that's why it's called a singularity. And I think we're entering the singularity with genomics as well, and that's a very exciting uh, time to be involved in biotechnology. And I think uh, and it's been gradual, right? So I think you had uh, the first breakthroughs in healthcare coming around 2010, when Nicholas Volker's whole genome was sequenced, and after about 100 surgeries, they figured out what was wrong with him, and this has been recorded in a story called One in a Billion, and actually won the Pulitzer Prize for the journalist who recorded it. And then it has gone on to you know, help children with disorders that they're born with, various types of genetic disorders, rare disorders, and first of all, solving their diagnostic odyssey, and then finding treatments that can be used to address some of these genetic problems. And it's now getting into this era of precision. And one of the guys who pushed this was Professor Larry Smarr at UCSD, who's actually an aeronautics scientist, but got very interested in monitoring himself, and he created this whole movement that we now call quantified self. I mean, we don't most of us wear Fitbits or wearables, and monitor our own health. And this was all started about 10 years ago, right? And at Strand, what we felt was that we needed now to move from interpreting what the experimental data was giving us for for research biology to improve its understanding, to clinical sort of implications. And this is where we needed to also capture clinical knowledge and use it uh, to be able to do diagnosis and reporting, and this literature curation and was already possible because of all the text analytics platforms that had been built. And so this led us to launching in India for the first time around 2013, uh, clinical genomics that could be used, by physicians to choose treatments, particularly in oncology, because I think that's where most of the advances were coming from. And so we built all these platforms, and because we were a group of computer scientists, we of course built a lot of automation into the actual informatics analysis. Are we having a problem again, or?
No, sir, everything's
Okay.
fine.
Okay, great. Yeah. So, and this has now been running for close to 10 years, and we've been able to drive down the costs, to a point where it is starting to get affordable. Of course, where this has helped us with understanding uh, specificities of Indian ethnicity in genomics, and particularly for disorders like hereditary breast and ovarian cancer. Actually, our uh, the patients in amongst the South Asian populations seem to have very different characteristics as far as the predisposition to breast and ovarian cancer compared to the West. We seem to have much higher incidence. Uh, Oncology, these oncological conditions seem to occur at a younger age, almost 10 years younger in India, with also the BRCA one, mutations are or variants within the BRCA1 gene seem to be much more responsible than the BRCA2 in the South Asian population, while in the West they're about balanced. So there are characteristics that we are starting to discover now in India through all of this clinical work in genomics. Strand, as a company, of course, as I was pointing out, we started out in informatics, really building products for research biology. Around 2012-13, we raised additional funding, moved into diagnostics, leveraging genomics. And by 2018, we were deep into hospitals and working with large networks like corporate hospitals like HCG and across the country. And today, I think we are starting to look much more at scaling all this technology that has been developed and taking it far and wide across the country. And of course, one of the reasons has also been that Reliance Industries essentially retired all the investors in Strand and have come in as our primary strategic partner. And once they have come in, of course, the whole idea of scale really sort of sets in, because uh, the Reliance is all about scale, right? So we are moving in that direction, and you will see the impact of this relationship with Reliance in the years ahead. I think one of the first things that you will see are uh, the offering of various new genomic tests at very, very attractive prices, because we are setting things up to optimize costs and be able to bring all of this at a price point that is affordable, at least to a substantial patient population, and also just towards health and wellness, to be able to scan uh, genetic predispositions, but in a responsible way. And I think we are staying close to the science. This will be also accompanied by genetic counseling, because the last thing you want to do is to scare people by telling them that they have certain predispositions. They need to understand what the implications are. So this will be uh, launched, uh, or it's actually already launched, but you will hear more about this in the days ahead. I want to switch gears now and talk about not just reading the genome, but also writing. And that's actually now taking genomics into a much bigger um, terrain. So it's while diagnostics and personalized and precision medicine, um, was a large impact. I think once we get into synthetic biology and being able to write and edit genomes, the revolution is much bigger. And the you know uh, Goldman Sachs and various others are predicting something like $5 trillion market just in the West. I mean, so you can imagine where this is going. And uh, uh, Even I guess this is Financial Times. Again talking about this being the greatest discovery since Darwin, right? And but it's really, the fact is that this could be, having impact on many of the problems and challenges that the world is facing, whether it's energy or productivity, food security, and of course health, and it's I think a very exciting time to be a bioengineer, right? Because I think a lot of this is going to become possible. So I'm going to play you a very short film here, which actually shows you CRISPR at work, right? And this is actually recorded with a high-speed atomic force microscope, and it's pretty remarkable to watch this. So in something like uh, 20, 20 seconds to about a little closer to a minute, you see the strand, the cleavage of the strand being affected um, by the CRISPR Cas9 process. I think this last picture is very clear, right? Uh, and so you actually see the cleavage happening here, and this is a double-stranded cleavage. You can also do controlled single strand and so forth. There is a lot of variations, and one of the exciting uh, developments is, of course, going to be that this enzyme, which was originally people used the Cas9 enzyme for affecting CRISPR, and that's what got the Nobel Prize um, for Doudna and Charpentier. Uh, Now there are hundreds and hundreds of different enzymes being created, and this is partly the effect of AlphaFold, because people are now designing enzymes in silico and then realizing them with new function and so forth, right? And it's I think it's CRISPR is not only advancing in the laboratories as a standard technique, but in innovation space is also just completely going through a very, very rapid evolution. Oops, sorry. So, just of course, you've all seen a lot of this uh, in the news that, first of all, there have been all these legal battles, IP battles between University of California and the Broad Institute at MIT, and lots of editing of genomes of small organisms. And yesterday I was with Dr. Surinder Singh from Canberra, from Australia. He came to present in the S20 deliberations as part of G20, and he is now able to, um, essentially through editing of genomes of organisms, is now able to convert sugarcane to jet fuel, or express uh, the omega-3 fatty acids from plants, and so you don't have to actually go to fish oil and so forth to get some of these effects. So, and this is all becoming possible, because of our ability now to manipulate with genetic engineering. So it's very, very powerful, and I think what we're um, starting to explore in India at this company that we've just launched called CRISPR Bits. By the way, the name comes from the fact that all the founders are Bits alumni from Bits Pilani, and so we got together during the pandemic and set up this new startup. It's basically registered in Delhi, but the labs are here in Bangalore, and we're starting to build out various diagnostic uh, applications using CRISPR detection systems. And I won't go into the details, but our MedTech sort of journey is towards creating really point of care MedTech platforms that can actually run these CRISPR assays and be able to do it in microfluidic platforms so that we could do a fair amount of multiplexing, and we will, of course, it'll be connected, and we've already started demonstrating the various pieces here, including the fact that we could get amplification through isothermal lamp and IPA techniques and RPA techniques, and we so may not even need a PCR in this delivery platform. So this would be a very uh, different type of medtech point of care device that would actually be looking for nucleic patterns. And I think we saw a hint of this early in the pandemic when IGIB announced the Feluda diagnostic for COVID, for SARS-CoV-2 detection, and but I think it's exploding, and eventually I think we should be able to identify varieties of pathogens and also resistance genes, and be able to generate and also do this on environmental samples like wastewater systems and so on, and be able to generate alerts on things like AMR and various outbreaks. So hopefully we are going to be much better prepared for future epidemics and pandemics, right? I want to just wrap up here very quickly with a bunch of recommendations for reading. I think from an industrial scale use of all of these technologies, I think our own stories from Strand, Ramesh Hariharan has published this extraordinary book called Genomic Quirks, published by the IISc Press. There's the book on genetic engineering by Jamie Metzel called Hacking Darwin. Susan Hockfield has written about the case studies from MIT and elsewhere on how engineering and biology are coming together, and in the age of living machines. Eric Topol, as a physician, has started to look at how all this medtech revolution is going to change how medicine is practiced. And Siddhartha Mukherjee's recent extraordinary book on the Song of the Cell, and how this is playing out in things like he's doing with gene editing, and also cell therapies like CAR T, the chimeric antigen receptor therapy, that he has started a company in Bangalore called Immunil, along with Kiran Mazumdar, Kush Parmar and others. And similarly in Mumbai, IIT Mumbai, Rahul Purwar and the Tata Memorial Group have also got into this. So very, very exciting times. I'll skip this section. I think all of you know this remarkable stuff that's going on in immunology, and I think, again, for the students, I think systems immunology is probably a wide open area, and if we want to actually do fundamental research, I think systems immunology is kind of a nice area to explore. Uh, this is sort of uh, my acknowledgement of the various companies and startups system that I'm sort of working with, and of course I mentioned CRISPR bits and Strand, but there are several others, and I keep learning from young people and scientists, the things that they do. And maybe I'll just stop there and would be happy to take any questions, or just wait for this to move on to the panel discussion, whichever is the organizers would like to do. Thank you.
Thank you so much, sir, for sharing your entrepreneurial journey with us and also shedding some light on what the future holds for medical technologies. I think we can take a few questions during the panel discussion, if that will be all right with you.
Sure, that's
All
perfect.
right. Thank you, sir. So moving on, I now invite Dr. Sushmita Jha, Associate Professor, Department of Bioscience and Bioengineering, and Coordinator of Joint Programs in Medical Technologies, IIT Jodhpur, AIIMS Jodhpur, to brief the gathering on building a self-reliant medical technologies ecosystem at IIT Jodhpur.
Very good morning to all of you. I hope I'm audible at the back. Yeah. Thank you, Katyayani, for the warm introduction. My name is Sushmita, and I'm going to be talking about the progress that we've made over the past few years at IIT Jodhpur in terms of building a sustainable, self-reliant medical technologies ecosystem. So before we get into the nitty-gritty of what we've built, let's discuss what is MedTech. MedTech encompasses any instrument or apparatus or appliance or an implant, in vitro reagents, software, materials, or any other article which is used alone or in combination for diagnosis, prevention, monitoring, treatment, or alleviation of disease or injury. Now, this is extremely broad because it encompasses investigations, replacements, modifications, or support of the anatomy or of a physiological process. And it helps in supporting or sustaining life. If we think about it, each one of us here today are using some technology or the other, which is considered to be MedTech, even if it's not related to disease. So it's involved in the disinfection of medical devices. We know a lot about it over the past few years during the COVID pandemic, and providing information for medical or diagnostics by in vitro examination of tissues from the human body. and which does not achieve its primary intended action in or on the human body by pharmacological, immunological, or metabolic needs. So the innovation in medtech and healthcare ecosystem is critical for our for improvements in life expectancy, in the case of quality of life, as well as improved diagnostics and therapeutic options. Medical technology innovations have helped build better clinical outcomes. They have been able to give us less invasive procedures and provide shorter recovery times. Okay, stop moving. So with all of these convergences of our needs as well as tech from different fields, we've had many medtech innovations over the past. From mixed reality for medical education that you have learned about in terms of the Microsoft HoloLens and many other technologies that are being developed even in-house at IIT Jodhpur and AIIMS Jodhpur, to brain-computer interfaces that have brought hope for paralysis patients. In this case, you might have heard this story in the news of a patient who was paralyzed and was able to move with an exoskeleton that was connected to their brain with small implants that could then be used to bring thought literally into action. There's been significant advances in 3D printing of drugs. So here I'm showing images from Wake Forest, where they've been able to 3D print kidneys and cartilage of trachea. And also now there is 3D printing of drugs, which will allow for more dispersible drugs for better absorption. There are apps for continuous health monitoring that I'm sure a lot of you here have been utilizing. Voice for diagnostics and medical support, which became extremely critical during the pandemic when a lot of us were calling into our doctors and asking if our cough was in fact COVID or not. Digital tattoos for a more invisible healthcare is something that we think of as healthcare of the future. So medtech and healthcare needs of India, though, are extremely unique. Why so? Because on one end, we have the paradox of India being one of the greatest healthcare providers of the world, with so much health tourism coming to our country. But on the other side, we have accessibility and availability issues for most of the population. So we need to bridge this gap with innovative technologies that bring about the demand and supply gap to be narrower. So how do you make India self-reliant in medical technologies? We know that the market for medtech and devices in India was about US dollars 11 billion in 2020. And this is expected to grow exponentially to about $50 billion by 2025. Interestingly, though, imports constitute about 80% of this market. India has the lowest per capita spend of about $3 on medical devices amongst all the BRIC nations. And this presents a massive opportunity for medtech startups. Now, our medtech sector is segmented mostly into consumables and disposables, electronic equipments and surgical instruments, implants and pacemakers, and in vitro diagnostics and devices. So that brings us to this MedTech program that was talked about a little bit. So the origin of this MedTech program, one of a kind program across the country, was to build a multidisciplinary program to produce deep tech innovators in the field of medical technologies to improve the quality, access, and efficiency of healthcare, hopefully to eliminate waste and provide lower costs, and of course, for the need of disruptive healthcare technologies and need for healthcare innovations, which is happening across the country and globally. Why do we need such a multidisciplinary program on innovation in healthcare? So we need a healthcare program of this kind because we need to have multidisciplinary professionals who are able to carry out business as well as entrepreneurship and understand the challenges of the future in the healthcare and medical technologies domain. Now, this cannot be done by engineers alone. This cannot be done by medical professionals alone. You need to have colleagues who are trained in all of these three domains. You want to have people communicate across domains and build bridges to build these kind of technologies. So these programs aim to generate manpower with multidimensional capabilities of creative, deep knowledge, and a strong sense of business. These programs that are jointly offered by IIT Jodhpur and AIIMS Jodhpur were launched in 2020 at the peak of the pandemic, and we saw a record number of 600 applicants in the first batch. At that point of time, we wanted to interview all the candidates because we wanted to see who were the ones who really wanted to dig deep into the incubation system. And we ended up interviewing all 600 of them. So we have now our third batch going on, and we have 3 different programs: Masters in Medical Technologies, dual degree, Masters and PhD, as well as PhD in Medical Technologies. In case of the Masters program, and in case of all of these programs, we follow a medical technologies training pipeline, which starts with a needs finding. A need is something of a problem that needs to be addressed. After this, these needs are screened, and to start with the invention process, the student or the student groups go about with the idea of concept generation and concept screening. After this is carried out, they undergo the implementation phase, which involves strategy development as well as business planning. So while this may seem really straightforward and simple, it takes a very long time for the students for the first step itself, which is to identify the needs and to kind of identify what is a good enough problem to pursue for this particular domain. So the scope of the program is to provide opportunities to assimilate cutting-edge knowledge in the domains of medicine and technology to address current and future global challenges in health, to encourage health techno-innovators to initiate startups and venture into entrepreneurship, to encompass broad areas which are related and they are not limited to medical device development, imaging-based diagnostics, deep tech solutions, telemedicine, many more. The program is unique and really tell the students what they have to do, but it is much more than that. It is almost tailored by the students' interests. So the program utilizes a student's individual interests to tailor make the coursework to enable these doctors and engineers to work jointly and meet healthcare challenges. The salient features of the program is that it provides an opportunity to medical professionals and engineers to learn and share knowledge and under a transdisciplinary academic umbrella, which is then designed to help with the innovation ecosystem. So all students undergo core courses. So in this case, as an example, if we look at the master's program, all of the MBBS graduates undergo core courses in some electrical engineering, so signals and circuits, and some courses in computer science and engineering, while the colleagues from the BTech background or BTech graduates end up doing anatomy and physiology so that they are able to understand each other's languages better. And then the whole group together undergoes immersion in the IPD and OPD settings of AIIMS Jodhpur to understand what are the problems that are faced by either the patient or the healthcare provider in terms of the physicians or the nurses that are interacting with the patients. So after the core courses, the clinical immersion happens. They identify these problem statements, and then based on the problem statements that they have chosen, they will dig deep with elective courses. So these elective courses are in specialized domains, which will allow these students to then learn. If they're interested, for example, in medical robotics, they'll end up doing elective courses in that domain. And they will then work in teams to carry out the prototyping of these technologies. And finally, they'll move on to invention and entrepreneurship. So there are courses which are offered by all of the different departments at IIT Jodhpur as well as AIIMS Jodhpur. Now, immersion is key to this exercise because each team, typically the engineers as well as the doctors, delve deep into one or more problem statements, and they try to understand what is relevant in a clinical setting. Not in isolation, not thinking about what could be an issue, but actually being in the setting and identifying what are the what could be the problems that are experienced. So this leads to what we call as a mission statement, which is the driving force behind a team, a doctor and an engineer, typically working together to kind of combine their forces to solve the identified need. So these are some images from our engineering immersion, where students actually go to different laboratories at IIT Jodhpur, experiencing the state-of-the-art infrastructure here and understanding what are the possibilities in terms of prototyping and building the kind of technologies that they are envisioning. And these are some of the images from the clinical immersion. So these students are extremely, I would say, privileged, and some of them are joining us here today because they end up experiencing all of the inpatient and outpatient departments, as well as all of the services that are provided by AIIMS Jodhpur, which are state-of-the-art. So these are some of the elective buckets that are offered in therapeutics, diagnostics, AI and medicine, and medical devices and implants. But this is just a suggestive list. It's not really a complete list of what ends up happening. So we have colleagues across the institute, from the School of AI to computer science to mechanical to materials to materials and metallurgy to electrical, who end up collaborating and working on these projects with colleagues from AIIMS Jodhpur across departments to build and help mentor these students. So every student of this program ends up having at least 2 mentors, one from IIT and one from AIIMS, and they have the opportunity to take one more mentor from industry if they wanted to. So to help groom them into this process, which they haven't been taught about conventionally in terms of their medical training or their engineering training, what we do is early on, we allow them to experience many workshops and talks with other innovators and entrepreneurs. So I've actually listed some that are mentioned here. These are from entrepreneurs who've either gone from being physicians into the MedTech domain or from being engineers and moved into that domain. So they can actually see what is the pathway to becoming a MedTech entrepreneur. I believe that, once you see these processes, it makes it a little bit easier to understand what are the steps where someone else had challenges. What do you need to kind of plan ahead for the future and such? So we have many such innovator mentor talks throughout the years. Some of these are listed here. So some of these mentors are continuously helping our students. So they come back and even help assess the pitches of the students as they start developing their products. So it's very important for the students that once they have come up with their ideas and they started building their tech, they have to pitch their ideas either to a funding agency or for some grants from the government, or to venture capitalists or to other collaborators. And in that case, you need to have people who will give you unbiased, critical assessments of what you should be doing, what you need to be doing, so that every different stakeholder needs are addressed. So we have lots of these pitch your innovation meetings. And we also have biodesign seminar series where we have colleagues from the MedTech ecosystem come by and talk and describe their paths to success. So we have hands-on biodesign workshops as well, which help these students understand this design thinking of how you go from a problem statement to ideation to actually the prototyping and moving forward into the process. These are the students of the MedTech program. These are our pride and joy. Some of them are not here from the 2023 batch, so apologies for that. But as you can see, we have a strong group. What I would like for you to notice here is that it's an extremely interdisciplinary group, right? So you have students who are dental surgeons, you have students who are from the biotechnology domain, you have students who are from the metallurgical domain, you have some students who are actually physicians and actually are working at AIIMS Jodhpur in the departments of physiology and anatomy. So there's a lot of diversity, which leads to a lot of diverse interactions and therefore diverse development of connections. So as a sample, I would like for you to see some of the projects of the 2020-22 Masters in MedTech batch. And these are 6 students projects that we are talking here. What you can see is that the supervisors from IIT and AIIMS are from different departments, ranging from the materials engineering department to dentistry, leading to development of technologies as diverse from the manual device for root canal irrigation through apical negative pressure, to the development of high performance saliva absorbent constructs for dental procedures, to developing socket-based anti-fogging glasses for ENT endoscopes. So extremely diverse groups, extremely diverse projects that are being generated. These are some of the prototypes that have been generated for continuous BP monitoring, development of a prediction model for automated scoring of cancers, development of high-performance saliva absorbent constructs, etc. Some of these posters are actually in the room next door. So what I would like for you to do is go visit and look at the posters and kind of experience real time and talk to the students about what the work that is happening here right now. So there are many posters as well as prototypes available. Some of these are listed here. So there is an empathetic WhatsApp chatbot for patient education and compliance, mixed reality-based, minimally invasive surgery and surgical planning, development of non-invasive, multimodal, multiplex devices for blood vital parameters, and many, many others that are listed here. So there are also AI-driven, robot-assisted echocardiography and image-based early diagnosis in child healthcare. This really young ecosystem of only 3 years has yielded a lot of patents. And so some of the MedTech patents that were generated by the students are listed here by students from the master's, PhD, as well as the dual degree backgrounds. As you can notice here, that IP is shared equally across IIT Jodhpur and AIIMS Jodhpur. This year, we are proudly announcing our first Indian conference on MedTech innovations. It's the first exclusive MedTech conference in India, and it'll be held from 24th to 26th February. And I would encourage all of you to register and definitely participate. Now, once the students have carried out their product designs and prototyping and all that, we have a very supportive ecosystem at IIT Jodhpur, which includes the Jodhpur City Knowledge Innovation Cluster, the Technology Innovation Startup Center. There's a lot of support from government and industry, as well as a MedTech Park that helps in the product translation. We've also been able to get some funding from Siemens to support pre-incubation incentive programs for medical technology students. And 3 of our students, Tilak, Anup, and Rajshri, have been offered incubation support after their evaluation of the pitches of their products. So from 2020 to 2023, there have been 7 startups that have been initiated by this program. And our MedTech students are actually bringing home a lot of laurels, from BIRAC Big Grants to MSME grants to Prime Minister Research Fellowships and many other fellowships across hackathons and MedTech competitions across the country. This could only be possible because of the unique ecosystem we have at Jodhpur. The MedTech Jodhpur City Knowledge Innovation Cluster, which encompasses many institutes, including IIT Jodhpur, AIIMS Jodhpur, NIR NCD, Ayurveda University, and all of the industrial partners, including Johari Digitals, which is represented by Dr. Johari here today. This ecosystem has therefore led to the 50 registered students that are available here now, a total of 18 pre-incubates, 7 MedTech startups, and 3 startups under the BIRAC Big Scheme. It has also led to the establishment of the BioNest, which is the first in Rajasthan by BIRAC, with a 4.5 crore funds for creation and support for more than 40 incubatees. Biodesign, which is funded by DBT with funding of 3 crores. AyurTech, which is funded by the Ministry of Ayush with about funding of 10 crores, and an MOU signed with Johari Digital Healthcare. I also mentioned CSR funds from Siemens, as well as the recently launched IIT Jodhpur, AIIMS Jodhpur Joint Certificate Program on Digital Healthcare for Working Professionals. We also have a new center on Duchenne muscular dystrophy, which is a rare disease, which has been supported by DSDA CRB at IIT Jodhpur. So our program has been in the news a lot, and I think it has to do with the unique flavor of the program, the structure that we have been able to accomplish, and the outcomes that are evident from the training framework at Jodhpur. This could not have been possible in terms of the program without the support of all of the colleagues that we have as part of the medical technologies programs. So this is a core academic committee across IIT and AIIMS, and we have different adjunct faculty also who are helping with this program. For the biodesign ecosystem, we again have team members from IIT Jodhpur as well as AIIMS Jodhpur collaborating together to help in the training and entrepreneurship development of our students. So right from the problem definition to the technology commercialization, these students will end up getting support of this ecosystem. So towards the end, I would like to add that to build a future of MedTech or any ecosystem, collaboration is key. So what we hope to get from today's session is that we are able to get stakeholders from different parts of the spectrum who can collaborate and bring together the needs of the MedTech industry for our country as well as globally. Thank you so much for your attention.
Thank you, Dr. Jha, for delineating the various aspects of the MedTech ecosystem at IIT Jodhpur. Ladies and gentlemen, we now move on to the panel discussion, and I would request Dr. Jha and Dr. Sumit Kalra, Assistant Professor, Department of Computer Sciences and Engineering, to escort our invited speakers onto the dais. So I request Dr. Vijay Narayan Tiwari, Mr. and Mrs. Ray, and Mr. Johari to please join us on the dais for the panel discussion. Thank you, ma'am. Thank you, sir. I'd like to introduce our expert panelists for this session before we begin. Mrs. Isha Ray and Mr. Nimesh Ray are the founders of Anaya Foods, which is an importer and supplier to food distributors, food manufacturers, and represents mission-aligned international food brands in the US retail markets. They both provide consulting and mentorship to organic food companies. Both Mr. and Mrs. Ray are investors in Analytic Labs, an API research development and manufacturing company based in India. We're delighted to have you here with us, sir and ma'am. Our next panelist is Jay Narayan Tiwari, Institute Bangalore, where he leads the Sensor Intelligence Research Team. He has vast experience in the field of academia and industry, having expertise in both engineering and medicine fields. Along with several research articles and books to his credit, Dr. Tiwari has received multiple awards from industry and academia in recognition of his work. He is a senior IEEE and MCI member. It is an honor to have you here with us, sir. Our next panelist is Mr. Satyendra Johri, who is founder and chairman of Johri Digital Health Limited. After working for 6 years in medical device industry, he returned to India with a clear focus to start medical device manufacturing in his own country and to encourage the local community. Amalgamating the technical know-how, business acumen, and research aptitude, he established an innovation-led MedTech brand catering to global clients. We're delighted to have you here with us, sir. So now let us begin with the panel discussion, and I'd request Dr. Sushmita Jha to moderate this session.
Thank you so much, Katyayani. Just a small correction. We'll also have Sumit moderating. So both of us will be moderating the session. Before we begin, I think what we can do is maybe we can ask our eminent panelists to talk a little bit about what they're passionate about and what they're involved in right now.
Hello, and thank you for having us. It's a pleasure to be here. My name, as they mentioned, is Aisha Ray, and I have a little bit of a cold, so excuse if I cough. Um, we, um, I think we went when we were really young, moved to the US to study. And one of the reasons that got us started into the industry we're in is that we both came from very diverse academic backgrounds. I actually went there to do a master's in biochemistry, even though I had completed a master's here. And I ended up working at Stanford doing research for the first 5 years of my life after academics. I was working very closely in the genomics field. I enjoyed doing it for a while, but realized that my passion lied more in the field of interacting and bringing some sort of sustainability in into the world of food. And so when we started our company, NRay, in the year 2000, we began with a three-pronged approach. The first being finding a solution for farmers to be able to develop organic products that had a market potential. Second was the ability to travel and work and understand different cultures around the world. And third, being able to bring diversity in grains in the marketplace that was almost non-existent in the US at the time. So with that in mind, we started an organic food company that evolved into a branded food products line called True Roots. And we grew into a company that was in 2013 acquired by the JM Smucker Group, which was an interesting acquisition at the time because they are more in the mainstream markets in the food in the US, doing jams and jellies and other kinds of products. But they felt the need to have a foot in the door in the organic food industry. So it shows that, the industry had evolved to where organics became mainstream, which was pretty much a mission accomplished for us as a company. When we started, people didn't know what a product like quinoa, even how to say the product name, to when we ended up, it became a mass market product line. So that was 2013, and since then, Nimish and I work both as industry consultants, mentors, investors, and running our current company, Anaya Foods, which supplies organic grains and seeds and other products to various different large retailers in the United States. Thank you.
Right. So, Nimesh, glad to be here. So many wonderful things to learn from the presentation here. My background is in computer science. I did my master's at USC, and after working for a few years in the technology business, I found agriculture and the role of agriculture in providing healthier lifestyles for the consumers and consuming organic foods just appealed to me, and the role it played in creating a better environment for the consumer, for the stakeholders in the supply chain, the farmers. It appealed to us to dive fully into it, and expanding the role and the use of organic foods in daily lifestyles was very interesting. I believe that the food system, the agricultural system, can push its boundaries and push its systems forward in implementing regenerative agriculture to address climate change. So that is one of my current interests and passions. So we have a few projects around the world going on along those. And in addition to the daily operations of Anaya Foods, we are involved in investing in the technology ecosystem in the startup in the Bay Area. That's where we are from. And it's always fun to learn what new things are going on in the industry by being involved in there. So that's what we spend our time on. Thank you.
I am Satyendra Jawhari. In 1970, when I was about to pass in BITS Pilani, I got an opportunity to work on IBM 360 and writing softwares. And one of my friends and me started writing a manuscript for a book. But I realized that writing code is not my passion. Then I realized, what do I want to do? So I enjoy hands-on working. And so I left that work, and because I was passionate to work hands-on, I decided to do work more on hardware. Although my background was in electrical engineering, I started working on electronics. Then, of course, I went to US and lived there for 6 years. But after 6 years, I realized that I must come back and do some creative, productive work in India. So we started with hearing aids because I wanted to do some simple design, which I want to do myself and not copy. And that helped me a lot because then I have good clarity about hardware, electronics hardware. Anyway, gradually we started growing. And I'm very glad to say that today our 85% of the manufactured items go to advanced countries like US, Germany, Canada, and we have certificate MDSAP, which means the quality management system of the 5 countries are harmonized, which is a very tough to, pass through the audit, but we did. And these 5 countries are whose quality management system is harmonized is of US, Canada, Australia, Brazil, and Japan. So we can send our material to any of these 5 countries once because we have the certificate. And our USP, the unique point is that our quality management system is amazing. The most interesting part is that when people outside, there was one company, endoscopy manufacturers, the largest medical device manufacturer, privately manufactured, privately owned company in the world. they approached 64 companies to, if they could manufacture in India. I don't want to name it right now because it's confidential. So after a lot of research for 1 year, they narrowed down to 4 companies. So their president came from US and they said, let's visit everybody. And they visited. And his statement was that among the 4, Johari Digital was on the top. And that's how they selected us. And now we are going to manufacture endoscopy and many other products. For last 20 years, we are manufacturing DNA and RNA extraction, which was the topic today. And one of the product, fast prep, which is we have evolved for many generations, and today we are supplying 5th generation, and it has become the benchmark in the world. Now we will design 6th generation, and the work is going on. And I can go on, but the point I'm trying to make is, like Professor Susmita was explaining about how AIMS, IIT are getting together and they get the funding, they understand the problems, go up to prototype. But from prototype to go to the market is a big, long journey, which we can do, and we do it. From prototyping, we have to convert this into manufacturable, DFM. We call it design for manufacturing, DFM. So we make it manufacturable, and there are many aspects in it. One of them is it has to be a simple design. It has to be, the industrial design has to be so good that it is acceptable by the market. I'll give you an example. In somewhere in 2001, we were exhibiting in Atlanta, Georgia. And some customers, few came and they said, why are you here? We get better products from most advanced countries and you are here exhibiting. And when I showed him one product, it was very good inside, but not from outside, and he laughed at it. And that made us to take the challenge and realize that industrial design has to be also good. It has to be nice looking, sleek looking. No matter what is great inside, it doesn't matter. It is valued by the customers, how they perceive. So you people are working very hard. I know. I'm in touch with many IIT engineers, and they work hard, but they don't go beyond it. And like you were saying that people should have creativity and very good in everything, but everything is not possible. There are 2 big aspects I want to share with you. One is the management aspect, where you have to have the overall view of the products and market and everything, finances. But when you go into the research, you go so much in the deep that you forget everything around it. So it has to be a combination of going into deep like a scientist or researcher or engineer and understanding the other aspects, which is governance, management, finance, marketing. And that can be possible interacting with industry. For last 2 years, I've been trying very hard to, work together with the companies, with IIT and AIMS, but it is going at very slow pace. We can speed up. Just once, all I want is make a visit to our facility. Because a lot of people think in Jodhpur, क्या होगा वहाँ पे? Jodhpur is such a backward city. यहाँ क्या होगा? When this endoscopy company came to India, they have about 250 people in marketing in Delhi. So जब उनके प्रेसिडेंट आए तो बोलते हैं साहब वहाँ जाके क्या करेंगे जोधपुर में यहीं दिल्ली में बना लेते हैं. We have 250 people and we can assemble and but when they visited our factory और वो बहुत he was very much resisting those Indian general manager. But that American president, he said, Mr. This is your dream. Just come here to Jowhari Digital and then you will realize what is the quality. And when they came to our facility, they realized that what is quality. And now he stopped resisting it and now we'll be getting the project rightly here. So what I'm saying is we are here in Jodhpur, IIT aims are here in Jodhpur. Great things can happen. And that's where I'd like to invite zealous people, who are with a zeal to be with us. And the way you have to do is find time, do it with priority. If you do it with the priority, because if you are in your labs and at your home, I know you are very busy, very comfortable, but you have to come out of it. Find time for working practically. The important thing of your research, most important thing of your research is it should reach the masses. And that is only possible if the design innovation is manufacturable and if it reaches masses. Thank you.
Hello, everyone. So thank you, Professor Siddharth, for inviting me. So I work for Samsung, and maybe in this panel, I'm the only one who is from industry. So when Professor Siddharth invited me, initially I thought I really want to go there because I started today morning from Bangalore. so, uh, but then he told, no, you have to interact with students, and this is the primary reason I'm here. And in true sense, I think I represent the MedTech program way back when I started my journey in such kind of program. It was a pioneer program in IIT Kharagpur in 2001. So I was in the first batch where 10 people were selected from all India and they started their journey. I was having medical background and I entered into an engineering institute. So maybe I can give my experience that although it is good to kind of know for engineering students, the medical subjects and the medical background people to know engineering subjects. But I think uh, eventually you have to choose one direction at an early stage to become successful in that field. Because otherwise you will end up learning a lot of coursework, or you will end up knowing a lot of things little bit, but you'll not be the expert in that particular field. So I would say pick your field or problem statement and believe in it, and then pursue that particular field or the tech item which you have chosen, and build a career around that. I think you guys are young and you will be definitely successful. So apart from that, in Samsung, I can't disclose too much because it is some of the things are confidential and we are not supposed to disclose. But I would say that we don't work on exact diagnostics. That if you know that you are suffering from some condition or medical condition, obviously there are gold standards things and you have to visit hospitals. But our job is to make the healthcare consumer centric, not the hospital centric, where every time you have to visit a hospital or for each and every condition you have to visit a hospital. So in a sense, if you want to democratize it, healthcare or MedTech. You have to bring it to such kind of portable devices, say for example, smartphones or smartwatches or standalone accessories, which people carry all the time and they can benefit on the run. Or unobtrusively, it is not affecting your life, but you are able to get some important signals and alerts, which probably you can then take it to the tertiary centers or hospitals to get it diagnosed or get the things done. So I work basically in the sensor domain. So not only on the body sensors, I also work on technologies where you tend to estimate the wellness and health conditions of a person using non-contact based methods and sensors as well. So this is an area we are exposing, we are exploring in Samsung, and we work on end-to-end research to market kind of scenarios. So for this MedTech program, I would say that a little bit of industry exposure and time-bound creation of POC is needed, I think. Even for PhD students, I would say that, okay, 1 year, 6 months, they should just dedicatedly build something in collaboration with the other partners, because you will not have all these skills in one person. So, and another observation I can give is that although it is nice and many IITs are pursuing this kind of program where faculties from different departments, they are coming together and they are mentoring the students. But I think at the end of the day, some anchoring institute or some anchor has to be there where those students belong to that particular anchor institute or something, or a department itself. So we at Samsung, we work on PPG sensors, motion sensors, UWB sensors, GSR sensors, and we primarily try to detect some early indicators of diseases or wellness indicators. We eventually don't exactly diagnose the definitive diagnosis or the final diagnosis, but we try to, move around with the person itself to give him some indication of his health and wellness. So I will be offline, I will be discussing more with students, if they are interested in what I'm doing. But at this point of time, I would stop.
So, thank you all the eminent panelists to share what they are doing. I would like to take our panel discussion further, like where Mr. Johri left and Mr. Vinay and Dr. Vinay left, is how we can increase the industrial support for running MedTech program in academic institute, so that there's more translation, there's more utility, there's more fruitfulness. So I'll again start. So keeping the time in mind, we'll quickly go again second round, and then we would like to hear from the audience their questions and then interact with them. So Dr. Isha, I request.
Very simple. We have to change and prioritize to work. We have to change our attitude and prioritize to see how we can innovate something which is practical, which can reach market, which is manufacturable, which is commercially viable. That is possible. And the way we can interact is meet once in a month. I don't know, frequency we can decide, maybe once in a month should be good. We come here, your people, whoever are very keen to do something, come to our facility, and this interaction has to be done more frequently. Meeting a year or couple of years doesn't help. And that's what is happening right now. So let's improve in that direction, and it will work. We are very keen to come out and support innovations. We have a lot of ideas, what is the requirement of the market. So keeping that in view And if the research is done, the sky is the limit.
So I think this is a good opportunity for me to reiterate that uh, industry collaboration is important. There is no doubt about it. But how we can enable that, right? That is the question. So if we identify the problems which are relevant for the industry as well as to the society, and we come to a mutual consensus that this is the problem we want to solve, which is there in the roadmap of the industry as well as it is relevant for the society in the long run. I think it will be a win-win situation, and collaborations are eventually successful if they have something for the both the partners, and I think that is important.
I'll just say one thing because I mean, I don't know about the industry here, but just based on how a lot of these things work in the United States, it's very, very appropriate what you just said, that some sort of industry, like a strategic partnership, right, where every project that needs to have a total addressable market concept in mind, and the industry or a partner that's interested in that space, if they have some sort of stakeholder equity in terms of just interest equity in the product or the project, I think the gains both for the students that are working on the projects or the founders that are working on the concept with the industry, really knowing that they want that project to come to fruition, I think the success could be a little bit more marketable, right?
I think in industries, we typically, before zeroing down on any particular problem statement, we do thorough background study and the surveys directly coming from the consumers or the population itself. And then we also discuss about the feasibility and the desire for the consumers to pay for that service, or whether they are interested to spend their money, hard-earned money on that particular technology. So I think once we have that kind of association with any survey agencies or internally either in IIT Jodhpur or even external agencies for that particular maybe one time, that might also help, I think, in zeroing down on important problem statements. Because that is the key, because once the students set out to solve a problem which is not connected directly to the consumers, I think it becomes little difficult going forward. And then there may be a point where you may understand that, okay, this is a wrong problem statement, but you can't come back because you have spent 2.5 years or 2 years.
So would like to hear. Yes.
I'm going to make an announcement, but TNC applies, term and conditions. And that is Johari Digital under CSR activity would like to invest 10 lakh rupees for the new projects.
So, sir, you would like to share?
So I think we can take a few questions
Yes.
from the audience. And let me remind you that we also have Dr. Chandru online. So any questions directed to him and the panelists present over here, please raise your hand. Yeah.
Hello, Vijay. Can
Hello?
you see me? I don't think you can see me.
No, I can't, but please go ahead. Yeah.
I think if we can pass around the mic, I'll request my MedTech colleague to just.
Please take this one.
Hi, I have it may sound cliched, but I still would like to know your opinions, from Professor Chandru, Esha, Nimesh, as to how, how can you really inculcate or how can you create a startup culture in an environment like IIT or AIMS? Some, really focus points that would really help. Thank you so much.
Yeah, no, I think it's a good question. I think certainly true that in an uh, environment like Bangalore, where Indian Institute of Science has been, I think there is a natural affinity. I mean, there is people see this whole innovation buzz around, startup buzz. There is so students take some interest in trying to figure out what could be interesting translational problems to work on. But I think uh, I was also just going back to the topic that was just discussed about how to get a little more immersion in the real world, and I think Satyendra might recollect, of course, at BITS Pilani we had this practice school idea where students would actually go in a team and establish residence in an industrial setting for several months. And the programs sometimes would also extend for a whole semester, and so that would give you an opportunity to actually get into problems that were relevant, right? And then actually that could be brought back. Now, of course, in practice school, we also would have a faculty member going with the team, and so there would be a continuity when you came back to campus and worked on the problem further. So I think those are interesting ways in which you could get students excited about this. I think if we have fundamentally a mismatch, a misalignment, which is if all our incentives and appreciation of work done at universities is going to be focused on uh, publications and not on actual practical development, then it's going to be hard to motivate people to work on these things. So I I think both from a student and a faculty perspective, I think we have to think through how to rectify some of these misalignments, right? And the other approach that actually now we are pushing hard at in the Indian Institute of Science is that we've actually created very strong translational centers within the campus. So, for example, in sensor technology at our Center for Nano Science and Engineering, we actually have like an incubator within that center. Similarly, in the Center for Product Design and Manufacturability, there's actually another sort of incubator or translational center for AI and robotics. I sit at Art Park, where again uh, we take on some of that responsibility of going from a proof of concept to a prototype, right? And encourage sort of pre-venture startups, and then connect them with venture capital and that whole investor community who can then actually help them with a real sort of seed funding to take the idea forward. But so creating those bridges of being able to go from an idea to a proof of concept to actually a real prototype. I think if that can be done within the university, I think that goes a long way to then being able to take it on the path towards commercialization. So And unfortunately, these things can't be actually built by faculty leading these efforts. You really need to bring back people who have gone out, been entrepreneurs, and come back to lead this. So our translational research centers typically will have people who have had that experience and will bring that culture into the university. And that's a that's a very quick view of how you could get this going.
Yeah, I think all great points that Dr. Chandru made, but I'll say a couple things that I think being in Silicon Valley, you notice that culture exists in general just because of the vicinity to great universities like this place has. But in addition, I think there are some really good collaborative infrastructures that the universities have with different startups in the area, which means either there's a co-op program or an internship opportunity or a shadowing option, all these different things that allow I guess there's two ways to look at it. One is that an idea or a question of what you're trying to create can be a product, but it may not necessarily translate into a business. And those are two very different things. I mean, it could be a research, a great product, but the bigger thing is if you're trying to build a business, then you need to kind of do more than just create a great product, right? So being in touch with the industry and having that ability to also talk to private equity firms or venture caps or access to that entire environment is what will drive that mindset to think beyond a product, but sort of a bigger company perspective. And I think that creating that culture could possibly help.
So can you give some light on how to create that culture?
Just involving other stakeholders, I think,
Exactly.
like interactions and opportunities, whether it be, taking students having that opportunity to, you create industry partnerships or you create partnerships with financial institutions. For everyone, this is great brain power, of course, right? I mean, there's some very bright students here. So it's about people understanding that and being involved in it, because everyone needs to have something in it for them. So if venture caps see great ideas coming out of this incubator, they're going to be more interested and drive more products into businesses. And I feel like just opening doors to those kinds of things will lead to better businesses.
I'd just like to add that venture investing is all about risk taking, right? Is the capability to lose it all. So that is not something that industry is used to, right? It is really an individual investor who believes in the cause, in the purpose, and willing to put all the capital, investable capital at risk and hope it works. But venture investing is all about taking a moonshot in changing the game and challenging the status quo. And that is what venture capital is. So I'm not sure what ecosystem you can develop along with the industry, but that is what venture capital is, right? That is where the mindset has to change. It is not about incremental change, but it's a 10x change because venture capital needs 10x returns, not 2x returns, right? So it's just a fundamental change in the approach.
Yes.
So I think we can take the question by Dr. Ram Prakash.
Yeah, it's not actually the same question which I was putting up is the mindset actually that Professor Johri Saab also said. We are here, we are working, more interaction is needed. I really wanted to mention to the audience here, Johri Saab has been very generous that he always extend his support. He's ready. He wanted interactions. We also made the programs like that. So there is some resistance from both hands. Actually, it's not from the industry side also, and from this is my observation. Actually, being previously I was associated with CSIR CIRI, but there is a kind of a barrier which is there that has to be really bridged somehow. So this mindset has to be changed. So like Johari Digital is a partner into Technology Park here. And we have made this program that we should have monthly interaction. Already I informed to your team members there. So sometimes it's like resistance is from that end, and sometimes resistance is at this end. So, so things are actually when we wanted to move forward, actually that resistance, that mindset has to be changed. So again, like Professor Chandru also mentioned, that there is a mindset which is there in ISC ecosystem that has been built. So how we can change that? That is my question, and how we have to work actually from both hands. So to the panelists, yeah.
reply to your question, there is no resistance from our side, but we are short of manpower. And the way we can break this barrier is that you help us get manpower.
No, actually, we had a discussion with your HR also. I mentioned that you let us know what kind of manpower you need,
Yes.
how we can help you. So there was a discussion, and we were supposed to get some feedback.
That work is going on, and let me tell you, Ram Prakash ji, that we are on this, and a lot of work can be done, and there is no resistance aside. All we need is more. We are loaded with the projects, so we need more manpower. That's all.
हेलो नमस्कार जोरी सर 2018 दिसंबर में आपने एक लीडरशिप कॉन्क्लेव में भाग लिया था एम्स जोधपुर में और मैं एम्स जोधपुर में नर्सिंग डिपार्टमेंट में काम करता हूं और उसके बाद से मैंने छोटे छोटे कुछ चीज़ें बना के और कुछ लोगों से संपर्क किया बट ड्यू टू माय बैकग्राउंड उन्होंने कहा तुम्हारे पास क्या है ये तुम्हारे वाला तो नहीं चलेगा और आपने अपने नंबर भी शेयर किए थे बट उससे बात नहीं हो पाई तो जैसा सर ने कहा कि दोनों तरफ से ही रेजिस्टेंस तो है और इसके लिए फिर मुझे मेडटेक पीएचडी में एडमिशन लेना पड़ा कि कोई मेरी बात तो सुने कि हाँ मैं कुछ तो कर सकता हूँ तो हो सकता है आपसे मुलाकात हो तो उस टाइम मे बी बैकग्राउंड हेल्प करे जी सर थैंक यू
I think we can take the question by my MedTech colleague Tilak.
Thank you so much, sir. Sir, like on to your words where that the support from both sides has to be there, and we also believe, right, from graduating this program that to get it from the stage from a prototype to a business commercialization is a very big leap, and also in that we require a lot of support. So in that aspect, we just wanted to understand like at what level a technology has to be built from a lab, right, lab, whether it is a patent or a paper, because in diagnostic medical devices or an implant, that is the level of readiness that is required varies, even for a business potential for an investor that differs. So when as a startup entrepreneur, like how to get that insight about preparing oneself so that the opportunities can be laid in front.
Once you get the POC, proof of concept, it has to be made in working prototype. Once that is done, then the journey starts. How we do the designing, outer designing, inner. I'll tell you an example. Suppose you selected some IC, and we then select whether this IC would last for at least 7-8 years or not. But right now, the obsolescence is so much that we have to be very alert about it. So that is, I'm just giving you one example. And there are hundreds of examples where everything has to be streamlined to make it manufacturable. Once after prototype, we make pilot production. From that pilot production, then we do tapping of the market and find out the feedback from the market. Then we have to do regulatory affairs has to be taken into consideration. Now even India regulatory has become very stringent. We have to be registered with CDSCO, BIS, Bureau of Indian Standards certification has to be obtained, and all these things are to be done. So this is a long journey. At least you should consider year and a half, or maybe 2 years to come into real mass production.
Thank you, sir. So we have another question.
Hello, it's Deepak Arora here. I'm a faculty with the Department of Chemical Engineering. So a couple of questions. One question, actually, this is for Dr. Vijay Chandru. So Dr. Vijay, you mentioned about Reliance being interested in, in the strain life sciences in September 2021 and kind of investing quite a bit. So I just wanted to understand what was the maturity level of this technology in terms of TRL, whether it was TRL3, TRL6, where Reliance decided to sort of really be with the strain life sciences.
Actually, this was, the products were already out. So it was not in the TRL process. These were already out and selling. But I think it was more a question of timing that as I was saying, I think the various confluences of the price points associated with genomics, its relevance to health and wellness, preventive medicine, and precision medicine, and I think Reliance, in some sense, is building out an entire health vertical, and we had already done the R&D, and in some sense we had a created market, because these were all new markets that were created. What was left was really scaling, and this scale up, of course, both requires resources plus in terms of financial resources, to be able to set up the mass scale manufacturing, but also to be able to the outreach, and obviously Reliance has that ability to take it through their retail, through their entire sort of geo health platforms, far and wide, and I think that's where they saw the opportunity, and they needed this omics piece, so the technology capability to develop these new age therapeutic approaches to fit into their plans, and I mean it's so these were not. I mean, we were not. There are some R&D aspects going on still, obviously. I think one of them is in this whole field of liquid biopsies and being able to have early detection of cancers and so on, which will be, as we're already seeing companies like Grail and Guardant and Foundation Medicine in the West, starting to make a headway into these areas. I think there's a potential to do that here, and of course, Reliance is a master at taking these technologies at population scale. So I think that's the potential here that we are exploring together. But in terms of R&D, I think we will be continuing to focus on cost optimizations, because I think these, if we can deliver a good diagnostic for a cancer patient, where we analyze the tumor and actually pick the right medicines, and we can deliver that at, say, under 10,000 rupees, right? That then would be very valuable, right? So the test I was talking about, the Genomic Insights test, is certainly already there, right? Where we can analyze a whole exome and actually provide those insights. So at those price points, I think then the scale up is possible. So I think that's where you see, if you think about even telecom, right? When we built this computer and we were looking at smartphones and the possibility in the late 90s, early part of the millennium, we were not even thinking about telecom at the scale that we are at today, right? And so it's also sometimes a question of timing, and that when is the right time to scale things. But for India being probably the most expensive for telephony at the turn of the century, today is probably the least expensive in the world, right? Today, when you talk, it's almost for free, right, on the phone. So I think that sometimes you just have to ride the wave at the right time, and I think that's and I think that time has arrived now for genomics. Is the assumption that I think from our side, and as well as our strategic partners' side. So.
All right, thank you, sir. So I think we can take up more questions after this. We have a poster demonstration so that you can interact with all the panelists in much more detail and have a one-on-one session. So thank you for that insightful session to all our distinguished speakers. Thank you, Dr. Chandru, for joining us and being patient with us. And thank you, Dr. Kalra and Dr. Jha, for moderating this session so beautifully. As a token of our appreciation and thanks, I would request Dr. Kalra to present a memento to our guest, Mr. Nimesh Ray. Thank you, Dr. Kalra, for presenting a memento to Dr. Tiwari. I request Dr. Kalra to present a memento to Mr. Nimesh Ray. Thank you, Dr. Kalra. Now I'd request Dr. Jha to present a memento to Mrs. Isha Ray. And I'd request Dr. Jha to present a memento to Mr. Johari. Thank you so much, sir. Thank you, ma'am. Thank you for that session. And our sincerest thanks to all our distinguished guests for the day. We're really grateful for your time. And I'm sure that all of us here have benefited from today's lectures and discussions. We look forward to a promising future of advanced healthcare through innovations in medical technologies. I request the guests and the audience to visit the scientific hall where there are posters displayed showcasing the ongoing MedTech projects, followed by a lunch. So thank you for joining us today. Have a good day. Jai Hind. Thank you, Professor Chandru, for joining us.
Thank
We
you.
hope to see you in person very soon.
Yes, we'll try to come soon.
Sure, sir. Thank you.
Thank you. Bye-bye.
चैट में क्या है देखा चेक करो चेक
Hello.
Hello? Huh? Hello? 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 Good afternoon, everyone.
Check, 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 check. One.
Very good afternoon, IIT Jodhpur. Today, we are on the second day of the industry conglomeration meeting, I should say, rather, than an industry day. So we have met many friends, colleagues. We have heard them for a while in different sessions. Today, we also will like to see another facet of the industry where future thought processes on being sustaining in their own missions will be captured basically. So here today we do have a thought process over to your screens. On almost onto your center, there is a thought process on technologies for sustainability. Now, we are IITs, and we are known for, having nurtured young minds who are or who will also be torchbearers for some of the most important technologies which are taking shape today, as well as yesterday, as well as for the last many years. It has been happening, and now it has grown or propped up, right? Because we are joining hands in a big in a big manner with what do you call the modern industries. Why modern? Just because of the fact that they have a foresight to sustain. Again, this word sustain is coming again and again. You can see why. Because in order to capture the markets across the globe, they have to follow some of the rules and regulations and limitations. They have to, jump over and therefore sustain. As well as when we are speaking about, industries, they are not only having silos in the cities. There are also industries in the rural environs of India as well as the world at large. And everybody, even the tiniest entrepreneur, thrives, who is an individual, who may be a simple cobbler even. He thrives just because of his passion to do so, as well as to take on the risk to do so. And when we are speaking about the thought processes of sustainability, United Nations comes out with, 17 different goals. And those have a great impact on the industries, on the lives of simple people living by, as well as our environment as well. So in that regard, we have all these 17 important parameters, from starting all the way from zero hunger to partnerships. Partnerships means that today I'm having my hand in glove with the industry, hand in glove with my environment, hand in glove with the energy aspect of it, hand in glove with the climate change, hand in glove with gender equality, hand in glove with the water we drink, hand in glove with, almost everything, right? So sustainability is there everywhere, right? So today, not wasting much of the time, I will now go towards introducing the actually, I should say the person who will show us or guide us towards thought processes on sustainability today. So I welcome all of you, all my colleagues here, students, members of the industry who are here, as well as teachers, because I am also a student. So learning is a passion. So we need to learn almost every day. So here we are introducing Professor Veera Raghava M. Charya from the Center for Rural Development and Technology, IIT Delhi. So he has been a professor at the CRDT, IIT Delhi, from the last many years. He is interested in principles of sustainable design. He focuses on various aspects such as sanitation space, infrastructure. But he has not left his motherland's traditional knowledge that each one of you might take roots back from. He has been into industry and has been guiding industries as he has been a spinner out of industries. So it is a great joy to listen from a person completely holistic in the thought process of bringing industry and traditions as well as people, as well as students, as well as, organization like IITs forward. So he is a co-founder of Joy is Yours for the last couple of years, or more than that. He has been in the National Task Force for Rural Housing for India. Presently, he also, guides ACOM Eco Solutions. By the way, you should know that he has been a senior sustainability fellow at Arizona State. He had been at the National Academy of Sciences as a peer science awardee, as well as he has been as a Fulbright fellow professor at Arizona State University. And after all, right, you're also listening to an excellent teacher at heart for the students. So I may not, take much time to welcome over to the stage Professor Veera Raghava M. Charya. Thank you.
Thank you, Anand. Can I borrow the mic?
Slides?
So if I do not speak from the stage and if I come down, can I request some of you also to come down? Only if I come down. No, otherwise you don't come down. Okay. If I speak from below, how many of you are willing to join me? यदि मैं नीचे आऊं तो कितने लोग आप लोग हिलने को तैयार हो? How many? How many of you are willing to take a seat which is empty ahead of you? How many of you are courageous enough to take a seat which is ahead of you and empty? Ashish Ghorpade is courageous, very courageous person. Welcome, Ashish. Wonderful, wonderful. What about some more empty seats? Some more people who had an additional imarti, an additional rasmalai. जिसने ज्यादा खाया उसको उठना ही पड़ेगा पीछे. You can wave to me, the last row. Can the last row wave to me? That is the imarti rasmalai row. Please come down. आइए थोड़ा. आइए दिख रहा है मेरे को इमरती. X-ray vision. Come on. Can you move, Imarti? Can Imarti move? Or can it not? Yeah? No. Imarti refuses to move. Great. Any Imarti which wants to move, please feel free. Can we have the slide? So, my dear friend Anand has introduced me as my brother actually. My brother's name is Veera Raghavan. But maybe as he was growing up, Anand's, maybe this word Veera Raghavan is imprinted in his mind. So he's introduced me as my brother, who's in Mumbai right now. But that gives me an opportunity to joke with you. And after lunch, in any case, I always get the speaking slot after lunch in many, many parts of the world. मैं कहता भी हूँ कि आधी रोटी कम खाओ, लेकिन कौन सुनता है? तैयार नहीं है. अभी भी तैयार नहीं. देख रहा हूँ. Yeah, it's wonderful. It's really very, very happy to be here with you all. And feel free to stop me at any point of time, particularly if you're a student. Do not feel intimidated by the gray hair, by the degrees, by the awards, by the positions of deans, directors, etc. Sometimes you know more than every degree. Yeah, sometimes unfinished degrees know more. Yeah, sometimes the junior engineer knows more than the superintending engineer. But I don't know, the departments don't behave like that. PWD does not behave like that. Yeah, I hope you will not feel hierarchical. I hope you will shatter hierarchy. That's important, isn't it? Liberal arts is agreeing with me here. There's too much of hierarchy in industry day. That is why Anand called me here, to shatter the hierarchy. Please feel free, Imartis, Rasmalais, to speak up whenever you. Yeah, it's lovely to be here. Please call me Vijay. That's my email address and that's my website. If you write to me, I guarantee you will get a response. Please do write to me. At the end of this talk, if you have any questions, any comments, yeah. The next game-changing idea in technologies for sustainability, please do write. Welcome all sustainability champions to this post-lunch, post-Imarti, post-Rasmalai session in Industry Day. I call you a sustainability champion. Any of you here, sustainability champion? One of my gurus used to say, नालायक ही लायक है. तुम लायक होते तो तुम्हें नहीं सिखाता. तुम नालायक हो, इसीलिए मैं सिखा रहा हूँ. और नालायक ही लायक है. So like that, I don't know whether you are or not. I'm calling you a sustainability champion because we're all deeply conscious, whether we realize it or not. We are all deeply conscious about sustainability. We are deeply aware of the sacred relationship that each one of us have with the planet and with each other. And we are all interconnected. It's not separate. Yeah. Sometimes when we pursue disciplines in departments, etc., we separate soil, water, air. Civil engineering mein hota hai, soil quality, water quality, air quality, and none of the qualities talk to each other. And then we make a big mess. And then somebody has to tell us from the UN, oh, please talk to each other. And then maybe we start talking to each other. Kyun Rohan Sutaria? Yeah. So we have a sacred relationship with sustainability. Yeah. Now a question for you all. Yeah, Panch, please. Yeah. So over the last 40 years, I think the mean age in this hall must be around 25, 27. There are very few people above 50 in this hall, less than 10 people probably. But you've seen life. Even if you're younger, you've seen life through. Welcome. Yeah, there's a seat right here for you. We kept it for you.
Thank you so much.
Yeah. No, welcome. Yeah. So over the last 4 years, yeah, this question is for you. Over the last 4 years, that there has been a complex challenge. Yeah, with quality of our environment.
Absolutely.
Yeah. Over the last 4 decades, there has been a complex challenge with health and livelihood. Absolutely. With social relationships over the last 4 decades. Yeah. Complex challenge. And one more. Economy, technology, and the word that is not meant to be mentioned in Industry Day, politics. Unmentionable word, Industry Day में blank out किया हुआ है. पता नहीं कैसे आ गया. Screen पे tape क्यों नहीं लग रहा? Is this a challenge that we are facing? 4-fold challenge. Quality of environment, health and livelihood, social relations. Is this only the neighboring country's problem? उसकी हालत खराब तो हम अच्छे. Is it only the neighboring country's problem? Is it only if you're from Karnataka, Tamil Nadu's problem? Whose is it? It's our issue. We face a complex challenge. You all agree? Yeah? Government agrees. Sarkar? Huh? Agree karta. Wonderful. Next. Yeah. And is this challenge only in the developing world or is it a global issue? Is it only in the developing world that the problem of health and environment, economy, technology, politics, relationships, livelihoods. Is it only that, a developing world problem? Huh? It's a global issue. Yeah. 1 minute. Go back, Sandeep. Yeah. Parts of France burned, Greek economy, economic growth slowed down in the US. Yeah. We are all wanting to, isn't it? जितना भी H1B वीजा मिले, जितना भी ग्रीन कार्ड मिले, हम सब लपेटना चाह रहे हैं, लेकिन वहां पे वही हालत है, वहां पर भी वही हालत है, यूके. या सो आर द एक्सप्लेनेशंस इजी? नेक्स्ट. या नेक्स्ट. सो इज द कॉज अंडर डेवलपमेंट? इज द कॉज ऑफ दैट प्रॉब्लम health, livelihood, economy, technology, politics, social relationships, quality of environment? If we develop more, if we industrialize more, it's industry day, IIT Jodhpur. IIT Jodhpur, are you listening? If we industrialize more, are we going to get rid of those problems? Probably not. Huh? We are in the Indian Institute of Technology. Please listen to me. We don't listen. I don't know how liberal arts happened in the IIT system, but we don't listen. We don't listen. And I know you're from liberal, but I'm not from liberal. Thank you for coming. This is also from liberal arts. Yes, I can see. Is the cause underdevelopment or development itself? Is it overconsumption? NTPC सो रहे हो या जागे हुए हो? जोशी मठ नीचे गया क्यों? Are we willing to listen? In industry day, is it overconsumption? Is it inequity? Is it all of this? Could this all have been designed a little better, less wastefully? Please think about it. The issues are not far away. It's not in Joshima. Issues not far away. Yeah, next. So the challenge is, Punch. So we have wasteful energy consumption. Do we have wasteful energy consumption on this campus? Please think about it. It's very important because sustainability will not happen by thinking about Pakistan's issue. कि पाकिस्तान की इकोनॉमी टूटी हुई है तो हम अच्छे हैं. हमारी टूटी हुई है, हमें उसे ठीक करना पड़ेगा. टूटी नलका. Wasteful water consumption, and sometimes we have fantastic technological solutions on the right. Look at the technological solutions. Wasteful energy consumption. How good do you think is nuclear power as a solution? Wasteful water consumption. How good do you think is? Welcome. There are seats here. Kept for you. Yeah, second row. Yeah, can you push inside? Yeah. Sanitation and 1 billion toilets. We have Gandhiji's Chashma powering that campaign. Not Gandhiji, only Gandhiji's Chashma. Gandhi is too dangerous a person. His Chashma is sanitized and clean. We can use Gandhiji's Chashma. So we want 1 billion toilets. Lack of leadership and mistrust. So we'll have more missiles and bombs and nuclear proliferation. Solution? How many of you think it's a solution? Young people, Instagram generation, TikTok generation, poisoning of the natural environment. We'll develop more special technologies, nano, biotechnologies, metaverse technologies, which will affect the ecology in unknown ways. I'm sorry, the emoticon didn't show, but are these solutions more dangerous than the original issues they were trying to address? What do you think? Over the last 40 years, we have used some of these solutions. Are these solutions or are they dangerous? Imarti, what do you think? Back there. Imarti row. Imarti is working very hard inside. Next. So, Anand mentioned 1970, the world over became, enamored with this term called appropriate technology. Gandhi, Schumacher, the book called Small is Beautiful became popular. Rachel Carson, Silent Spring became popular. I know there are several people from civil and environmental engineering here. In 1987, the UN talked about sustainable development. In 2010, we started talking about climate change and global warming. What are we talking about today? 13 years after this. Nearly 52 years after we started talking about appropriate technology. Are we talking about this term? Circular economy? That's so nice that we're talking about circular economy, because on the day we had a call to discuss this meeting, I had a small remark that I made to Anand properly, and therefore the mitti ka kullad that you see here. This you have not seen in any other session in industry day other than this session. So this was triggered. Yeah, do you all see this? Imarti, do you see it? Rasmalai, do you see it? So we have to go towards circular economy. But it's called MKG, Majboori Ka Naam Mahatma Gandhi. Only in the session on technologies for sustainability, Majboori Ka Naam, we have reduced him to that, no? Have we successfully reduced Gandhi to Majboori Ka Naam Mahatma Gandhi or not? Circular economy. Choice. There is no body of water which is blue which I can take my grandchild to and convince that this is a lake. वो मेरे को बोले कि गंदा नाला है, लेक का है. Welcome, welcome, welcome. You're on time. Welcome. Welcome, sir. Yeah. Next. So what do we want? Which system would we want? Left or right? Please say it out loud. Left or right? What are we moving towards? Yeah. And why are we moving towards that? So we need to question this very deeply. Why are we moving towards very fragile, very vulnerable systems? And why is Mahatma Gandhi Majboori Ka Naam Mahatma Gandhi? That also we need to question. Because if we try to question this only from a technological perspective, कि मेरे पानी में fluoride क्यों, तेरे पानी में arsenic क्यों, I will not probably be able to figure out a solution, an elegant solution, a sustainable solution. Yeah? Next. Yeah. So what do we need? So do we need solutions only from technology? I have not written only. Do we need solutions only from technology and economics? Because industry day means probably a solution which is only techno-economic. How many of you think that a techno-economic solution to health and environment, yeah, livelihood, economy, technology, politics, social relationships, how many of you think a metaverse solution for the problems that we just listed? How many of you think that we will need to listen to some poetry? No, it's fine.
We're streaming now, so.
Oh, it's creating a problem. So you want me to have a column? Okay, thank you.
Hello.
Yeah, next. Sandeep, next. Yeah. So do we need, so is a solution only from a technology and economics perspective likely to be adequate? Or we need solutions from a radical new perspective? Is it okay? Thank you. So what would you like to hear first? Happy news or next? Punch. What would you like to hear first? Professor Lipika De, what would you like to hear first? I'm seeing her after so many years, after IIT Delhi campus, maybe 10, 12 years later. Welcome. Anyway, she asked for terrible news, but I'm sharing some good news. Okay, the good news is that if you look at with respect to sanitation, because I've been trying to work in this area called sanitation for the last 2 decades or so. And no, go back. So there is a lot of startups. So good news, because industry day, we have to talk some good news, no? Industry experts are here, isn't it? Or IIT Delhi expert. IIT Jodhpur expert, yeah. Also IIT Jodhpur expert. So some good news is required, no? industry day cannot all be bad news, right? So that's why even though Professor Lipika, they asked me, for bad news, I'm putting good news in it. Maybe later it's coming. You're a very perceptive person. Okay, so India is seeing a lot of startups. One of them is here. I would like to introduce Uttam Banerjee. Uttam, please stand up because I am learning from my students. My former student at IIT Delhi and a very courageous entrepreneur, because in the era of Swachh Bharat, it's very difficult to do entrepreneurship in sanitation. That, he'll explain when he gets a chance to speak. And the other startup person also who's working on clean air, Rohan Sutaria. We don't have to waste time for Anand to introduce him later. So he's an amazing guy working on clean air based out of Pune, grew up in Mumbai and working on clean air. Welcome, Rohan Sutaria. So there are amazing people who are in this list actually like this, working on how to improve the habitat. Some of those names are listed there. Next. And there are many more, right? And there are, if you go to Pune, you will find the Kagad Kachpatra Kashtakari Panchayat. You will find Almitra Patel, a 90-year-old woman who's fighting for improving the quality of air in Bangalore. Ekam Eco Solutions, I just mentioned Uttam Banerjee, C. Srinivasan from Velur, Indian Green Service, not the Indian Administrative Service, not the Indian Forest Service, not the Indian Foreign Service. He set up something called the Indian Green Service. Yeah. Next, Ravi Agrawal of Toxic Link and many, many more. There are many. But this is a picture that nobody wants to show anybody, isn't it? Is this a Photoshop picture of Taj Mahal? How many of you think this is a Photoshop picture? I Photoshopped it. How many of you think I am urban Naxal? ऐसा फोटो कैसे दिखा दिया? ये urban Naxal जरूर होगा. Liberal arts, you're smiling. ऐसा होता ही नहीं है, कभी नहीं हुआ भारत देश में. गलत है. It's there. How do we see it? Yeah. Does not mean that because I showed this picture, I voted for X party. You cannot conclude. But we make mistakes like that in our thinking. In engineering, we don't learn critical thinking anymore. We don't learn critical thinking at IITs anymore. If we make assumptions like that. Yeah? Yeah. So there is a great opportunity. That picture is both a crisis and an opportunity. What is the opportunity? The opportunity is that because by 2025, in 2 years from now, 3.4 billion people will be living in countries defined as water scarce. And will it require only a technological and economic solution? What do you think? Industry day. Will only a technological and economic solution be enough, or we need a cultural solution? We need an ecological understanding of what is our relationship with this planet. And maybe a technological solution can be a part of that whole solution. Right? People say that in Europe, married where men and women don't live together. And the government thought that maybe if we give them tax, some tax incentive, that you have to pay 30% tax less, the husband and wife will live together. Do husband and wife live together if you have a 30% tax saving incentive? That's an example of a technical or economic solution. And sometimes we need more elegant solutions than coercive technical economic solution. Technical solution may be part of the solution, but may not be the entire solution. So one such solution is a waterless urinal, which we encourage IIT Jodhpur because it is in a very fragile zone with respect to water to implement. If there is anybody here who is involved with water conservation on this campus, I request you to look at any brand. We are not promoting our brand here, though we are IIT Delhi. We started up, we incorporated a company next. We launched, we'll talk about that. Yeah. And so the issue is not only scarcity of water, whatever water you have, which is surface water and groundwater, is highly contaminated. It's not fit for animal or human consumption. Yeah, sewage is leaching into groundwater supplies. Next. Yeah, thousands of small factories dump untreated sewage industries into rivers. Toxic waste is being mixed with fresh water. Central Pollution Control Board, Sarkar, says only 160 out of 8,000 towns had both sewerage systems and a sewage treatment plant. Right? We produce 40,000 million liters of sewage every day. Only 20% of it is treated. It is a ticking health bomb, says the Center for Science and Environment, across the country. It's an issue, isn't it? Next. So do we only need more urinals, toilets, garbage bins? That is like the tax incentive to keep the two live-in partners together. Will only urinals, toilets work, or at the end of the urinal we'll need something? At the end of the toilet we will need something? Or does it call for something much deeper, much more fundamental? That's the question, because my interaction with you all, with all the Imartis and Rasmalais, is about questions. It's not about answers. If you go back today and you have more questions, I'll feel very, very delighted. It's not about answers. Yeah, next. Yeah. And if you look at wastewater, interestingly, like a child, right? If we learn to look like a child, then the child will say, oh, wastewater mein namak hai, wastewater mein nitrate hai, phosphate hai, potassium hai. And maybe if that nitrate, phosphate, potassium is extracted, it can go back and grow some other plants. It need not be dumped into the Yamuna or the Ganga, everybody whom we treat as a goddess, it need not be dumped there. Next. And we can look at that recovering the nutrients from wastewater, using them back into agriculture. Historically, people have been using wastewater in agriculture. It's called sewage agriculture. And that's a 4-step process. Go back, Sandeep. 4-step process: source separation, containment, sanitation, and recycling. And that's possible. And our food systems will be a little more sustainable if we are able to take back nutrients from wastewater and put them back into agriculture. Next. Right? So there are two things involved. One is what we call, because in sanitation, it's important to do two things. It's very important. When we have a urinal or when we have a toilet, the most important thing that we want to do is we want to destroy the pathogens in the fecal matter. Fecal matter has pathogens. That is why we do hand wash after defecation. Urine has very little pathogens, actually. That is why we had a disciple of Mahatma Gandhi, Majburi ka naam Mahatma Gandhi, who used to practice something called auto urine therapy, and he called it one of the magical remedies. Morarji Desai, he was one of the prime ministers of India, independent India. So urine has no pathogens, fecal matter has all the pathogens. So what do we need to do? We need to ensure, yeah, that's right, source separate. If you can separate the liquid, that person has a solution there. He says separate it. If you can separate the liquid and the solid and treat the liquid separately and the solid separately, then you can extract nutrients. Next. Yeah, but it's not only about latrines. It's yellow, brown, gray, rainwater, organic waste. All these things can actually give you resources. You can get liquid dry fertilizer, you can get biogas, you can get irrigation groundwater, you can recharge the groundwater, you can do all that. You can use the biogas leachate for improving soil. Next. Yeah. So 700 million rural Indian people, IIT Jodhpur. So each one of you is a rural person now, isn't it? 25 kilometers from civilization, from Dal Bati Churma, from Imarti, from Rasmalai. Huh? Yeah? Go back. 700 million rural Indian people, pee and poo, urine and fecal matter, is 350 million tons of organic fertilizer each year. Next. And its worth is 1.8 billion US dollars. Next. Global human waste estimated to be 8.5 million tons each day. Its economic worth annually is 20 billion US dollars. Nobody is evaluating the startup. There are so many startups who got evaluated in your industry day yesterday. And some of those startups, Daily Hunt, etc., you know, in informal lunch says, valuation ki chinta mat karo, apna dal roti khamao, khalo, you know, sukhi raho. Vijender Gupta, who was a speaker at your plenary on the inaugural of the industry day, when he was having an informal conversation, he says, you know, simple businesses are better, do not chase valuation. I'm not talking about valuation, but I'm talking about valuation of a different kind here. That, you know, what we do not look at as a resource is a resource. And it's flowing down IIT Jodhpur's urinals and toilets. What can we do about it? Will we wait for Stanford to do something about it? And then say, now I have a collaboration, so I will mine nitrate, phosphate, and potassium from Jodhpur, because now Stanford is doing it. So we need to be a little more original than that. Next. So is all this waste? Whatever is happening in the urinals and in the restrooms, do you think that's waste? I was at a talk invited by the Principal Scientific Advisor's Office, and they had a board there called Waste to Wealth Mission. And I said, the first thing that you need to do is you need to rename your mission, because there is no such thing called waste. You're saying waste to wealth. So why call it waste to wealth? First, you'll call it waste, and then you will say that I'll convert waste to wealth. Complicated, no? There's no need. Actually, there is no such thing as waste. Urine, fecal matter is not waste. It's actually resource. Next. Is it waste or resource? Next. Yeah. So there are elegant technological solutions, but technological solution, along with the technological solution, we'll probably need a cultural solution, a literary solution, an imagination solution, a peaceful solution. Technology cannot be the only part. And this is an IIT Delhi patented technology, which happened with a PhD thesis around 2007-8. 2009-10, we got the patent. We did a couple of technology transfers. I must have attended some industry day functions in 2009, 10, 11. And we did some technology transfers, and we found that the industry was not good enough to actually implement it as passionately as the innovator himself wanted to do it. And then I found my student, who was a student of the Master of Design program, working in a good corporate job, but with a lot of security. Crompton and Greaves, he was working in Crompton and Greaves Global R&D in Mumbai, and he quit that job because he found that the job was too repetitive, and he came and we shook hands together, one faculty and a student, and I continue to learn every single day from my student. In these 9 years, or now it's going to be the 10th year of operation of Ekam Eco Solutions, we have installed hundreds of thousands of these waterless urinals across different parts of the world, each single waterless urinal saving 151,000 liters of water, fresh water per urinal per year. We have not yet been able to crack the women's urinals before the liberal arts raises a question. 1, 2, 3, at least liberal art, 4, yeah, before they raise the jhanda, We sunk 10 crores of non-DST, non-DBT money, more than, not 10 crores, sorry, more than 1 crore we spent our own money to try and develop a product, but it requires even more money. We don't yet have it, but we hope to come up with a product for women as well. Because anatomically, we need to design a different product for women, which is slightly more complex than the standing implementation, which is easier for men. Next, yeah. So no consumable, frugal innovation, no consumable, no chemical, eliminates odor. Go back, Sandeep. Yeah, it doesn't take any power. So it is very different from the European and American innovations, which are all power-based, enzyme-based, chemical-based. It retrofits. It's very Gandhian. It retrofits. It doesn't say, मेरे पास एक solution है, तू अपना ceramic निकाल, ceramic भी खरीद और waterless urinal भी खरीद. Contractor driven. It's not contractor driven. It's user driven. You have a solution. You have a problem. We'll fix the problem with your own infrastructure. Okay. Low cost, low maintenance. Go back, Sandeep. Low cost, low maintenance, and saves over 100,000 liters of water per urinal per annum. Do visit ekameco.com for many solutions. If you have a pet at your home and you find that the typical floor cleaner that is used at your home, your pet is allergic to, so we have developed pet-friendly cleaners also. Because the cleaners that we currently use in our home, I have nothing against Reckitt and Benckiser, okay? But I'm just giving brand names because we all know brand names. So Dettol, Harpic, Lysol, Domex, many of these are actually pets develop allergy, children develop allergy. So the cleaners that we have developed, I'm not going to show the Ekam Eco website because of lack of time, but we have developed a whole range of solutions. Yeah, go next, next, yeah. And that's how it gets installed. Early on, we installed these waterless urinals at IIT Delhi for many years. Yeah, next, yeah. We installed waterless urinal kiosks for harvesting urine. We don't only do water harvesting. We were successful in doing urine harvesting at IIT Delhi, at National Institute of Rural Development, Hyderabad, etc. Next. Yeah. So we need to ask whether we can continue with this linear model of Yeah. What is the linear model? Resource extraction, manufacturing, distribution, consumer. That is, consumer is Imarti and Rasmalai. Yeah. Consumer, do you see yourself there? The last row. Yeah. And then resource destruction. Can we continue with this? Is it possible? Next. So is this an option? This is a technological option. It's a techno-economic solution. Landfills and incinerators. How many of you live near a landfill and you love it? How many of you? Yeah? Any of you live near a landfill? Passed by a landfill and love it? That same person. Yeah. He said. Are you a postdoctoral scholar or faculty? Or postdoctoral fellow. Yeah, I can see it. I can feel it. Yeah. Postdoctoral fellow who lived near a landfill and hates it. Yeah. So it's not an option, isn't it? So we think that these are very good technological. It's technology. Many people say this technology. It's an economic solution. It works. And then the National Green Tribunal will have to strike it down. And then the landfill will take time to strike down because it's one of the biggest mountains of Delhi. Every city has a landfill. So what are we going to do after Industry Day? Let me put up, what are we going to do after Industry Day? Imarti, kya karenge hum? Yeah, landfill is not an option. Incinerator is not an option, right? Because there are mountains of plastic that every event of ours is generating. Yeah. So can we sort of, take our own, we should not wait for the government to circulate a ban that, plastic bottles are banned. Therefore, we don't consume plastic. Yeah. Take a pledge this, take a pledge that. Vigilance, take a pledge lo. Hindi Divas ka pledge lo. Re, kitne lenge? Next. Yeah, so we need to ensure health of water bodies. We need to ask this question because it's linked to other questions. Water is linked to energy issue. How much energy do we really need? Because a lot of our water is hydroelectric. A lot of our power is hydroelectric. We are interfering with river flow to generate energy. So we are having stories from Joshimath. We are having similar stories from Himachal. We are having stories from Kashmir. And we are talking about technology. But technology, how are we talking about technology? Are we looking at the intended and unintended consequences of technology use over the last 30, 40, 50 years? Are we questioning? Are we asking these questions? What should be the mechanism of energy generation? Is natural flow of rivers important? Should drains also, nale maybe, should there be natural flow? Should watersheds, should there be drainage encouraged in watersheds because that encourages silt distribution, fertility management happens, and overall cycles of carbon, nitrogen, phosphorus, potassium. What is happening to those cycles? Are we asking these questions? Next. Yeah. So we'll stop here. We are trying to link up to another issue. Yeah. Because we don't only want to talk about sanitation. I know I'm at 2:53. I may be very close to the end of my time. But similar issues you see, this is in the textile industry. You see weavers, you see farmers in Vidarbha. And this is from, I remember right from the time I was a PhD scholar, I remember when I've been traveling to the Vidarbha region, there are farmers committing suicide and there are weavers committing suicide. Right? And, if you look at the government information, there are good schemes for farmers to cultivate BT cotton, and there are good schemes for weavers to technology upgrade or technology modernize, etc. But the number of suicides has not gone down. Over the last 20 years, I am aware, farmer-weaver suicides have not gone down significantly, irrespective of whichever government is in power. So is there some systemic issue? Are all sectors of the cotton textile industry in trouble, both weavers and farmers? And we need innovative solutions. Where are those solutions going to come from? In the context of history, go back, next, yeah. And Jodhpur is a city, Bandhani, isn't it? Women, yeah. Jodhpur is known, Jaipur is known for natural dyes. And those are the kinds of beautiful technology that we have had in this country for hundreds of thousands of years. Next, yeah. So you get fragments of Indian cotton like that from Egypt from 12th century, which are all natural dyed, well preserved, beautiful, small batches, diverse qualities, whatever be the quality required. So if Indian textiles is in a crisis, is it a technological issue or is it an economic issue or is it a different kind of issue? Or is there some political things that happened for 200, 300 years? Our back was broken. What exactly happened? Next. So there is a new kind of technology that has been developed by a beautiful enterprise run by Professor L. Kannan from IIT Madras, and I have been part of the textile working group for 30 years looking at the issues. So sometimes structural issues such as the textile crisis, farmer weaver suicides need to be studied for a fairly long period until you can actually develop a wonderful technology solution. Next. Yeah. So it's often referred to as a sunset industry, textiles. You go to Sualkuchi, you go to Assam, you get Muga silk, you look at the weavers, you will find them highly famished, malnourished, and they're working for 14, 16 hours at their handloom. They get 100 to 150 rupees wages a day at the end of a whole day's work, and they are producing some of the world's best fabric. Yeah, and it's referred to, textiles is referred to as a sunset industry. If you ask a weaver whether you would like your son to be a weaver or daughter to be a weaver, they will absolutely say no. If चपरासी की नौकरी सरकार में मिलेगी तो भेज दूंगा, weaving नहीं करना है. Next. Yeah. So, but if you do the economics, you will find that cotton costs around 70, 80, 90 rupees a kilogram. And yeah, the retail price of the shirt can be 2,100, it should all add up like that to 2,100, whether it is a sari or a shirt, it appears as if there are good margins, but where does it all go? Yeah, next. So it's interesting. It's not sunset at all. If you take a look at if you can develop a different kind of technology or a techno-economic system. Next. Yeah, I'm not going into the details here, but there is a methodology called micro spinning, and do visit the website www.microspin.in for an amazing transformative solution, which is not only technological, which has looked at it very ecologically. There's a small video that we'll play. In case the video plays and the sound plays, we'll do that for you. Otherwise, I will send the link to Anand and maybe that can be sent to you. So a lot of things can be done. So, the long lead times are responsible, big inventories, high capex, expensive marketing. Because all the time you go to buy something, you see a 50% off or buy 2, get 3 free. Do you see those slogans for shirts? Yeah. So that's creating a very artificial kind of crisis in the textile sector. So if you go for lean manufacturing instead of mass manufacturing, your lead time becomes smaller, your scale becomes smaller, your in-process stock is lower, you can make quick style changes, and therefore micro spinning makes all of that possible. It breaks the bottleneck of scale, promotes quick changes, and there is technology, but technology is not the only thing which is really getting the solution. Reduces power. Yeah. So frugal innovation, no baling required. This is a very colonial process of baling because cotton used to be transported to Lancashire and Manchester, and we are following a very outdated technology. We don't need to do, sorry for the typo there, that should be frugal innovation. No need to do bale opening. Yeah, the bales are torn open at a mill. We don't need to do complicated blow room operations. Yeah, and don't need to do mill carding because conventional carding machines are very complex. And if this machine goes down, then the whole mill is down for days and weeks actually until it is repaired. No mechanism overkill, and you can actually, so there's a small video because I love video. I love using video resources. So allow me to play this short video. Hopefully the sound will reach you. Video is not playing. Okay. But do look for micro spin on YouTube and you will find a play kar payenge? If you have any questions other than jalebis and imartis, if they want to ask any questions, please feel free to ask. करे तो चलेगा, time भी थोड़ा tight है. करेगा? Oh wow, that's nice. दिखा नहीं रहा. It's okay. It's okay. It's okay. It's okay. It doesn't want to play actually. Technology. नहीं YouTube से ही है, YouTube से ही है. You want me to go to the internet and copy that link and play it? It's okay because we are also a little bit tight on time. So is it all right that I jump the video? Oh, I'm sorry, got opened something else. Yeah, pardon me that the video didn't play. I'm sorry. Yeah, so there are many innovations, and this is a lean textile unit developed, powered by Professor L. Kannan, who's a professor of practice, a distinguished alumnus at IIT Madras. Do look him up and do look up Microspin for an amazing lean manufacturing technology that can potentially revolutionize our handloom sector in India. Yeah, it has not really been taken up with as much encouragement as should have been possible by the Ministry of Textiles for reasons that are best known to them. I don't know. Yeah, next. Yeah, it can employ people. Capex required per person is 80,000. Revenue, these figures are little part-time employment, 10,000 rupees per month for the farmer. So that's the and very profitable. The video would have shown that, but we'll try and send you a link maybe to Professor Anand, and maybe that can be sent to you all. So that's the opportunity with frugal innovation and looking at things from a systemic perspective, not a sunset industry, but a new dawn. Next. So we need to understand sustainability a lot more. Is sustainability only about environmental engineers and civil engineers? And how many of these people sustainability deals with? Planners, engineers, designers, architects, consumers, corporates, lawmakers, justice system, economists, social scientists, artists, thinkers. Each one of you here, does sustainability have something to do with you? Or is it for somebody else? Bhagat Singh पड़ोसी के घर में पैदा हो. Sustainability, whom does it have to deal with? Anybody? I don't hear a single voice. Our education system first get rid of our vocal cords. I believe in this. Our primary education system is very good at removing people's vocal cords. They become non-vocal. How many of you think that our vocal system has been interfered with? Yeah, one vocal cord is alive. Yeah. You need a mic. Yeah, we'll give you a mic. Yeah, if you have a vocal cord, we'll give you a mic. Yeah, thank you so much. Yeah, I've been waiting.
So anyway, this sustainability, when you think about it, obviously we are talking about, and you just mentioned about policies. I work in kind of electronics. And from electronics, you have a lot of electronic waste which kind of is generated. And when you say landfills, I don't know what is the percentage of electronic waste which is very high. So all the computers, fridges and everything, they eventually go to landfills because there are no proper mechanisms of true recycling. So that is one area which I have taken up for last 10 years. In fact, in 2011, Ministry of Electronics and Information Technology, actually they made this first electronic waste regulation for government of India. So before that, actually, it was not even official.
So sustainability deals with you.
Certainly. So when you say,
if you don't mind, because I'll have to close my talk a little.
Yes.
If you can summarize what you want to say.
Yeah. So for me, the electronics itself, if I talk about, the way we produce electronics has to be sustainable. And whenever we use materials, if they come from nature, they're part of nature. Probably if that is more like cultural aspect, where if something comes from nature, it will easily go and decompose in nature. If we think in that direction, probably things can be very good.
Thank you so much for talking about, I think what you're talking about. I'm so happy that education system has not eliminated every single vocal cord in this room. I'm so happy. If there are more vocal cords which want to sing, which want to speak, please feel free. The mic will come to you. It's very important. It's very, very important that we need to think actually. Yeah, we need to think. It's not about planning. It's not about regulation. It's not about that. Maybe the solution is in this room actually. Yeah, next. Yeah. So the whole thing called waste, is it a category of bad design is a question that we ask. That, should there be something called extended producer responsibility? That's a new policy that is coming up in many different parts of the world. Next. Yeah. Should we be moving towards zero waste systems? Is it about me? Is it about me as an empowered citizen? Anybody else who wants to speak, particularly women, if you want to speak? Yeah. him in and I said, and this bearded Balu has raised his hand. Yeah, one moment. Yeah. Yeah.
Which is a systemic problem which you're essentially trying to say. How does that change by an engineer or, for example, me?
First, the vocal cord, the vocal cord, what happened to your Imarti and Rasmalai now, Imarti, you spoke up, right? You feel like speaking up. This is something that I'm concerned about. We are concerned about as an individual, as a community, as an institution. And there are many kinds of actions that can be taken. Next. Yeah. So we need to move beyond the linear model, electronic waste. Our person was speaking about electronic waste, right? Yeah. Next, beyond this make, use, dispose model, right? And I'm sure there must have a lot of things about AI, VR, AI, IoT, etc. I saw it in the schedule. We need to move towards a data-driven circular economy model. And this is a recent paper by Christopherson, 2020, right? What do we need to do next? Right? Next. Yeah. So we need to look at what is the specific. So we need to apply probably design thinking. Yeah. Mike is coming to you.
I just wanted to ask that, like you said, that we need to move towards a more data-driven model. So, but if we want to handle a huge amount of data, we need very much resources in energy consumption and such. So how will that solve a problem in sustainability?
Yeah, so I'm not answering all questions here. So I promised you that you'll go back with few more questions. I hope you have one more. Yeah, सोचिए इसके बारे में. Yeah, data-driven is one because because this is all the world is about talking about data. So that is why I have that slide to show that even data scientists are thinking about how to solve the circular economy problem. We'll talk about it a little later if there is time at the end of the talk. So we need to apply design thinking. It's not only a technological solution that will lead us to sustainability, whether it is circular economy or sustainability. We need to ask this question, what's the specific problem that I'm trying to solve? Next. Yeah. And go ahead. Punch. Yeah, frame it as a how might we. For example, you might ask a question, how might we reduce plastic packaging used in supermarkets? Yeah, state the key outcome you're trying to achieve. Write down important aspects of the context, safe transport, hygiene, durability, labeling. I'm just put in a small element of design thinking into this interaction on technologies for sustainability, because only with technology, without design, we may not be able to move many steps forward. And in fact, what I advocate is using an approach called technology, design, and business. So this is industry day. So we need to actually make it viable as a business. Next. Yeah. What's the problem? What are some possible solutions? So in design thinking, we talk about divergent and convergent thinking. So in engineering, often we talk about rational, logical, analytical thinking, but design thinking talks about a combination of successive divergent and convergent thinking by which you generate far more ideas, you test early, fail early, and then you develop more superior ideas in the second cycle of divergent and convergent thinking. Next. Yeah. So understand your users, So user-centered design. Our design needs to be highly user-centered. What are their thoughts? Not only what do they do with your products, but what are they thinking and feeling in general? What are their personas like? Next. Yeah, introducing a concept called empathy map canvas. If you are going to develop an elegant solution for sustainability, we need to understand users. We need to understand ourselves far more deeply. Next. We need to understand what is people's experience with landfills, with dumps, whether it is Jodhpur or IIT. How do we feel when we, when we see a dump like that? Yeah, next. Yeah, we need to map the entire journey. When we consume from this cooler, how do I feel? When I consume from a plastic bottle, how do I feel? When I have to dispose of waste, how do I feel? Yeah, what is the feeling of the garbage pickup person? Yeah, who cleans the toilets? What is her feeling? All those things are important. And we need to test as early as possible with real people and iterative. And we need to learn to sense, we need to learn to see the subtle, the unseen,
कैमरा के पार गई पैर और पैर उड़ा के सीन तेरा पैर तो यार है गिरा नहीं है मेरा पैर अभी हाँ मेरा पैर नहीं गया
We need to develop leadership to develop this sense of empathy. I'm so happy the liberal arts program is running there.
कैमरा का ऑडियो
for diversity.
कैमरा बंद किया है।
Because there is Stanford may not work in India. Encourage community. Yeah, previous slide. Yeah, integrate the technology, business, and design approach. Yeah, next. That's circular economy for you. Yeah, next. Yeah, skip this slide. Go fast a little bit. We are running out of time. Yeah, so I have 3 questions to end with. The people who like to take pictures, if you want, you can take these 3 questions back. Is it only more and more technology and products that will make the world a more beautiful and harmonious place? What do you think? Beauty only through technology? Our friend here, electronics person, beauty only through technology? Ah, wonderful. Is more and more the solution, or do we need to embrace the paradigm of frugal engineering? There is a philosophy in architecture called less is more. Some of you may have heard about it. But, but we all love Pepsi because Imarti, why do we love Pepsi? Because ye dil mange more, isn't it? Is more and more the answer? Or you have to be 55, then only you will realize. Okay, is there something to learn from biomimicry? Can we learn from biomimicry for developing sustainable solutions? Next. Is sustainable consumption and circular economy the only way for us in the years to come? Next. So I hope you take back one thing that, it's not about learning. I hope it's also about vocal cords. Unlearning. It's not only about learning. We think that it's all about learning. So there's a little bit of something wrong that I learned, so I need to unlearn that. Next. It's also about discovery. Like a child. Child is always in a are drooping. Transformation. Experience and transform. Yeah, next. Yeah. And Gandhi, Majburi ka naam Mahatma Gandhi. We have reduced him to that. You know, your generation, your parents' generation, that's my generation also. We have reduced Gandhi to Majburi ka naam Mahatma Gandhi. We'll have to bring him back to Mohandas Karamchand Gandhi. He says, I believe it to be perfectly possible for an individual, that means each vocal cord here, each one of you here, to adopt the way of life of the future without having to wait for others to do so. I hope many of you will. Thank you so much. It was lovely speaking and interacting with all of you. Thank you. I'm open to any questions, any brickbats. Outside also, I think probably we went a little bit ahead of time. My deep apologies to Anand in case I upset his time schedule. That's my email address. I respond to every single email. That's my mobile number. I respond to every single WhatsApp. Yes, Prasalipika De.
Sustainability and an aspiring society.
Ah.
So, you know what my experience is as we move up the ladder, we become more sustainable. We buy these things from Amazon and we wear organic cotton and organic things to eat, whereas the plastic is cheap technology. And that's where I think we are struggling. So what's
Yeah,
what's the
it's a very, yeah. Thank you so much, Professor Lipika, for talking about, how rural India responds, how peri-urban India responds, how urban India responds, how as we move up the Maslow, so-called Maslow's hierarchy, our responses change, what we are seeking changes. It's a very philosophical question also. But I feel that, what is important fundamentally is that, the issue of sustainability begins with the issue of responsibility, the issue of freedom. All these things are also linked to that. Do I have a voice? Are we cultivating people's voices when they are in kindergarten? Or are we training them to be in hierarchical systems where solutions are being fed to them? So the schooling system, many schooling systems that we have gone to, why only 2, 3, 4, 5 voices spoke? If you do an analysis of this, you will find that typically you do not feel safe to speak something silly and feel good about being, feeling small about it. It's okay. I may be wrong. Is it okay to be wrong? Right? But many of us are not told that it's okay. It's important to be right. It's important, बेटे को 99% लाना है और IIT JEE जाना है. शर्मा जी का लड़का IIT पढ़ता है. I hope you understand. Are you all understanding what I just said? That we are pushed towards this thing called, one solution, the solution, the right solution. And if you have the right answer, speak up loudly. Otherwise, don't speak. Right? So I think to answer the question, it seems to be very early conditioning with respect to choices that we make, and we conform. CONFORM. We try to conform. We are very conformist. Typical keynote speaker would have conformed to the podium. He would not have stepped down. It's dangerous to step down because you don't know how these animals will respond. Isn't it? You don't know. Sorry, I'm making it humorous. Huh? You're all meant to smile. Yeah. We don't know. When I come down here, what is exactly going to happen is not known, isn't it? So the person conforms to the stage, remains there, and the memory of the keynote is gone. Right? But it takes courage to come to the Ministry of Information Technology to talk about extended producer responsibility. It takes a little bit of courage. It takes even more courage to come here to Lucknow and to Bhopal. It takes so much more courage to come here to Iran, isn't it? Where are you from? Kashmir. Yeah. Sorry, just joking. It takes so much more courage and come and speak to the Imarti out there who refuse to move actually. Yeah. So we need to get out of this conformist mindset and we need to get into a very creative mindset. I hope Industry Day will take you all into that. Thank you so much for being a wonderful, wonderful, wonderful audience. Pardon me for any jokes which may have hurt you, if at all. If there's anything you want to share, please feel free. I'm available after this panel discussion where Anand is again going to introduce me by my brother's name. Thank you so much. Thank you. Thank you.
I don't know how to thank Professor Vijay Raghavacharya. Although I thought in mind that I got an opportunity for make him remind of his brother sitting in Bombay. Yeah. Thank you so much, sir, for so
Abhi, okay.
now
Thought my colleagues have done in this institute uh, on the verge of towards sustainability. So it's my honor and to bring in my colleagues onto the stage just because of the fact that it's not the institute as such. The institute is made by my colleagues. So it's my duty that all my colleagues come over to the stage and tell their story, because sustainability story is a holistic approach. It's not an individual case study. So, uh, so first of all, before we start off, I think, yeah, I feel that we should have Professor Ram Prakash from Department of Physics to elaborate a couple of minutes on his journey into providing us with an environment which is much more sustainable, a closed space. Over to you.
From here itself, no? View, you go to the view, full screen. Come in? No?
वेबएक्स यहाँ से हटा दिया वेबएक्स हटा दिया क्या वेबएक्स हटा ही दिया
नहीं, ये इसमें से नहीं हो रहा है। मैं अपना लैपटॉप लेके आऊं?
नहीं वो इसी में से
ओके ओके
उनको
वेबएक्स हटाया क्या?
यहाँ से वेबएक्स डिस्कनेक्ट कनेक्ट कर दीजिए उसको
तो एक बार करें।
So good afternoon to all of you. I am here to speak about cold plasma waste technologies. Particularly, we are trying to do nitrogen fixation by some EGS processes that, for this is one of the goal to have food for everyone and health for everyone, actually. So I will just try to present something on that. What we are trying to see, actually, let me speak like this by the time the slides are coming up. Yeah, I don't know whether you have heard the word plasma, actually. This plasma is a fourth state of matter, and it contains energy. So if if I define what is physics and what is chemistry, to my understanding, physics is the branch of science where we study energy. And chemistry is the branch of science where we study matter. So the most interesting part with this plasma is because it is a fourth state of matter, so it is basically chemistry. And it contains energy, that is why it is a physics actually, in a sense, because it talks about energy. Energy is contained with the particles, so that is why it is there. In the visible universe, what we are seeing, more than 99.99% of the matter state is filled by plasma. There is no plasma as Earth actually. Even if you are around 100 kilometers away from Earth, there is a plasma, what you call the ionosphere. Stars are plasma, sun is your plasma. So all around there is a plasma actually, intergalaxies plasma. So all around is the plasma. And this plasma I wanted to use for something which is related with the agriculture and food. So it means it has to go towards biology. So the most interesting part about this physics and chemistry, when there is a what energy is providing is basically the interaction. Physical interaction is possible because of the energy. And what chemistry is providing is a reaction. So whenever there is a reaction and there is an interaction, there is a biological production. So this, because this plasma contains both, it is having energy contained and as well as the matter contained. So you have the chemical reaction, you can have interaction, and you can lead to biological production. So it can be a one of very interesting idea to go for the sustainability, particularly for food and agriculture. Because you can see right now the global challenge which is there, by the mid of this century, we will be around 9.6 billion people on Earth, which is right now 7 billion, around 7 billion. So 7.5 billion. So you can imagine the way population is increasing. And for an individual person, it is around 300 kgs staple food is needed per year. And the way we are increasing, we will be having a lots of requirement of food production on Earth, which will be, there is one analysis which says that by the mid of this century, right now it is the energy which is which we are using per person per day across the world, this has to be cut down to around 30%, and still we have to cut down it, and we have to also have production of the food. Then only we will be able to meet those kind of requirements. So with this intention, will it work, or shall I bring my laptop? Actually, I can push it. Huh? Anyway, so actually I was having some interesting slides to show you. So what I was just trying to say here is that the requirement of the food which is there, and there is even like there is one analysis which says by in the 2020 around 17% the food wastage which we are doing right now. This there was around 17% of the food wastage. If we would have even controlled that food wastage, we would have served at least 650 million people on this earth. Okay, so this is again a very big and challenging idea, that how we can have we can preserve that food. So to have longevity into the food itself is another interesting area for the sustainable development. So the plasma, I feel, is a interconnect for sustainable development. And in this process, we were just trying to think, like particularly there is another challenge which we are seeing right now for this agriculture, that we used to use these urea and what you call the chemical fertilizers. So these chemical fertilizers which are produced on this earth, if you look the data, which says 42% of the carbon emission on this earth is because of this urea production. And this is happening because the production which is done is in a very stringent environmental condition. You need 400 atmosphere pressure. You need at least you need at least 500 to 600 degrees centigrade temperature. At this point, you are trying to produce the fertilizer. And this fertilizer production is becoming very, very challenging, and we are not able to solve the sustainable problem, particularly when we are moving towards agriculture. So we came up with a very interesting idea. And what we produce, a plasma activated water we generated in the lab. So what we produce is we had a water, and we applied the plasma onto it, and we found there were this water was rich with the nitrite and nitrate. And these are the components which are needed for growth of the plant. So you don't even in this nitrogen fixation process, which you used to do when you are doing with the urea and all. So this can be worked out with the simple plasma system. And what we found very interestingly, that we saw the seed germinations. So we took the moong dal seeds, and we just poured that water. The growth of what you call the seeds got germinated very fast, and their growth was very high actually. So I was having some pictures to show you, and we have also seen on the plants, like for example, we are here in desert region. The plants are not growing; they used to die very fast. So what we have seen, we have poured that water inside the plants, and they have grown up very fast. And so these kind of interesting results have come up with the use of that plasma-based technology. हाँ? चलेगा कि नहीं चलेगा? Shall I end it myself? Okay. Okay. So actually, I'm dreaming. We wanted to have a nitrogen fertilizer plant based on plasma-based technology, and that would be a disintegrated plant that could be used by individual farmer in their land, and they can just use that, and they can grow their crops and all. So this is the key idea on which right now I'm working. This has hanged. Shall I bring my laptop? Huh? Okay. Quickly, I just show a few. Okay. नहीं वहां से ये कर सकते हैं क्या? व्यू में जाइए, फुल स्क्रीन कर दीजिए. व्यू में जाके फुल स्क्रीन कर दीजिए ना. Yeah, it will work with this. Yeah. So fine, actually, what I was talking about is this cold plasma-based nitrogen fixation for global agriculture need. That is what we are trying to do in our cold plasma laboratory. And I already mentioned you that there is this end of hunger, achieving the food security and improved nutrition and promote sustainable agriculture is one of the this SDG goal. And I mentioned to you that by the mid of this century, there will be requirement of around 69% into the food calories for the humankind. And we have to basically, the way we are growing the crops, so we have to reduce the energy level, which is right now 2,831 calories to, it has to be brought down to per day per person. It is 2,026 calories, something like that. And as I already told you that around 42% of carbon emission is because of these nitrogen fertilizers that have been produced due to the stringent environmental conditions. So the key issues are to find out alternates for the current fertilizer production. So worldwide efforts are underway, and people are looking for alternate green nitrogen fertilizer productions or processes. So you can see from that the urea production around 29% of the nitrogen fixed by this Haber process. And so I already talked about that, how this physics and chemistry and plasma is biology, which is interlinked, and it can provide a solution, actually. So this plasma is a great hope for food and agriculture. And the most interesting part about this plasma is that we can provide you the disinfection processes, as I mentioned to you, that 17% of that food wastage that has been done, if you would have preserved that itself, this would have solved a lot of problems. So the batch utilization of food industry is expected to contribute around 56.4% of the overall market revenue by 2025. So this plasma can provide, this is what I'm talking about, is the cold plasma basically, and this can this can disinfect, this can remove pests and microtoxins, and there are multiple advantages which are there. And plasma-based nitrogen fertilizations people are trying, and people are working in this direction. So there was one interesting thing which this was the first experiment which was done in 2003, that can this nitrogen fertilizer would be produced at 1 atmospheric pressure at around 80 degrees centigrade temperature, which used to happen around 4,000 atmospheric pressure conditions. So this has been achieved, and in 2016, the first small-scale plant based on plasma has been produced in Germany, and then in one of them has come in the UK. So people are working in this direction, but in India, nobody has started thinking in this direction. And these ideas have not even been disclosed, what exactly they are working. So we started doing something, and people have seen some growths into the plants based on plasma things. So what we did in our laboratory, we produced the cold plasma. You can see here, this was a just a 10 days activity study that we did. This was a tap water. We took the two plants together, and we created the plasma activated water, and then we saw the growth into the plant in just 10 days. It has raised to that height. And also we have seen this seed germination in the moong dal, and you can see that is the control of the control in 1 day, whatever the seed germination that has happened. But when we have put it the plasma in just 20 seconds and then 40 seconds and 1 minute's kind of exposure of that plasma has led to the seed germination very fast. So we have produced by different ways the plasma activated water. And this is the most interesting part, that we have come up with a surface generated plasma. This can be put it onto the water, and we can cover a larger area of water through this mechanism. And you can see that's the 5 minutes of plasma treatment we did with the water, and then 10 minutes and 15 minutes. The 15 minutes of the water has given the optimal growth into these mung seeds, actually. So what we have done in this process is that in general, when we are producing plasma in the atmosphere, it is generating reactive oxygen and nitrogen species. But when we are doing this in the water, we are eliminating the hydrogen peroxide, and this is only increasing the nitrates and nitrites. And because of that, this growth is seen, actually. So this is one area that we are working, and I wanted to make nitrogen fertilizer plants, and small plants that can be used by the individual farmer. That is the key target. With this, I will end here. Thank you very much.
Thank you, Professor Ramprakash. Next, I would like to invite Professor Meenu Chhabra from the Department of Biosciences and Bioengineering to share her.
Good afternoon. Am I audible? I'm sorry, there's some trouble again with the presentation. So my name is Meenu Chhabra, and I work as Associate Professor in the Department of Bioscience Bioengineering. And on this platform, I would I am standing here to request collaborations from students, faculty members, and of course the industry people who are around. So we are basically working on, I will not call it waste to energy, because Professor Vijay Raghavan asked us not to call anything waste. So resource to resource, maybe a relatively less usable resource to a more usable resource. This is what we've been trying to do with the help of microbial fuel cells. So we all understand batteries, and we all understand oxidation reduction, and that we can separate the oxidation reduction reactions to get energy. So all these, yes. So this is bioelectrochemical solutions for energy and environment is what we are working on. And how do we change? Okay. The slides are okay. All right. वहाँ से change हो रहा है. All right. Okay, so what we can see on the screen is that there are microorganisms all around. We cannot see them with the naked eye, but these are the most wonderful biological species that are there in my stomach, that are there on my skin, that is there in the soil, which are doing all the recycling in nature. And for microorganisms, nothing is waste. So they are the ones which are responsible for recycling majority of the carbon, nitrogen, and phosphorus, and we are using these microbes in a microbial fuel cell. So you can see on the scale that anything below 0, which has a negative reduction potential, is actually a good electron donor. There are a lot of wastes which are very good electron donors. And then there are above 0, which have a very high reduction potential. They are actually very good electron acceptors. So when we separate these donors and acceptors, what we get is energy, electrical energy. And at the same time, I can get rid of the donors. Let's say I have glucose dissolved in water. If I'm oxidizing glucose, glucose is getting converted to carbon dioxide. So I have gotten rid of glucose in water, and I have purified my water. Similarly, if I have nitrate in water, which is a pollutant for me, I use a denitrifying microorganism which converts nitrate to nitrogen, which is a harmless gas. So that's how I treat water, by putting them in the anodic and cathodic compartments and get electrical energy out of it. So this is, for example, the theoretical voltage. This is the configuration. We have to collect samples to get the microbes. They are everywhere, and we have to enrich them. We just have to harness the potential of the nature, what Sir said, biomimicry or understanding biology, and taking them for the laboratory application. These are some of the challenges that we solve. And we have developed processes for, yeah, can you please move on to the next slide? Yes. So we have worked on nitrate removal, uranium removal, all the toxic waste that we talk about. For something which is a pesticide for me and a toxicant for me is actually a food for microorganism, and therefore I can put it in the microbial fuel cell to harness energy out of that. So these are some of the systems that we have developed, and we have characterized the microbial communities. Please go ahead. And we demonstrated it in Park, Mumbai. So we have a process for the treatment of water containing uranium-6 and nitrate. If you read newspapers, you'll find that both these compounds are present in our groundwater. Nitrate as well as uranium-6, we need to remove them simultaneously. And this is the process that we did and demonstrated at Park. Can you please move ahead? Now, this is something that we are doing for, now we need electron acceptors in the cathode. And algae, we all know, is a very good organism which fixes carbon dioxide and produces oxygen. So we are cultivating algae, which is also a very good source of bioenergy. These are the anodic and cathodic reactions. Please keep moving ahead. So we have developed this closed loop process. Again, this is available for application in a large scale. I request any industry which is interested in this closed loop process for bioenergy generation. There are almost zero inputs into the, it's a closed loop process with zero carbon and zero waste. So we have scaled up this process to carbon capture for industries. Can we please move ahead? So we have taken the laboratory scale setups from 100 ml to 10 liter scale, and now we are working on a 500 liter scale. So these are the energy outputs. Is it possible to play the video? So here you can see that two gas is coming from the petrol engine. It's going into an heat exchanger. We have Dr. Hardik Butharia from Mechanical Engineering Department, who has designed this heat. Carbon dioxide is bubbled in wastewater. So now the carbon dioxide is getting scrubbed. From the air, it is getting removed and it is entering the water in the form of soluble bicarbonates. And then they are used for the cultivation of algae. So we are actually converting the carbon dioxide to algae biomass. It's essentially circular because algae can be used as a source of biodiesel or biomethane and several other uses, and it can come back. So I will stop. I'm sorry. I hope I have not taken a lot of time. I am available for discussion in case. Thank you.
Thank you so much, Professor Mehnu. Then next is Professor Ravi KR. Is he around? Professor Ravi KR. Professor Trishiki Roy Chaudhary from the Department of Civil and Infrastructure.
Okay, very good afternoon, all of you. So I'm Trishiki Rai Chaudhary. I'm in the Department of Civil and Environmental Engineering and mainly working on water quality. So slide will be displayed or I can explain. Okay, so yeah, so I'm working on water quality, and as a professor was saying, so before I started my PhD, I was actually working in international water management institution. So there I have a scope to work both, like in the industry, not industry, it's kind of NGO, then real field condition, then academia, and so on and so forth. And there I realized actually water, especially water, is not a technical issue. So we have political, we have economical, we have social issue, and so on and so forth. But at the same time, I also realized that if there is 5% technical, and if that 5% is applied or smartly, then it can make a change. So that's why I went for a PhD, and my PhD was mainly on like from the big scale to the smallest scale, nanoparticle. So I started working on nanoparticle, application of nanoparticle for water quality. So my overall interest is like, so one thing is that, I mean, in a professor's slide, we have seen nano bio in the red side of the sustainability, but nano is obviously it's a kind of emerging technology. So we also have to explore the possibility for water treatment and so on and so forth. But I also, I mean, I have not overlooked it completely. That's what my research also include application and implication of nanoparticles. So we want to see the application of nanoparticle as well as if there is a environmental implication. So please go to the. Yeah, so one, as I said, like we are looking into the water quality, so fluoride, arsenic, and so on and so forth. I'm not going to into details of it, but obviously, if we have different kind of contaminants, we have to target those contaminants, right? So we need to have different specific contaminant selective adsorbents or method. So here we are trying to apply different type of the nanoparticle or different kind of system that could be directly used as a filter. So activated carbon nano composite, okay? And also we are looking into the real field, how it is working, because in the real field, we only don't have clean or pure fluoride. We also have other ions, right? So what is the influence of those ions in treating fluoride, and we have to design the system accordingly. So please go next. So we do lots of field sampling also and see whatever, I mean, some of this material worked very well in the lab, but when we tried with the natural water, it does not work, right? Or it does not work that efficiently. So we are trying to ask the question why it's not working, how we can improve the performance and so on and so forth. So we have generating the data and analyzing and trying to identify the factors. So next. Yeah, so another approach we are taking is the in situ water treatment. So what we have talked now is that we are taking the water, treating and using. But other approach is in situ treatment. So one, can you also go to the next slide? Okay, no, upper slide, yeah. So I have not put this picture. So one of these problem is arsenic contamination in West Bengal. So I also did field visit there, and there was a pipeline. I was explaining that from the surface water, I think government already installed the pipeline where the surface water is coming, but the villagers was not using that. So I was doing the field visit in July. So I asked why they are not using that water. So they said that the water is too hot. So they cannot afford a fridge. So whatever the water like contaminated or poisoning is there, but they will use the groundwater because it's very cold. So in the hot summer, the pipe is exposed to sun, so the water become very hot. So it's very, even though there are no arsenic, they don't have any arsenic in the pipe water, but because of the temperature, they are not using it. They are using the groundwater. So the perception is very important. So the in situ approach is that we will be injecting the solution or whatever. Nanoparticle is not applied here because it was not sustainable. But if you are using some reductant or any chemicals, I'm saying like we are trying to synthesize FES. So within the ground, this FES will form, and then it will treat the arsenic underground itself. So if you are extracting the water, you will get arsenic-free water. That is the concept, and we are working in that. So in 1D or small scale, it worked well. We have scale up into 3D, and next step could be field application. So yeah, and I'm not going to, so another thing is that implication of nanoparticles. We are also looking into the, I mean, if you are putting the nanoparticle, disposing it off, whether it can cause an environmental problem or not. So we are also exploring the study in that direction. So thank you very much, and we are also very open for any kind of collaboration. Thank you.
Thank you, Professor Trishiki. Thank you so much. Finally, I will request Professor Bhupendra Singh from Department of Civil Engineering and Infrastructure, please.
So, a very good afternoon to all of you. I am Dr. Bhupendra Singh, Assistant Professor in the Department of Civil and Infrastructure Engineering. So, my core area of research is pavement engineering. So, I work in that field. So, as most of our industries are facing nowadays that we have to cut down our carbon emissions and global warming is a problem. Similarly, our pavement construction industry is also facing the similar problems, road construction. So, our research group, we are working on a number of solutions which are pointing towards this problem. Yeah. So first one is go back. So what is happening? Recently, we made a world record by constructing 75 kilometers of road in some 5 days. We are constructing the roads with a record pace. NHAI did it. But the problem which is facing we are nowadays is the availability of good quality material. And one of the material which is scarce nowadays is the good quality aggregates, which makes the most part of the construction material which we build our road with. So aggregate is available all over India, but most of it is considered unusable because they don't meet certain properties which are expected of them. So first we are using some marginal aggregate, which are the unusable aggregates, which is locally available everywhere. So what problem this aggregate solves? It cut down the transportation cost and transportation emissions because of that we transport the good quality, so-called good quality aggregates from the larger distances. So that results in the fuel consumption also, and that results in cost also. So we are working on the locally available aggregates which are considered unusable, and we are using the different treatment methods, and we are coming up with the solutions so that we can use them in the road construction. Second one is nowadays we are tearing apart so many of the older roads and constructing the new roads. So due to that, a lot of waste is generated. So that is not waste, that is the material that can be reused. So two kind of material is generated due to that. First one is the reclaimed asphalt pavement, which is generated from the bituminous pavements, these black top pavements. And second one is the recycled concrete aggregate, which is generated from the buildings and those kind of things also, but from the roads also. So we are taking the aggregate out of them, we are treating them, and we are using them in the new road construction so that it doesn't go to the waste also. And again, we can solve the problem with the availability of the aggregates also. Then recycling of the aggregate of the aged bitumen. So what happens when we tear apart the older roads, which is made from the bitumen? So from there we get the bitumen also, but this bitumen has aged now. So it has become very stiff. It loses its elasticity. So due to that, we cannot use it in the new construction. So we are working towards, our research group is working towards some solutions so that we can use it again in the new road construction. Yeah, so I will go in the faster. We are using some of the waste plastic to construct some of the paver blocks, which can be used in the parking blocks and those kind of things. We are doing this study by using the waste which is being generated in the IIT Jodhpur campus only. Then we are using some of the waste filler which comes from the industrial, agricultural, municipal waste, those kind of things. Again, we are utilizing them in the road construction. We are reducing the construction temperature also, because now when we want to build up these bituminous roads, we have to heat up the material up to 160, 170 degrees Celsius. And then we have to maintain that temperature till it's laid and roller compacted and all. So that is a problem because we are heating that much of the material at that high temperature. So it produces so much of the greenhouse gases also, and it consumes lots of fuel also. So we are using the cold mix technologies in which we don't have to heat up the material at all. At ambient temperature only we can construct the road. So we are doing that, and we are also working towards improving the durability of the pavement so that the maintenance cost and whatever the cost of the maintenance towards the environment, that also can come down. So these are some of the solutions our lab is working on. Thank you so much.
Thank you, Professor Bhupinder. So, thank you to all my colleagues who have come and, taken time to, and if somebody is getting missed, I don't know, if somebody is to present. Yes. So Professor Sakshi, Professor Sakshi Danekar from Electrical Engineering. Slides, right?
You can talk. That's fine. Okay.
Slides, slides,
It's okay. Leave it. I can talk, it's perfectly fine. Okay, wonderful. We don't have the slides. And I think it's good for the audience because they want to get out of the room quickly. Okay, so I'll just quickly talk about what we work on. So I'm Sakshi Dhanikar. I work in Department of Electrical Engineering. I'm also a member to IDRP, if you know, Interdisciplinary Research Programs, Smart Healthcare and IoT and Applications. So we work primarily on sensors. These are gas sensors. We all know alcohol breath analyzer, right? I'll be surprised if students don't know alcohol breath analyzer, isn't it? Have you tested it? No? That's a lie. Okay, so alcohol breath analyzers, we know police uses, right, on the highways. They check the drivers if they are drunk or not. And those pieces are all imported and they are quite expensive. So if you're curious enough, you can break it open and see what kind of sensors it uses. It's a very expensive sensor, primarily because of the weight functions, right? So our idea is that when we blow breath on any sensor, we should be able to attract the gas of interest, right? So if I want to check if the person has had alcohol or not, it should only pick up alcohol from the breath, right? So now making such sensors which will selectively only pick up alcohol from the breath is very challenging. And that's how these sensors are expensive. There are some low-cost sensors, but they have some challenges that you have to heat them up to 400, 500 degrees centigrade to make them functional, right? The other way is you make cheaper sensors, right? Instead of using one sensor, you use an array of sensors and pick up data from a mix of gases and then apply algorithms to identify the gas of interest, right? So this whole pipeline from using array of sensors, using mix of gases, and then doing this programming, this is what an artificial nose does, right? Like a human nose, we can identify, as we grow, we can identify which smell is what. When we are small, we cannot identify because we are not trained, right? So this is what you do. You train the sensors like you're training the brain. And that's what is called as artificial nose or electronic nose. So this is primarily one work that we do. The other things we do with help of faculty members from biosensors, Dr. Mino is here, some from IIT Delhi, who help us in making biosensors. Those are more point of care diagnostics where we use wet solutions, ELISA technique, or other techniques for building sensors for human health monitoring. Right? And one other work we do is with where we interface it with IoT. That's more of industrial perspective. So in case anybody who wants to discuss more, I'm available. And I'm very much found in electrical engineering, so you can catch me there. Thank you very much. Thank you.
Thank you, Professor Sakshi. Now, I come over to the most and the much awaited session. I'm not taking time too much to actually invite the panelists onto the dais. I will start off with Professor Sudipta Das to come over to the stage and take up his chair. Professor Sudipta Das has been, has been a close close colleague of ours for the last couple of years, and he has been a pushing force behind many of the things, collaborations, MDPs, and various other things, and also building up the Center for Emerging Technologies for Sustainable Development. It has been give a big round of applause to him. So he has
He has a great, great experience over sustainability practice at Ernst and Young, and he started off that in India for the first time in 1990s, right? In the late 1990s. It happened over 20 or two scores or one score of 2 decades or one score of year that you can imagine of, right? He has been also working into various aspects of the sustainability issues in America, Europe, Africa, Australia, and Asia through his position at the Ernst and Young. So he is also a very important, what to say. He has been pushing towards important aspects such as climate change and sustainability. He has published many articles on sustainability development. Actually, very important aspect is that he has been a member of the low carbon working group of the Planning Commission of the Government of India, and presently he heads the Future Station Advisors LLP. It is a sustainability advisory firm and having location presence in Delhi, Mumbai, Hyderabad, and Kolkata. Thank you, sir, for coming by. Next, I will like to invite Dr. Ronak Sutaria over to the stage. Ronak Sutaria is the founder and CEO of the Living Sciences, a company which has won the NASSCOM Emerge 50 2021 award and has been selected as the India's National Startup Award of 2020. Since 2017, he is a industry partner. He has been an industry partner to IIT Kanpur, and Ronak has 20 years of experience, and also had been in the Silicon Valley at USA. So he has his BTech from Computer Engineering and Masters of Science from New Jersey Institute of Technology, USA. Right. I welcome now Uttam Banerjee, CEO of Ecom Eco Solutions, and also he is a alumnus of IIT Delhi, and he works in the area of sustainable solutions, environment, consumer behavior, technology trends, and he believes in less is more, as quoted by Professor Charrier. And he has created several products and has a lot of patents under his name. He also has participated and organized various events by UNICEF, UNESCO. He presently is on the advisory board of SCNO India and serves as a core member of the advisory committee of the Consortium on Sanitation by Jagran Pehal, Government of Bihar, and Advisory Council of the World Sustainability and World CSR. So thank you so much for coming by. And now, I will like to invite his guru, Professor Vijay Raghavacharya. I will not introduce him anymore. So you all know him. And now I will also invite Dr. Deepika Bhattu. She has been a colleague for many years now with me. She has been co-hosting this particular team with me. She is an assistant professor in Department of Civil Engineering, Civil and Infrastructure Engineering at this institute, and she has been, leading up much of the work on the Kota project that we have, a Kota Smart City project, where we are doing source apportionment studies. So, she works in the field of, air purification and, finding out contaminants and measuring all that sort of stuff. So, thank you all for coming by. So.
Good afternoon, everyone, and thank you, Dr. Anand, for the nice introduction. And I thank you all the panelists for coming over here. And without wasting much time, I would like to start with the panel discussion. And I have set of questions for each one of you, so I'll start away with that. So first question for Professor Sudipta Das is, like, what is the definition of sustainability we have in businesses? And what do you think, how closely it is intertwined with the economics, environment, and governmental strategies? And how do we find, this is more for the audience, how do we find the technologies which can be supported as sustainability initiatives? So, Professor Sudipta.
Thank you. Can I come over here and answer?
Yeah, sure.
Oh, thank you. So, sorry. Okay, please do that. Yeah, please do that. Okay. All right. So, I won't go into the, the classical definition of sustainability. I think all of you know about it. You have read about the classical definition of sustainability, but in simple terms of industry, because today is industry day. So we'll talk about industry. And if you have heard about my background, I know nothing but industry, all right? So it's been purely in industry, business consulting. I've spent last almost 30 years of my life. And yeah, so the, can we go to the next page, yeah? So next page, please. So, what I'm going to discuss today is in the context of business, how would you define sustainability? All right. And the question was asked to me. So thank you for that. I would like to answer the question. But before I start answering the question, I would like to get some answers from some of you. Taking a clue from Professor Charrier, vocal cords, please. Any one of you who would like to respond, how do you define sustainability in the context of business? Not about humankind, not about economy, not about all big things. Business, industry day. How would you define sustainability? Anyone? Please. Sure. And that's it. Okay. Fantastic. Good answer. Anyone else? Yeah, please. Sure. So future generation, right? Absolutely great. Anyone else would like to respond? All right. Yes, please. Continue business for a long time. Okay. Okay. Eat less, eat more, right? Of course. So let's come to the next slide, please. So sustainability in the context of business, and I'm not going to a very nice definition, I'm going to a very practical way of responding, is optimal use of natural resources. And how do we do it? What natural resources? We have heard about so many technologies today. We have heard about so many ways of conserving resources. So we are talking about preserving hydrocarbons, preserving minerals. We're talking of preserving petroleum kind of thing, preserving, iron ore and bauxite and all these things. Biodiversity, flora and fauna. Water, so important. We've heard about water, since morning. And environment overall. So essentially, we are talking about optimal use. Now, these, unfortunately, are the resources that we need for any business. Any business you can think about, we need these resources today. So sustainability doesn't mean that going out of business, because as somebody mentioned, keep on doing the business on a sustainable, on a long-term manner. So we have to continue doing the business, but do in a responsible manner where we can reduce and make optimal use. So that would include waste management, that would include circularity, that would include, efficiency, everything. And Business is for whom? Business is for the stakeholders. One of the stakeholders is shareholder, which is investor. So stakeholder value creation. So two very important things. I'm not going to say only optimal use of resources. Keep on creating stakeholder value. Stakeholders could be society, investors, of course we know about investors, value chain, customers, suppliers, all are a part of the value chain. All of us doing business are a part of a longer value chain. And of course your team, your employees, your people. So these two are the very important contexts of sustainability today. That is what I have learned, and this is not definition that I've read in any book. This is from my experience of last 30 years in industry. If you can do that, if somebody can achieve that, then obviously the business is sustainable, and there are several examples of sustainable business in our country as well as all over the world. Next slide, please. How much time do I have? Sorry? 5 minutes? Yeah. So one very important thing which many of us miss out, and I haven't heard too much about it since morning, or rather since post-lunch, is the learning that we have got from the COVID-19 pandemic. The COVID-19 pandemic has taught us that whatever technological advancement we have achieved so far, not only in India, anywhere else in the world, is useless against certain these kind of black swan events. Okay, so black swan events are events, I'm sure all of you know. These are going to happen, but we do not know when these are going to happen, in what shape these are going to happen. So do not ever think this is the end of pandemic. It will come in a different shape, different name, different way, different manner someday. One of these black swan events which is going to happen is climate change. So black swan event doesn't have to be a COVID-19 always. One of these is going to be climate change, and climate change is something, no matter whatever we do, we can avoid climate change. It's going to happen. When it's going to happen, how the impact is going to happen, we don't know. Now, how do we address climate change? There are two broad ways of addressing climate change. One is through actions around mitigation, one is through actions around adaptation. So the technologies of tomorrow, why I'm talking about all these things, I'm talking about technologies for sustainability, technologies for tomorrow. And I've heard so many brilliant technologies on which the faculty, the professors over here are working, students are working. Now, I'm just trying to guide, and I'm just trying to suggest, think about technologies in these areas, because this is what industry wants. Sorry, can you come back to the previous slide, please? Yeah. Technologies around carbon efficient technology, hydrogen economy. I know there's some session going on hydrogen economy separately. I wish I was there, but anyway, I'm sure a lot of you will be there. Efficient manufacturing, innovation, and many more things on mitigation. Mitigation means how do I reduce emission of greenhouse gases, GHG, the biggest problem that we have several problems today in the world. The biggest one is GHG. And adaptation, how do we change ourselves to be more resilient? So through water security, we talked about water today, smart agriculture, okay, I think we touched about smart agriculture also in some of the sessions, resilient infrastructure, healthcare, climate monitoring, resilient transport, resilient society, and so on and so forth. So we need to make ourselves resilient to whatever is going to happen someday through the impact of climate change. So these are the things which industries do not know today to a great extent. I deal with the large industries. Unfortunately, I do not deal, I didn't get a chance to work with SMEs and smaller industries in my professional life. But I'm fortunate enough to work with large industries, top 200 companies of India, for example. And believe you me, they have very less idea. They are looking for ideas, looking for solutions, looking for technologies. And here you are. That's your market. Next one, please. And I think this is my last slide, and I will end within the next 2 minutes. So when we talk about measuring how a company is working in the area of sustainability or business, a company, an industry, the most widely used measures are, we also call it ESG. I'm sure you've heard about the term ESG in context of business. business sustainability is also called ESG. So environmental aspects, if you look at what are the environmental aspects, GHG emissions management technology, depends on technology. Energy usage, energy management technology. Circularity technology. Water usage technology. Innovation technology. Climate risk and opportunity technology. So technology is possibly a very, very major important solution for the industry. If you look at the social aspect, the S aspect, of course, there are many other things which is not possibly so-called technology perfectly, but product safety, occupational safety, value chain engagement, and communities and society, societal good, societal healthcare, societal, system, so rural economy, whatever we have heard so far from the various professors who have been working in the area. So I'm just trying to highlight, I do not bring in a new technology. I'm not a technology person that way, though I did engineering at some point of time. But I'm just trying to highlight that business in the industry day, I'm trying to highlight where the demand lies. The demand of industries lies in these areas. Pick up your areas of comfort zone, pick up what you want to do, excel in that. And that will make you professionals, that will make you entrepreneurs, and that will make you successful, and that will make you, the passion towards this will make you happy. Thank you so much.
Thank you, Professor Das, for sharing your experience with us and for giving us the new or redefined definition of sustainability from your own experience. Now we have the next panelist, Dr. Ronak Sataria. And Dr. Ronak, what is the way your organization, Urban Science, supports government endeavors um, in providing good air quality environments to our citizens? And can you share some B2B stories or your experiences for having a healthy business environment in the country in the future? Yeah, maybe you can come on stage.
Oh, okay. So I think in terms of the context of the work we do, essentially we work in the air quality domain, like Deepika said, and I run a company called Respire Living Sciences. It's been around since 2015, the work we are doing. And currently, broadly, the work we do is under the aegis of the National Clean Air Program. So if some of you might have heard of it or are familiar with it, it's a national level program which has started in 2019. And there are 131 cities which have been identified, which have been considered to be non-attainment. So essentially what that means is that these 131 cities in India have been found to have air quality levels which were not commensurate with the standards which CPCB had set. So that's broadly the guideline and the framework in which we work. We are extensively involved in it. And currently there is actually a program running in the states of UP and Bihar, which is essentially the work we are doing with the government, because both of these are, in accordance with the state governments in UP and in Bihar. It's an Office of PSA sanctioned project. Broadly, what is happening is the NCAP program, which started in 2019, started with a 400 crore budget, which is now actually ramped up to 4,400 crores between 2019 and 2022. The huge increase in budget is being spread in only these 131 cities. And these cities were identified because they didn't have the levels which were needed, the air quality levels. So the question we asked is that, the cities which were getting selected in the National Clean Air Program were based on air quality data, which was there for the prior 3 years. So what happens to the cities which didn't have air quality data? And that was the driving question which we started with, and we started meeting some of the faculties in IIT Kanpur back in 2017 onwards, actually. One of them was Deepika's advisor. But some of these questions led to some field trials, field calibrations and all. And eventually we found that there is technology available to build in India, which is possible to build at about 1/10th to 1/20th the cost, which was currently being used by the central boards and the state governments. So effectively, what has now happened is that at least the 2 states of UP and Bihar have sanctioned projects to roll out very dense air quality monitoring. So 1,400 air quality monitors are being installed in the 2 states. To give a context, So far, India has about 335 to 340 continuous air quality monitors. So we are trying to scale that to about 8,000 to 10,000 monitors without compromising quality at a cost which is about 1/20th the cost. So broadly, our work is in the monitoring domain. It expands into all kinds of emissions monitoring work. So we do PM 2.5, NO2, ozone, CO monitoring, which are toxic pollutants. And then we focus on doing greenhouse gas monitoring, primarily around methane. And that's where we do some of the industry focused work. We are funded by a PSU, a public sector unit, a large petroleum refinery unit, and they are investing in us primarily because they want us to take up fence line monitoring. They want us to take up methane emissions and fugitive leak detection monitoring. So that's broadly the domain we work in. All of this, translates into climate sciences. All of this translates into health studies. Broadly, WHO numbers have estimated that there are about 20 million people who have a reduced quality of life due to air pollution. And about 1.5 million people actually die. These are attributions made to air pollution. So broadly, this is the domain and the realm we work in.
Okay, we have one more question for you. How do you plan to engage with IITJ in the future?
I would love to. I mean, frankly, our work has been born out of a couple of different IITs. It started, I was doing a PhD at IIT Bombay. We got support from IIT Kanpur, a lot of extensive support, actually. We started with, I was telling her that 5 units were initially placed back in December 2016. They procured 5 units. And last month, we shipped out 1,400 units to them. So it's a journey. It doesn't happen overnight. It doesn't happen in 2 years also. But it literally started in a conference. It grew over 4 years. And now it is the largest network. The data set is. So I think in terms of collaborations with IITJ, we value interactions with academics and with researchers, especially those who've, building a career in specific domains. We do extensive work on electronics in building circuit boards, firmware development. So if any of you are working on advanced firmware, which includes edge computing, but also goes beyond edge computing because we do things beyond edge analytics. So we work a lot on the edge side, we work a lot on the cloud side, and we dabble in climate sciences. So if you are doing on any of those three, which is quite a broad spectrum, but if you like to work on big data, we are streaming per minute data from several thousands of locations. We build a lot of equipment. Everything is built in-house, so you are welcome to come to our Pune facility. It's a few thousand square feet facility where we develop all of the equipment. And if you like climate, then of course, talk to Deepika, but we have a lot of climate-focused data, ground-level primary data sets that we collect. So broadly, electronics and data is where we are focused in.
Okay, thank you, Dr. Ram. Now we have our next panelist, Mr. Uttam Banerjee. So to Mr. Uttam, which areas your organizations are trying to impact and which sustainable goals you are actually touching upon? And okay, yeah, maybe that.
Thank you so much for that opportunity. We have something to show, or shall I continue? Did you get my presentation? No issues. So primarily, we have been working in the areas of sanitation, waste management, also looking at the water sector, trying to see how we can, utilize whatever we have in a better way, in a more, conscious way, I would say. It all started as a college project, as Vijay was actually sharing how it actually, taken the shape, how we we started working on urine and the components of urine, how much of nitrogen, phosphorus, potassium is there, and how you can recover that, use it in some other form. So the first product, or I would say the solution that we came up with, was the waterless urinal that he has already shared in the presentation. It was a very small attachment, and it goes into a conventional men's urinal. In the whole process, it saves a lot of water. But when we were working in the urinal sector, while interacting with a lot of consumers and customers and users, we realized that urinal is a very small, segment of the overall ecosystem of sanitation and waste management, whatever we were looking at. And a lot of these customers and users kept asking us that, यूरिन पे तो आप काम कर रहे हो, बाकी चीज़ों का क्या, right? टॉयलेट में बहुत कुछ है देखने के लिए. So what about women's urinal? What about the toilets that we have? How you are managing whatever is coming out of the toilet? And then we started thinking about, okay, it is actually a genuine concern, and how we can, look at that aspect as well. And we started looking at the toilet, the poop also. We captured samples from different septic tanks, different STPs, and what we realized was that it's quite a tough task to recycle that. It's quite a difficult task to degrade that. And one of the primary reasons we could find is there is a lot of chemical contamination that is happening. Nature has all those bacteria and enzymes to process these so-called waste. But what we are artificially doing is we're using a lot of chemicals inside our houses, inside our complexes, whether we talk about hand wash or floor cleaners or maybe toilet cleaners. And all of these cleaners, primarily they're entering in the same sewage system where the pee and poo is going. And it is making it very, very difficult to degrade and decompose. So we thought, okay, before we look at that aspect of degrading that toilet sludge, can we do something else? Can we look at the primary reason why it's happening? And then we started working on enzymes and biocultures and the biological aspect of it. And we created or we developed a range of solutions, alternative solutions to the existing chemical cleaners. We also worked on specific biocultures which can rapidly degrade and recycle the toilet sludge, recover the flushed water, put it back into the flushing system, recover the water and use it for irrigation. So in short, if I have to summarize the work that we do, especially in terms of the SDG goals, I would say that we are looking at as a holistic approach, and we are trying to see, can we create a circular closed loop system through whatever solutions or whatever technologies that we are bringing in, and create a sustainable model, a circular economic model out of it. So yeah, in short, that's what we are doing.
Thank you, Mr. Uttam. Any suggestions for our younger generation to lead a sustainable life in future?
I don't know I'm qualified enough to give a suggestion, but what I have, this is in 2013 when we started doing all of these things. And in this whole journey of 10 years, I myself have become little conscious about the actions that I take. And you asked a very relevant question, that the consumerism that we are talking about, right? कि मेरे पास already 5 कपड़े हैं wardrobe में, एक सेल दिखा, मैं चला गया, एक और उठा के लाया, right? So, and as Vijay was mentioning, can we start asking questions? Can we start asking questions to ourselves as well? कि क्या वो एक और कपड़ा जरूरी है? क्या मुझे वो खरीदना चाहिए, अभी खरीदना चाहिए, कल खरीदना चाहिए, या कब खरीदना चाहिए? Have we started asking those questions? And I think if we start asking those questions to ourselves, we will eventually find an answer to lead a sustainable life. And that is what something that I myself in my life have started practicing.
Thank you, Mr. Uttam.
Thank you. Oh, okay. Finally, it's on.
Okay, so Professor Charya, so the question for you is that how the individual sitting in our audience can be brand ambassador for the sustainability, and can empathy be the part of this design?
Yeah. So I usually end all my talks with a quotation which answers both these questions, and it's a quote from His Holiness the Dalai Lama. Have any of you heard about the Dalai Lama? Very naughty. He's the head of the spiritual Tibetan monastic order, and he's the 42nd Dalai Lama. And one of his quotes, usually I end my presentation with that, and he says one very, very interesting line. He says, "Be kind whenever possible." Yeah, he says, "Be kind whenever possible," but he doesn't end there. He says it's always possible. He's very naughty. He's one of the naughtiest spiritual masters of the world. And I think it conceals a very powerful message that, whether it is, Gandhi spoke about be the change, but this message of the Dalai Lama is very powerful because in Buddhism, one talks about compassion, kindness. It's at the core of Buddhism. And, before I am kind to the environment or to the planet, I need to ask myself, am I being kind to myself? Very often, if you ask this question, I think we would find that, we are very, very merciless with ourselves. We are very unforgiving of ourselves. We are very cruel and crude to ourselves. And that behavior manifests with respect to other people, with respect to environment. So it looks as if Dalai Lama's message about kindness has nothing to do with environment. But environment begins with me, isn't it? So if I'm kind to myself, probably I'll be kind to my pet, I'll be kind to my neighbor, neighboring nation as well. And there'll be peace on the planet, piece by piece, right? So I think the simplest of messages are sometimes the most difficult. Right from school, I think we are conditioned to be unforgiving with respect to oneself. And if we can actually begin by forgiving ourselves for the small mistakes we make, not to repeat those mistakes again tomorrow. And Anand has begun something very beautiful. Anand and Deepika must be complimented for not having, few more bottles of plastic. I think it all begins with small things actually, changing the earth and sustainable development goals begins right here, So what can we do? What can I do? And I'm sure if we introspect, we will find that probably there is little, I think Ronak wanted to circulate a carbon calculator to everybody in the audience to find out, how much are you contributing to the carbon footprint? And what can I do to reduce it? Yeah, I don't need to become Martin Luther King. I don't need to become Nelson Mandela. And I cannot probably become Mahatma Gandhi overnight. But can I reduce my contribution to the global footprint, carbon footprint a little bit, and I think small steps. And I think that question about empathy is how can I begin by being kind to myself? By being kind to myself, I'll understand the tremendous power of kindness to transform everything that can be transformed to something more harmonious, something more beautiful is always possible. Sorry if I took longer time than what I was meant to.
No, sir, not a problem. Yeah, we actually shared this carbon footprint calculator with everyone. I know how many of you tried, but it actually gives you a very fair idea of, it includes the energy consumption and transportation, how much CO2 is emitted if you use the transportation, different modes, and also the waste management practices what you are taking. So I think everyone should have a look at least what components are going in. It will give you a very good idea. It's US based, but we couldn't find anything Indian based. So at least one could try. Yeah. So thank you, Professor Charya. And I would like to thank all the panelists for having a wonderful discussion. And to conclude the session, I would like to call upon stage Dr. Lipika De, Professor Tiwari, and Professor Ajay Agarwal, and Dr. Ram Prakash to give the mementos to the panelists. So, yeah, ma'am, to Professor Charya. Professor Charya, Professor Charya, please come. Now I request Professor Pradeep Tiwari to give the memento to Professor Sudipta Das. Now I request Professor Ajay Agarwal to give memento to Dr. Ronak Sutaria. Now I request Dr. Ram Prakash to give memento to Mr. Uttam Banerjee.
Hello. It has been a great evening, and photo sessions are going on. And it's a wonderful group, wonderful knowledge that we have gained from this particular group of panelists. And, you know, I would like to, on proposing a vote of thanks towards the end of this sustainability session. I don't like to leave this actually leave this function. That's what creates that sustainability back in me, that I would like to sustain this 2.5 hours that I had. So that's the thought process that I want to share with you, because it's very rare that we get gems like this, and we can get very much deeper industry perspective, ESG perspectives, our own nature perspectives, and very relatively what we are to do changes in our life. So in that regard, I thank all the audience also coming here. But I would, on the background of we both, there are several volunteers who have been supporting us for many days, and also many other people. But let me tell you, Sandeep Gupta, Sunil, then we have Ashish, then we have Sanjeev, and we have so many student groups from Professor Shobhana's group, Professor Ram Prakash's group, Professor Ambesh's group, Professor Trishiki's group, Professor Meenu's group. So I don't know, I will go on telling all these. Now, the other aspect is that before we wanted to, organize this session, we got a very great advice from all the panelists before itself. So that was the only thing that we could bring in all the teamwork over to this platform, because we believe that, if IIT Jodhpur has to provide a holistic thing, then it has to work hard, as people say here, that you have to really work hard on the ground in order to make that a perfect, program or participation or thought process. But then also I found that, still we were with the whole program going in,
I saw that the number of questions that came from our audience went relatively down. It was the power of Professor Vijay Raghavacharya, who actually I have memorized this for many, many ages. So this word, his brother's name comes back. So, so Professor Vijay Raghavacharya's advice and his energy going in and, bringing in imartis and laddus and whatnot came out. So thank you all for joining in. And the other important thing that came up is that we got this advice from all the four panelists that what we need to do on the podium, off the podium, how to uh, do things here. So that advice actually paved off. I thank Professor Sudipta Das, Professor Dr. Ronak Sataria, and Uttam for all guiding us together. So otherwise, this would not have been. And I also thank the last minute confusions which were coming by during this particular whole thing, that were sorted out by Sunil ji and his team. So thank you so much, Sunil ji, and also I thank the whole the organizing partners, organizing administration, as well as Professor Shantanu Chaudhary for being behind us, pushing every minute and whatnot. Thank you so much to everybody. Please have your tea. We have actually made you sit through, and I think it was a great learning. Thank you so much. Thank you. Yeah, please do not, forget to visit our poster session. That is the Technology for Sustainability poster session, because we need to provide awards to our little junior colleagues who are, participating in this poster. So do go there and, give them some encouragement out there. So there are posters also in the case building. There are also posters here in the technology for sustainability arena, and in case building it seems that many people didn't go. So I would request you also to march on to the case building. That is the center for equipments, higher equipments. So to go there besides the Shamiana, so such that there are students awaiting you, such that they want to present to you. Thank you so much for coming by. Thank you.
स्टार्ट हो जाए आप ट्राई
Hello. Okay. Good evening, everyone. So sorry for the delay, but there was some technical issues which we were trying to sort it out. So dear invitees, colleague, student, and all the people who are present here, we welcome you to the last session of the Industry Day 2023. And this session is focused on the hydrogen economy. First of all, on the behalf of IIT Jodhpur, I thank all the dignitaries for accepting our invitation and coming to this beautiful campus and sharing their thoughts on this important topic. Now, without further delay, I would like to invite our keynote speaker for this theme, Dr. K.C. Sandeep, for delivering the talk. Let me introduce Dr. Sandeep K.C. Dr. Sandeep K.C. is a chemical engineer, graduated from the University of Calicut, Kerala. He joined Heavy Water Division BARC Mumbai in 2005. After graduating from the 48th batch of the BARC training school, subsequently he completed his MSc Engineering and PhD in Chemical Engineering at Homi Bhabha National Institute, Mumbai. He is working in an area of hydrogen production by water, electrolysis, and separation of hydrogen isotope using different techniques such as absorption, membrane, and the electrochemical method. His areas of expertise include process design, reaction engineering, and process modeling and simulation. At present, he is heading process development section of Heavy Water Division BARC and leading a team of engineers working in the development of different technology related to the green hydrogen. He is an author of peer-reviewed international journal publications and conferences. He is also recognized MTech Guide of Homi Bhabha National Institute, Mumbai. Based on his significant contribution, he has been honored with the DAE Young Engineer Award in 2016 and two Group Achievements Award in 2015 and 2021 by Department of Atomic Energy. Recently, he has been awarded with a Nina Saxena Excellence in Technology Award 2022 from IIT Kharagpur. With this short introduction, I invite Dr. Sandeep K.C. to deliver the keynote speech. I think he went for the poster evaluation, so he might be coming in a few minutes. I have to introduce, so let me quickly again go through the small introduction. So on the behalf of IIT Jodhpur, we thank you for accepting our invitation and for traveling here and sharing your thoughts on this important topic. And now I would like to invite Dr. Sandeep K.C. to deliver his keynote speaker. Thank you, Professor Prashant, for introduction. Good afternoon to all. First of all, I would like to thank IIT Jodhpur, especially Professor P.K. Tiwari and Professor Prashant, for providing an opportunity to be here as a part of this industry day. So today I'll be talking on this topic, hydrogen economy, process options and indigenous efforts. So let us just start our discussion with global energy scenario. So if we look at it on the left-hand side, so the total energy demand, so that is met by fossil fuels around 80%. Out of this, the major contribution is from oil around 31%, next coal and then natural gas. In the right-hand side, I have given a projected energy demand up to 2050. Even if you see at 2050, the trends remains similar. It will be dominated by only fossil fuels. As we know, the carbon present in hydrocarbon or fossil fuels, it will be converted into carbon dioxide during its combustion. And if we compare these different global greenhouse gas emissions, then the major contribution is from CO2 that comes to be around 77%. And CO2 is majorly it is coming from this electricity and heat production, basically from thermal power plants, and then from transport sector. As we know, the energy from sun that is reaching to atmosphere through sunlight, and our earth radiates IR waves. And these greenhouse gases, including CO2, it has a property to absorb these IR waves, which makes our atmosphere hotter. And if we compare this temperature rise from 1950 to around 2020, this comes to be around 1.5 degrees Celsius. And if you want to use fossil fuels in the similar fashion, so there will be a temperature rise of nearly 4 degrees Celsius at the end of this decade. And this can adversely affect our human, mankind and ecosystem. So in order to mitigate that, we need to look for some alternate energy sources, basically renewable energy sources and nuclear. And at the same time, we need also to look for an energy carrier which can transfer this energy at its generation site to the point of end use. And the most promising energy carrier at present, it is hydrogen. Now let us discuss about why hydrogen is so much important. So if we see, hydrogen is the most common substance in the universe. And if we consider the source of hydrogen as water, there is an abundant source of water because 71% of Earth's surface it is covered by water. And hydrogen can be produced from many energy resources, like it can convert this water to hydrogen using either heat or electricity or even light. Since hydrogen produces only on combustion, basically only water vapor, so there is no point of CO2 emission over here. When we compare the calorific value of this fuel, it is an excellent energy carrier. It has 39.4 kilowatt hour per kg of hydrogen. And when we compare it with gasoline, this is nearly 3 times. Now, let us see what are the uses of hydrogen. At present, 55% of the hydrogen in globally, it is meant for production of ammonia. This is utilized in agriculture industry. The next one is contributed by refineries. Basically, they use hydrogen for dehydrodesulfurization process for removal of sulfur from diesel. The next one is methanol. Methanol is a precursor for many of the plastic industries. And remaining 10% is from all other industries, that is including transport. So depending upon the feedstock and method of production, industry has given different color codings for hydrogen. Even hydrogen is colorless. The hydrogen which is produced from solar, wind or hydro, basically renewable energy, using water as feed, it is called green hydrogen. When we produce hydrogen from coal gasification, it is black hydrogen. And in the industry, majority of the hydrogen, it is coming from natural gas reforming. So it is called gray hydrogen. When we are able to capture or sequestrate CO2 from gray hydrogen, it becomes
blue hydrogen. Now, let us discuss about the importance of green hydrogen as an Indian perspective. So this is based on a report published by International Energy Agency. The annual consumption of hydrogen in India, this comes to be around 6 million metric ton per year. And majority of this is coming from natural gas reforming. So we release around 60 million metric ton per year of CO2. And this feedstock natural gas, more than 50% right now we are importing. This comes to be a import value bills of around 9.5 billion US dollar. And if we are able to replace this gray hydrogen with green hydrogen at a reasonable price, then we'll be able to reduce the feedstock import bills drastically, promoting the energy security and self-reliance of the country. At the same time, we'll be able to decarbonize some of the industrial sectors, and we can also address climate change issues. So based on this vision, so at Baba Atomic Research Center, BRC, we have different programs for water splitting. From a nuclear reactor, as we know, we get two different forms of energy. One is heat, other one is electricity. And if you want to split water using only heat, then we need to go for very high temperature, more than 2000 degrees Celsius, so which is not feasible. So in order to decrease the operating temperature, we need to go for thermochemical cycles. In BRC, we practice two different thermochemical cycles. One is sulfur iodine cycle, other one is copper chlorine. And if you want to use a combination of electricity and heat for hydrogen generation from water, the option is steam electrolysis. And if you want to use only electricity, the option is water electrolysis. So in BRC, there are different developmental programs for water electrolysis, steam electrolysis, as well as thermochemical cycles. So I will just explain one by one in my subsequent slides. So this is a particular schematic of iodine sulfur thermochemical cycle. So in thermochemical cycles, basically it is just like a black box. So water is the feed. There should be a heat source, and there will be n number of reactions which are taking place. And at the end, we get hydrogen and oxygen as a product. The remaining products will be in a recycled bag. So you can see here, at the middle, water is entering. It reacts with iodine and sulfur dioxide, forms HI and H2SO4, and they are separated. And HI is again decomposed to H2 and I2. So H2 is released to the user, then iodine is recycled back. Similar way, H2SO4, this is decomposed to sulfur dioxide, 1 mole of H2O and oxygen. Oxygen is vented outside, and SO2 and H2O, it is recycled back. So this is the overall schematic of iodine sulfur thermochemical cycle. So there is one more cycle which we are pursuing at BRC. This one is copper chlorine thermochemical cycle. Here also the concept remains the same. Feed is water. We need a source of heat, and there are n number of reactions. Here the reactions are 4, and ultimately we get hydrogen and oxygen. All the intermediate products, they are recycled back. Next one is steam electrolysis. It is very important process. The main advantage is that as compared with low temperature water electrolysis, the total energy demand in steam electrolysis, it is lesser. So in the left hand side, after this dotted line, you can see that is corresponding to the low temperature water electrolysis, and the right hand side, it is the steam electrolysis. So the total energy demand in steam electrolysis is lesser. And if we see the red lines and blue lines, basically the total energy demand is contributed by two different terms in thermodynamics. One is delta G, other one is T delta S. So delta G plus T delta S, that contributes to the heat of reaction. So if we see on the right hand side, as we increase the temperature, basically even the total energy demand, it is increasing, but the energy demand for electricity or electric energy demand, that is coming down. And T delta S, that is also increasing. So what does it mean? So we can provide this excess energy in terms of heat, which is a low cost energy compared with electrical energy. So it is very important to pursue R&D on steam electrolysis. In low temperature water electrolysis, at present we are having 3 different options. anion exchange membrane water electrolyzer, proton exchange membrane water electrolyzer, and alkaline water electrolyzer. Anion exchange membrane water electrolyzer, this is the ideal candidate. Basically, here we can get the advantages of PEM electrolyzer at a lower cost. But basically, the issue here is the stability of anion exchange membranes. It is not very good. It is still to be developed. The stack life will be decided based on these anion exchange membranes. And the other two, alkaline water electrolyzer and proton exchange membrane, they are still, they are almost mature. Basically, alkaline is more matured. In terms of capital cost, maturity, and scale, and stack life, alkaline water electrolyzer is better. And if you want to operate our electrolyzer at a higher current density, high pressure, or at a higher purity, proton exchange membrane electrolyzer, that is preferred. And in my subsequent slides, I'll be talking more on the development of alkaline water electrolyzer. So this is a very simple schematic. So it is, the process is very simple. So we need to provide a water as feed. We need to provide DC electricity. Then we get hydrogen and oxygen from our electrolyzer plant. Now let us discuss about the advantages of low temperature water electrolysis process. So this is the simplest process which produces hydrogen and oxygen in a single step at its highest purity. So when we compare this process with other hydrogen production method like steam methane reforming, that operating temperature over here it is close to ambient, close to 30 to 50 degrees Celsius, where steam methane reforming, it operates around 800 degrees Celsius. Here the feed is only water, so there is no CO2 emission. And we can operate these electrolyzers with high turn down ratio of around 20 to 100% of its rated capacity. So this is very, basically we need to discuss on this point much more, because we need to couple ultimately this with solar power plants for renewable hydrogen production. And the solar intensity varies with respect to time in a day as well as in season. So this operating in a high turn down ratio, it is very much critical for any process. And this can be, using this process, we can produce hydrogen on demand and on site. So this can be a source for centralized and decentralized hydrogen. So it can be scaled up in a modular way. It is very good. And commercially, the technologies are matured. But as on today, all the electrolyzers in the country, they are imported. And there is no indigenous technology available in the country for alkaline water electrolyzer. So based on this fact, nearly 10 years before, BRC has started some developmental activities. So the approach is like this. For any water electrolyzer, so basically there are two different parameters which decide the performance of any water electrolyzer. So first one is current density and other one is cell voltage. Current density is nothing but the amount of current that we can pass through electrode per unit area of its electrode. And if you are able to pass more current per unit area, the production rate per unit area will be higher, or for a given production rate, the area requirement for the electrode that will come down. So this will make the system very compact. So ultimately our initial investment will come down. Cost of hydrogen we can bring down. At the same time, if you want to operate our electrolyzer at a higher current density, then we need to go for very high cell voltage. So this increases the operating cost, or it decreases the cell voltage efficiency. So all these developmental programs, so basically they will be focusing on maximizing the current density at the lowest cell voltage possible. And current density and cell voltage, they are function of electrode materials. So we have three options I have just given over here. The electrode material should have good electrical conductivity. It should be corrosion resistant. It should have good electrochemical activity, and it should have low cost. So if we see on the left-hand side, basically it is steel. Steel is having low cost, but electrochemical activity wise, it is poor. And when we move towards the right-hand side, basically we are moving towards the noble metal side. Here, the activity, electrochemical activity is quite good, but you have to pay more. So as a cost-effective option, we have selected nickel for our developmental program. And if you see the type of electrode configuration, there are different types which are reported in literature. One is plate type, extended surface, perforated electrodes, and porous electrodes. And among these porous electrodes, they provide the maximum active sites per unit physical area of this electrode. So it can operate at very high current density, even at lower voltage. So based on this fact, we have selected porous electrodes for our future development. So there are two different types of design. So one is unipolar tank type design, other one is bipolar filter press type design. So you can see here in the right hand side corner, so there are n number of tanks which are connected, and in each tank there will be two electrodes, and there is a distance between there is a high distance or more distance between these two electrodes. So as we know, the resistance in any electrolytic cell, it is directly proportional to the distance in the ohmic region. So the voltage drop over here, it will be quite high, or the efficiency in tank type unipolar type design will be quite less. And it will take more floor area. If you see here, we need to arrange n number of tanks in series. So it will take more floor area. But mainly the advantage over here, it is the maintenance. Maintenance is very easy in unipolar tank type electrolyzers. And if you want to increase the efficiency of this type of electrolyzer, we need to bring these two electrodes closer. Let us take a situation in which we are just bringing two electrodes closer in order to decrease the distance. So in that case, what is happening? So one side of electrode, this hydrogen is getting generated, other side oxygen. And when we bring these two electrodes together, there is a chances of mixing of these two gases, or we need to compromise on the purity of this hydrogen which is getting generated. So in order to prevent that, normally we provide a diaphragm in between these electrodes. And you can see here in the left hand side corner, so there is a filter press type design. Basically, all these electrodes, they are sandwiched and there is a diaphragm in between, and the entire size has come down. Here the efficiency is also higher as compared with tank type. So this is a very compact design with higher efficiency. So we selected this filter press type design for our future development. So as I told, we need a separated diaphragm. So we have three options: asbestos, polysulfones, and anion exchange membranes. And we have not selected this anion exchange membrane mainly due to two reasons. So first one is this stability of anion exchange membranes, it is not good. And second one, there is no indigenous source of anion exchange membrane in the country. So we have initiated some R&D activity for development of polysulfone based membranes. And we started our initial activity of development with asbestos diaphragms. Or in short, nickel was selected as the electrode because it was a cost-effective option with favorable reaction kinetics. And porous nickel electrode was selected because it has the highest active surface area per unit physical area of electrode. Bipolar plate design was selected to reduce the ohmic losses and to increase the efficiency. And asbestos was selected as the diaphragm material due to its high ionic conductivity, which leads to lower ohmic drop. Yeah. So in BARC, we developed a process for the production of these porous nickel electrodes. So you can see here in the left-hand side, it is a ACM photograph of these electrodes. So initially, this has been fabricated in a small size, around 50 mm. And once cell has been designed, you can see here. So there is a cell over here. So there are two gas separators. And this has been tested initially. The polarization characteristics were generated, gas purity data was generated. And based on this confidence, we thought of scale up. So the production capacity over here, it was around 4 LPH. And subsequently, the scale up was thought in a very systematic manner. Initially, we thought to study the effect of stacking. So we will not increase the diameter. So only the effect of stacking will be studied in the first phase. Next phase, we will be introducing or we will be increasing the electrode diameter to an intermediate scale. And we will also introduce the electrolyte distributor and electrolyte pump for distribution. And in the fourth attempt, we'll be going to a higher diameter electrode with a provision for studying the effect of pressure. So you can see here, this is a intermediate scale, next scale. So basically it is a 3-cell stack. So in the right-hand side corner, you can see here, there is a cell module with 3 stacks together. So there is an electrolyte pump over here. There are 2 gas separators. So hydrogen production rate of around 12 NLPH. This has been demonstrated. And based on this confidence, we have increased the diameter nearly 3 times. And the effect of electrolyte distribution and stacking, this has been incorporated. And basically this produces around 80 NLPH of hydrogen. So before going to increase the diameter further, we thought of doing some CFD analysis to get an insight onto the hydrodynamics of this system. So basically here we need to handle 2-phase flow, one side hydrogen, other side oxygen. And in case of any dry zones inside the cell, there can be a mixing of hydrogen and oxygen, and which can lead to a hotspot, and eventually it will damage the cell. So we studied this analysis, we studied this hydrodynamics using CFD. So initially single phase flow was modeled and it has been validated later. And subsequently 2-phase flow was analyzed, and later the distribution of electrolyte through this stack, this was done. So these are some of the results. So you can see here, this is the pressure profile in the left-hand side. Right-hand side, these are the velocity streamlines. And these results were validated. Different experimental setups were made. These are one of the results. And this is the pressure profile in a cell module stack. This stack is having around 25 cells. And the right-hand side, this is the flow distribution through each bipolar plate, each cell which are connected in series. So based on this confidence, so we have increased our diameter up to around 500 mm. You can see here in the right-hand side, there is a 6-cell module stack. This produces around 1200 NLPH. And we made one process kit in which we can study the effect of pressure as well. So this is the summary of scale up. So we started with a single cell which produces around 4 LPH capacity. And subsequently we have gone ahead with 3-cell stack, later to 80 LPH capacity, and finally to 1200 NLPH. And if we see the gas purity from cell module exit, due to some inherent property of this diaphragm, there will be always some traces of oxygen in the hydrogen stream. So as per the user requirement, we need to purify hydrogen up to 99.99%. So this has been done by passing this hydrogen through a packed bed catalytic reactor. So the catalyst will be some noble metal based catalyst. In presence of this palladium or platinum based catalyst, the trace amount of oxygen will be reacting with hydrogen, forming water vapor. And there is a dedicated group at BRC. So they work on the indigenous development of this catalyst. And you can see here in the right-hand side. So this is a catalyst reactor test facility. So we do a lot of experiments over here to generate the reaction kinetics data. And finally, we select the catalyst based on the performance. And our next objective was to further scale up to a scale of around 10 meter cube per hour, which is as the smaller scale in industry, as per the industry is considered. 10 meter cube per hour. This can be readily deployed. So the first attempt was to develop a flow sheet. So you can see here there is a cell module and there is a pump. This pump supplies this electrolyte into the cell module. From the cell module, during electrolysis, at the exit, we get a 2-phase gas mixture. So we need to separate this gas in a gas liquid separator. And later, at the exit of this gas liquid separator, so basically we get some traces of alkali as well as oxygen in the hydrogen stream. The alkali is scrubbed first in an alkali scrubber, and the hydrogen is further purified by removing oxygen in catalytic recombiner. The oxygen will be converted into water vapor, and this water vapor is removed in gas cooler. And finally, we are going to get 99.99% of hydrogen. So based on this, cell module stack was fabricated. So this is the bigger cell module which can produce 10 meter cube per hour of hydrogen capacity, around 10,000 normal liters per hour. So basically the design features are, it is compact bipolar filter press type design. This cell is having almost zero gap. So we are using thin sintered porous nickel electrodes. This can go to a high current density of around 5000 ASM, and it can produce high purity product gases, both oxygen and hydrogen. So this is the first production plant which was developed at BRC. So this plant is having a dedicated control system. So this has been operated for more than 5,000 hours in around the clock shift. So this is a safe, reliable and robust plant, and 4 such plants were deployed to the user and they are still running. So in this slide, I would like to highlight that BRC is having the complete know-how of the electrolyzer system. We have a team of dedicated engineers from different streams: process, mechanical, electrical and instrumentation. We have expertise on control system design, gas purification system design, and DC electricity power supply. So in this slide, I would like to highlight the electrochemical performance of our cell module stack. So here you can see here in the y-axis, it is the cell voltage. X-axis, it is the current density. This data has been generated by operating the cell module stack at different temperature, 30 degree, 40 degree and 50 degree Celsius. And when you increase the temperature, electrode kinetics are faster. The cell voltage for a given current density, that is coming down over here. And based on this data, we can extract 2 different parameters. One is the ohmic parameter and next one is the current density parameter. Ohmic parameter basically decides the total resistance offered by our electrolytic cell module stack. So basically the value should be low as possible. It is a function of the cell module stack design. And this ohmic parameter, this has been compared with the literature data, and you can see here our BRC electrolyzer is having a lower ohmic parameter. That means this overall resistance in our cell is less. And let us come back to this exchange current density parameter. So basically it indicates the electrode kinetics. So how fast the reaction can take place. So, or this value should be high as possible. So you can see here, this has also been compared with the reported literature. So BRC electrolyzers are having a good electrochemical exchange current density characteristics. So this is the global comparison at present. So there are different electrolyzer manufacturers across the globe: Electrolyzer Corporation Canada, Norsk Hydro Norway, Teledyne Energy Systems USA, DNORA Italy. And if we compare these current densities, so the current densities of these commercial electrolyzers, it varies from around 1,340 to around 12,000 ampere per square meter. So we are coming in between around 4,500 ASM. And the cell voltage, it is almost comparable. So we are able to get this cell voltage even at a lower temperature, 50 degrees Celsius. This technology has been recently transferred to HPCL for green hydrogen production. This is the one of the ceremony during the technology transfer. And subsequently, BPCL has approached us. So we have also transferred this technology to BPCL. So these are some of the news headlines during the technology transfer. This technology has been awarded recently by IIT Kharagpur, Nina Saxena Excellence in Technology Award 2022. So basically this award is meant for those initiatives which are started at lab and gone up to the industrial scale. During the last COVID wave at Mumbai, we used this technology as a spin-off for medical oxygen production. So in our plant, oxygen is produced as a byproduct. So we were able to produce around 5,000 liters of oxygen in an hour. So we introduced some additional gas purification streams. We provided a compressor and we were able to bottle this oxygen at a capacity of around 20 cylinders per day during the pandemic by meeting all the process parameters required for medical grade oxygen. So this was some of the news clips during that time. BRC joins code fight. So this is the proposed scale-up strategy. So right now we have demonstrated up to 50 kilowatt scale, and the attempts are going for to demonstrate 150 kilowatt scale in the left-hand side. And in order to scale up further, there are two different approaches. Either we need to increase the number of cells or we need to increase the electrode diameter. So we are also going in the similar way. So in the right-hand side, I have given two images from Hydrogen X and NEL. You can see here in the 600 kilowatt stack. So they are also increasing the stack length and multiplying with the modules. So we are also planning to go in the similar way. And subsequently, we are also going to increase the electrode diameter. And our target is to get 1 megawatt electrolyzer plant with a production capacity of 200 meter cube per hour. So these are some of the photographs during this development. Right now, these activities are going on, some of the cells which are tested. So the left-hand side, basically those test specimens with increasing stack diameter. So right-hand side, you can see here, we are increasing the number of cells in a stack. Apart from this, we are also doing some R&D activity to improve our system efficiency further. So if we see based on the thermodynamic point of view, so we need to provide only 39.4 kilowatt hour based on the heat of reaction for water splitting. But at present, all these electrolyzers, they are operating with a energy consumption of around 45 to 50 kilowatt hour. So the difference is converted in terms of heat. And if we look at it, these losses, so it is mainly contributed by diaphragm, nearly 21%, and other one is electrode. And we are also working to decrease these losses by improving our diaphragm, and we are also into development of different electrocatalysts. So recently, this technology for diaphragm, this has been indigenously made. So this was done by Membrane Technology Division. Earlier, Professor P.K. Tiwari, he was heading that division at BRC. And this technology has been transferred to Adani. So you can see here, this is the technology transfer ceremony photo. These are some attempts for new electrode and electrocatalyst fabrication. So we are into the development of electrocatalysts. So we are also trying to develop our own multi-physics models by coupling this momentum, energy, mass, and charge balance equations. We have a dedicated team for doing this CFD analysis. So there is one more area in which we are working on, this is the development of laboratory electrolyzer. This is mainly meant for different labs or R&D institutions. Normally we use hydrogen cylinder for our application, and in each cylinder will be having a hydrogen inventory of around 6,000 normal liters. And if we use this type of system, the inventory of hydrogen is around only 3 liters. Or if we see here the fire load, if we compare, this comes down by nearly 100 times lesser. So this is very advantageous. Right now, all these models, they are importing, and even if we are using in our lab. So, and this system can produce around 300 ml per minute of hydrogen at a pressure of 5 bar. So this technology is being just commercializing. This is another application. This is meant for intermediate scale application. So this is a tank type hydrogen generator, what I have shown earlier. So this hydrogen generator can produce a hydrogen production capacity of around 1 meter cube per hour, corresponding to 1000 NLPH at a hydrogen gas purity of around 99.9%. And it can produce a pressure of up to 5 bar. Now, I would like to acknowledge the different contributions from different divisions in our BRC. So there are different divisions involved: Desalination and Membrane Technology Division, Chemical Engineering Division, Chemistry Division, Analytical Chemistry Division, Glass and Advanced Material Division. And there is a committee for guiding the development, Apex Committee for Hydrogen. And we also thank our industrial partners. And today morning, I received a report from Professor P.K. Tiwari stating that radiation flux from sun. Basically, the solar intensity at Jodhpur is quite high when we compare with our other regions in the country. So basically, hydrogen is the future. Now the future is basically IT Jodhpur. Thank you.
Thank you, Dr. Sandeep. We have a time for a couple of questions.
Hello, Dr. Sandeep. This is Dr. Hariom Yadav, registrar here.
Yeah.
I have been a S&T manager rather earlier. So I would like to ask you some sort of funding queries. MNRE has been the nodal ministry for this hydrogen mission.
Yeah.
So what sort of funding you are putting from BARC and what sort of projects you have submitted to MNRE?
Yeah, actually we have our own fund. So right now we are not connecting with the MNRE. We have a dedicated project for hydrogen, which is funded by our Department of Atomic Energy itself. And we are also planning to have a collaborative program with MNRE. Professor Shonde is forming a Hydrogen Valley project. So there we are supposed to participate. So right now we are not into this MNRE program.
Okay, another related question. You were showing something, one slide related to the upscaling from 50 to 150 and then to 1 megawatt.
Yes.
So I didn't see the timelines actually. What sort of timelines you are putting to reach up to 1 megawatt level?
This 600 kilowatt. So this is straightforward. So we are reaching 600 kilowatt in a 1 year period, and 1 megawatt we are targeting in a 2 years period.
With how much funding?
This funding basically the capital cost, it is more or less similar to the industrial standard, around $1,000 per kilowatt. That way we'll be getting a fund from BRC itself, and we are also seeking some funds from MNRE in this Hydrogen Valley program.
So thank you for the interesting talk. So my question is about the gas purification part, right? Where you are talking about that a lot of energy consumption is required to purify the hydrogen. So the contamination is coming, is it from the purging gas, nitrogen, or is it from somewhere else?
No, actually, this is not a nitrogen. So basically, there is a diaphragm which separates these gases, hydrogen and oxygen, and there is no gap between these electrodes. So only diaphragm is used for separation. And you see, this is basically a microporous diaphragm, and there is always some diffusivity. There is some diffusion of hydrogen into the oxygen stream as well as oxygen into the hydrogen stream. So normally this comes to be around 1000 ppm. So the energy intensity is not high, even it is the reaction is exothermic, but we'll be able to manage. Yeah.
So it's mostly oxygen.
Yeah, mostly oxygen. There is no nitrogen.
Okay.
Hello, Dr. Sandeep. I have one question.
Yeah.
So even though you are using the low temperature, so at low temperature, the even kinetics are very slow, but you are getting more current, like 4,500 ampere per. So why is it so?
So that is the beauty of our porous electrode. So basically, if you are going for a higher temperature, close to 90 degrees Celsius, as what they are doing, like commercial electrolyzers, current density will be much higher. But here our objective was to get a higher life for our cell module stack. At high temperature, this corrosion rates will also be dominant.
That is also simulated.
Here our objective was to get a higher life. So basically this cell module stack, even after 10 years, this is operating without any deterioration. All these commercial stacks, the maximum lifetime they provide is around 5 years. Sometimes it extends up to 7
How do I service it? So now you're changing a role for servicing
more
gas,
questions.
and you're getting a step-by-step instruction as to how to replace that diaphragm which has got punctured because of high pressure.
Dr. Sandeep, any concern with a higher current density? I mean, just you were mentioning that if you operate at a higher temperature, you will get probably an even better current density. So any adverse impact of that?
So there is no confusion.
Yeah, operational at higher current density is always better. If it is, if we are able to achieve the current density at a lower temperature, then much more better, because at higher temperature the corrosion rates are higher. So effectively our cell module stack life will come down.
Going ahead for digital twin of process. This digital twin of process is combining and analyzing the different processes what the machines or equipments go through, and even other operational inputs. Right? So there the KPIs are different. You want to see how the machines are operating, can we detect problems before they occur, can we prevent unplanned downtime, etc. Plus, it can also predict
thank you.
when it has to be maintained. So that
Now I would like to
you can
call
also
Professor
identify bottlenecks because of which the
Pradeep K. Tiwari on stage to talk about the different activities which are happening at IIT Jodhpur with respect to the green hydrogen production. Professor Pradeep K. Tiwari currently working as a Jal Jeevan Mission Professor Chair with a focus area on sustainability of drinking water since 2022 and head of the Department of Chemical Engineering, IIT Jodhpur. He joined Homi Bhabha Atomic Research Center in 1977 and became
what you see here. So as
a distinguished scientist in 2012 and associate director of Chemical Engineering Group in 2014. He was a chairman of International Nuclear Desalination Advisory Group and technical work group on nuclear desalination of the International Atomic Energy Agency (RENA) from 2005 to 2015. His wide research area include membrane technology, nanocomposite membrane, heat transfer, two-phase flow, total water solution, water technology, water purification, conventional desalination, and nuclear desalination. With this short introduction, I request Professor Tiwari to talk about the different
So it is
activities.
shown as an anomaly.
Thank you.
And then the efficiency of the pump also comes down. Plus, it says that if this situation continues, then it does predictive analytics and says bearing will go into a failure in 297 days. More seriously, the impeller will go in 6 days. So you have to take immediate action. Once the action is taken, it comes back to normal. So this is a digital twin of process. I am not running the this thing is a 6 minutes video. Similarly, if it is a medical lab example, you can have a dashboard of the entire lab and its equipments here. What is the status? What is the maintenance due? If something is happening because it can fail, all those kind of different graphs you get in the medical lab. So if I advance this, let me just run this.
Thank you, Prashant. Where operational efficiency is necessary.
Good evening, everyone.
Having an enterprise where the workforce can't access information they need can set back day-to-day operational effectiveness.
Yeah, Dr. Sandeep, he was here, and it's nice to hear him because my association also, I was in BRC, BARC, and some of the activities what he has mentioned, Dr. Sandeep mentioned. It's heartening to note that they have gone from lab to land, and they are further going from lab to land. A very important talk it was, and after my superannuation, I joined Department of Chemical Engineering at Jodhpur. And a lot of work earlier also was going on in IIT Jodhpur, particularly related to solar energy. And different departments are working in this direction. I'll be covering some of the aspects of that. Basically, I'll be the spokesperson of the work going on in different departments. And the future, the bright future lying ahead with the synergy of the departments, different departments in IIT Jodhpur. Beyond that,
the industries in our country, the R&D institutions, the academia, together coming in and working on green hydrogen. So why we talk of green hydrogen? Look at this slide. You'll see global hydrogen demand is increasing. And this is the hydrogen demand itself for different purposes like process industries and others, using the fossil fuel. What it leads to is as the fossil fuel cost increases, the hydrogen cost also increases, going to the level of $5, $5 per barrel. So strategy comes how to reduce the carbon footprint, because fossil fuel adds carbon footprint. So different methodologies, solar energy, solar PV, get the electricity, use that solar through photochemical methods for hydrogen production. You can also get from the hydrogen electricity power, and through electrochemical methods using solar PV, produce hydrogen, get electricity or power used as a driving force. Now, electrolysis plays an important role. The present day cost of electrolysis is quite high. Work is being carried out so that this cost, whether it can be reduced, how much it can be reduced, and this is the part of research and development. One of the methodology mentioned is scale up, going from different scale up cycles. Higher the scale up, lower is the cost, electrolyzer cost, and also research and development in that particular area. Now, India, our country, aims from $30 billion economy by 2050. And my friend Professor Sonde tells me that it's 8 times of present day economy. 8 times of present day economy, what it implies. There's a lot of opportunity, but there are many challenges. And that's why government of India, our country, because when we talk of $30 billion economy by 2050, we cannot do it by importing energy from elsewhere. There's need for energy plus. Can our own country be the energy plus? And that's where the green energy comes into picture. The renewable energy comes into picture. And other kinds of energies which do not add carbon footprint, which are indigenously available or can be generated, they play an important role. And that's why Our government has announced on 15th August 2021 the Green Hydrogen Mission Program, with the outlay of, which has come now recently, 19,700 crores. Even in the current budget, which our Honorable Finance Minister, he has provided lot many incentives for the green hydrogen program, green hydrogen mission. This proposal called for from the DST on the Hydrogen Valley platform. So in our own institute, IIT Jodhpur, there are different departments working, as I mentioned, physics, mechanical, chemical engineering, civil and infrastructure engineering. Why? The reason is, look at solar energy. Solar intensity, solar radiation intensity available in Rajasthan is in the range of 6 to 7 kilowatt per square meter per day. 325 days of sunshine. One of the largest in our country. Jodhpur is known as Sun City. More than this. And that's why it is known as Sun City. The green hydrogen program, basic objective is to bring down the cost of hydrogen production through technological innovations, cost reduction strategies through technological innovations. So energy requirement through solar. Because the intensity is high, the solar energy cost will be lower. And that's a very important point, which plays a role for the green hydrogen. We have the strength in the PV side and storage side. We are working on different kinds of integration aspects already. Lot is to be carried out. The computational theoretical work is going on, which can help in the scale-up design of electrolyzers, because the scale-up plays very important role. Like optimization, parameters, prediction of control strategies, improvement in the performance by reducing the bubble formation. There are several possibilities to enhance the efficiency, bring down the cost. And also to the level of enhancing the electrode life, reducing the maintenance, lower explosion limits. So work is going on in this direction, and we, keeping in mind the green hydrogen program and the DST call which came out for 500 tons per annum of hydrogen production, green hydrogen production, our team has worked out some details. Like 500 metric tons per annum comes out to be around 65 kg per hour of hydrogen. So we say 50 kg per hour will be produced by the solar PV electrolysis route and 15 kg per hour will be produced by the biomass route. And the requirement corresponding to the, you need the solar energy, solar PV, you need particular area requirement, space requirement. The water is to be electrolyze into hydrogen, into oxygen. There is space requirement and cost component corresponding to that. And we have worked out the 50 kg per hour on the basis of 50 kg per hour. How much is the energy requirement corresponding to that? How much is the solar PV requirement, and corresponding to that, how much is space area requirement? And it comes out to be around 30 acres, which is about 3% of the area available with us, because in IIT Jodhpur we have 857 acres of land with us, and 30 acres is available. Our director is very positive, and he says that space can be utilized for the hydrogen program, green hydrogen program. Biomass route, another route, 15 kg per hour. Biomass route means basically the bio goes to the biomass, goes to the pre-treatment, goes through the gasification. From the gasification, it produces carbon monoxide, methane, and all. Goes to water shift reaction. From shift reaction, you get more of hydrogen and carbon dioxide. Hydrogen is separated, carbon dioxide is absorbed. That hydrogen is purified and taken. So that's another route. We are working on this also. But we need the support of, we want to work together along with the industries, along with the academia, along with the R&D centers, together in a cohesive manner, utilizing each other's strength. So that time period which is mentioned, we have to achieve this as early as possible. If we miss the bus today, it is gone. Let us be leader in this. And that's why there is need for the working together. Water is one of the issues, because we are talking of from water we produce hydrogen and oxygen. And Rajasthan water is the main issue. 1 kg mole of hydrogen, you require 1 kg mole of water. And that means basically we need about 650 kg per hour or liters per hour of water. So we have worked out a scenario where the wastewater, the grey water, after purification will be utilized for the hydrogen production. And we have worked out the total scenario for this. How much is the water requirement? Which comes out to be around 16 cubic meter per day. In our campus, we use about 1,000 cubic meter per day of water. Wastewater produces of that of 500 to 600 cubic meter per day. From that, we take the 16 cubic meter per day of water, purify it, clean it, and use it for the hydrogen production after treatment. We also worked out the cost part, how much it will cost. It costs hardly 50 lakhs rupees. Then also the hydrogen storage issue comes, and we are exploring the new ideas on this, including the metal hydride. But the important thing is what Rajasthan is having hydrocarbons producing sites like in Barmer area, Jaisalmer Basin, Bikaner Nagaur Basin, Vindhya Basin, and these be utilized, used as potential sites. And tomorrow we are having a big workshop, one-day workshop on to deliberate, to have brainstorming on this. And there are industries, many industries are participating in that. Can oil and gas, who are in this site working here, they are also participating. And I am happy to tell you that today I received message from Jodhpur itself, 40 industries will be participating tomorrow. This is the kind of requirement, need exists, and that is the kind of capability exists. We need to work together. All the academia, industries, R&D centers coming together. As mentioned by Dr. Sandeep, the Department of Atomic Energy, Bhabha Atomic Research Center is willing. Tomorrow, not only Bhabha Atomic Research Center, Nuclear Power Corporation of India also, of Department of Atomic Energy, they are also coming here and participating in this. Hydrogen storage, there are other methodologies also as well as transport. For example, liquid hydrogen transport through the ammonia route, methanol route. Our institute is working in that direction also. The utilization is the gas turbines, utilization is in the fuel cells as a carrier gas by the industries, energy hungry industries. The main object issue was coming whether the energy will be ready to utilize the hydrogen, because if we produce 65 kg per hour of hydrogen, where it will go? And that becomes important point. So it's very encouraging to note many industries will be participating tomorrow, not only from the developer side, also from the utilization side. Safety is another important issue. That also will be deliberated and that will play an important role. With this, thank you very much. And tomorrow we will have a brainstorming on this. Professor Sonde is already here. He has arrived, and probably we will take have important discussions. And there is need to work as a Team India. And we will work as Team India to achieve this goal. IIT Jodhpur is the ideal site because of the solar energy, because of the solar intensity available here. Very high potential to bring down the cost of green hydrogen. Where else? It is Jodhpur. Thank you.
Thank you, Professor Tiwari. Is there any question for Professor Tiwari? Okay, thank you. So now we would like to move ahead. So now we are having a panel session, so panel discussion. So I would like to invite the panel member, Dr. Sandeep Kesi, Dr. Suruchi Roy, and Dr. Pranav Akshi, and Dr. Hardik Kothadia on the stage. So let me introduce the different panel members who will be participating in the discussion. Dr. Suruchi Roy is a CEO and the co-founder of the OSIS Biorenewable, a Bangalore-based bioenergy company providing hydrogen recovery as a service during the wastewater treatment for process industry across US and India. OSIS is currently working to produce green hydrogen for Indian steel, starch, brewing, and FMCG chemical industries via their proprietary product, the OB Hydrocell device. OSIS Bio is currently in the process of integrating advanced machine learning capability to upgrade the OB Hydrocell device into its first kind, fully automated unmanned bioreactor array capable of being installed and run at a remote industrial site with minimum intervention and the maximum safety. OSIS Bio has been semi-finalist of the Nudge Ashirwad Challenge, winner of Qualcomm Design in India Challenge 2021, winner of CII Startuppreneur Award 2020, Award of India Innovation Growth Program 2019, and others. Before starting her own venture, Dr. Rao was working on the conversion of agriculture waste into the ethanol as a transportation fuel as a part of her doctoral work at the Institute of Chemical Technology, Mumbai. Now let me introduce the second panel member, who is the Mr. Pranav Bakshi, is currently working as an Assistant General Manager, L&T Energy Hydrocarbon. He has completed his master degree in chemical engineering from ICT Mumbai. He is having experience of more than 11 years in the field of process design, advanced process control, commissioning, troubleshooting, and optimization of gas, processing, and fertilizer plant. His special interest in new energy transition technology, including biofuel, blue, green hydrogen, hydrogen storage and transport. He is also having a 2 publication. The third panel member is Dr. Hardik Kothadia, he is an assistant professor in the Department of Mechanical Engineering, IIT Jodhpur. His area of expertise in the multi-phase flow, boiling and condensation, heat transfer, fluid mechanics, and other many more. I would invite Professor Pradeep K. Tiwari to moderate the session. And also I would request Professor Sonde to participate in this panel discussion because this is one of the important topic where he would like to participate. So I request Professor Sonde to please join us on the stage.
Yeah, good evening, everyone. So the topic of discussion is how India can be a global hub for green hydrogen. And National Green Hydrogen Mission was launched by Government of India on 15th August 2021. Aims to provide comprehensive action plan for establishing India as a global hub. Economy $3 trillion, 8 times the present. Whenever you talk of higher economy, you need energy. Energy is the engine. Energy is the driving force. So you need to become the energy independent. Our country has to become energy independent. To become the energy independent, how? We cannot keep on importing the oil, cannot keep on importing fossil fuel. Look at the treasure what we have. Renewable, solar, wind, nuclear, whatever it is. Reduce the carbon footprint. Reduce the cost. And that's how comes the green hydrogen program, green hydrogen mission. And that's where comes the topic, how India can be global hub for green hydrogen. Some of the issues which I would like to our panel members to address is how academia, industry academia collaboration can help for green hydrogen mission of India. Our industry is ready. Our industry is ready for this transformation. Local and global impact on the economics. Is hydrogen a better fuel option? Is safety major issue in utilization? I think I'll request Professor Sonde to initiate the discussion on and we move further. Professor Sonde, please.
Thank you. Yeah. 6:30 and late in the day on the second day number 2, to keep this interesting is going to be very difficult. I think that the panel members will have a huge task to do it. So I'll try, Professor Tiwari, to keep it interesting, but I really don't know. And not, I mean, you are moderating, so I would request all my panel members to, I mean, all the panel members to give their opening remarks. But if I have to keep it very brief, is that, you know, it happens in India very often. You know, now there's a buzz on hydrogen. I come from Delhi. Every other day there's a hydrogen. So when you ask why hydrogen, very often many of the people do not know why hydrogen. I mean, I'm frankly telling you. And there's common kind of a thing because there's money provided. L&T guys are here, so BRC. So I'm also working my own former organization, Thermax. Everybody wants to do it. I would request that it is important that we take a step back and ask these very hard questions on why hydrogen and how hydrogen. I think this is very important. We should not go into what is solutions and all that can come much later. I just want to narrate you a story, and I'll not take more than a couple of minutes. In 2011, when India did the solar mission, okay, there's again huge buzz 10 years back on solar. I was invited because that time Dr. Chidambaram, my guru, was the PSA. I mean, our guru, I think, Professor Tiwari was. So he said, Sunday, we had to do solar mission and all that. I said, yes, sir, we'll do it. What is there? Very obvious. Solar, if you look at it, solar thermal efficiency is 60%, turbine efficiency is 40%. So you can get overall almost 38% efficiency. And that time PV was about 12 to 13% on the monosilicon, on the polysilicon. So I said very clearly, India will have to go to a CSP as a road to this one. Not realizing that the actual science was happening elsewhere and not on the solar thermal. And that was total ignorance. And in fact, solar policy gave a feed-in tariff for solar PV about 18 rupees at that point in time. And solar thermal, we said we don't need actual subsidy. Solar thermal can become by itself a viable option. Give us only some about 12 rupees. I think I distinctly remember these numbers when I was working. I was with Thermax and actually working with the government as a public-private enterprise. But 10 years down the line, now when you look at it, there is no CSP. There is no CSP at all. It's very sad. I mean, when I talked to Dr. Kakurkar, he said, Sunday, we missed this. Heliostat should have been there. This should have been there. We should have gone to a parabola. Nothing has happened. So actually, market, how does it look like? How does it do? Is a very complex phenomena. Sometimes we as scientists sitting in a well and like a frog, we say this is the way that we have to touch this particular thing. And all of us, and I'm the main person, a blind man touching an elephant and saying this is what it is. So my request tomorrow when we are going to have this session, and today is a good time to kind of kickstart this panel, is to actually identify why hydrogen. Why hydrogen is very important topic that we need to discuss. All the aspects what Professor Tiwari talked are relevant in terms of the fact that India needs to have energy independence. India needs to have carbon to be actually removed, decarbonized, and India, more importantly, needs huge amount of energy. And if you put these three equations, you'll really find, is it hydrogen is the right answer? May not be, may not be. So I don't know to say that. I'll come back to it a little later, but I just thought that let me start a little bit controversial subject. Is hydrogen the right option at all? Just to give a thinking, you know, in mathematics, you start a hypothesis in a negative manner, and then you do a reductive absorptive program. And by tomorrow evening, I'll convince you that hydrogen is the only way. So I'm just started today saying that hydrogen is not the way. Maybe I don't really feel that hydrogen should be the way. I would like to listen to my panelists to either support me or say, no, what you are saying is absolutely stupid. I stop here at this stage. Thank
Mr.
you.
Pranav Bakshi from L&T. From industry side.
No, it's okay.
Yeah.
Am I audible? Yeah. Speaking after Professor Sonde, I don't know. I mean, being the only non-scientist on the panel, I would like to build on what Sir said in a slightly different way. Hydrogen is not new. I mean, people have been talking about electrolyzing water to produce hydrogen since decades, if not centuries. one of the first reactions to have been studied in the world of physics and chemistry. We did not do it so far, probably because it was not the most efficient solution around. Today, what we are trying to achieve, all of us and many other people all around the country and in the world, is trying to improve its efficiency. But then we also need to think that what is the aspect other than the efficiency? Okay, tomorrow somebody will come up with a very good electrolyzer, a very good gasifier, and produce hydrogen with the best possible efficiency. The problem does not stop there. Hydrogen needs to be handled safely over long distances. Only then it can come up tomorrow and challenge the dominance of fossil fuels. We don't think twice before even taking petrol in a can and putting it in the dicky of our car. Can we do that with hydrogen? I don't think so. Not today, at least. So this is what I request all the brilliant young minds and not so young minds sitting in this room, that please give us some solution to handle hydrogen in a safer and more efficient manner. That's it. Thank you.
Dr. Suriti Ram.
I don't know if we should be the ones following up on this, but let me introduce what my company does, just to set some context here. So we founded Oasis Biorenewables in 2017. Startups are a unique creature now. I did my PhD in something that was completely different to hydrogen. It was converting agricultural waste to ethanol. And the choice to start a business instead of doing a postdoc on hydrogen was purely a financial one. Who would fund this? And what is the best trajectory I can take forward? But where that has left us is that a lot of the questions that Sir asked, who is going to use this hydrogen? And is this the right way for us to be producing it? Was something which you're forced to answer as a startup quite early on. You may not even have conversions or numbers, but there's a customer sitting in front of you asking for those to be qualified before the science is qualified. We joined the Shell E4 program about 3 months after registering the company and having basic proof of concept in the lab. What that led us to is to understand that Nazi era technology is water splitting. They have been trying to do this for a very long time. There was a slide that Sir showed. 44 kilowatt hour per kg is theoretical and you get about 39. How much is required? How much energy input is required at current status quo? 50 to 55. So in terms of chemistry, out is less than in, which is why hydrogen is difficult to it's difficult to be optimistic about hydrogen. But then you ask yourself, why is there so much money going into it? Billions and billions of dollars are being spoken about. Why is there a buzz created around hydrogen? It's because there's hope that the changes that are happening in terms of technology, in terms of answering the questions about usage that justify a reopening of something that is being spoken about for a very long time. What we do at Oasis Biorenewables is completely outlier to green hydrogen and water splitting. At our company, we have developed these bioreactors that take the dilute, so you would know this, dilute carbon content of industrial effluents. You're basically taking wastewater, breaking down all of that carbon content into electrons, and then using electrochemistry, 2 electrons, 2 protons, to make hydrogen gas. So you're combining biology with electrochemistry. The advantage that this gives us is that from day one, you have a user of that hydrogen that you produce, because he also happens to be the one who generates that wastewater. So our first client and our largest client right now is Tata Steel in Jamshedpur. I noticed in your slide, sir, that wasn't a use case that you had put up. Why? DRI, moving away from coal, if you ask, quite honestly, our customers, Tata Steel, okay, so when are you looking to phase out coal? And they will very calmly tell you 2070, right? That's the nation's goal. There's a financial reason. We're a growing country and you cannot allow yourself to slow down. Having said that, the efforts that are being taken to introduce hydrogen into the steel ecosystem is quite wide. It isn't just one company, everybody is investing in it. And at this point, it's simply a question of hedging your bets. You invest in 5 different kinds of technology, including 4 of which would be different kinds of water splitting system. But ultimately, the idea is to produce green hydrogen without being burdened by the troubles of transportation and compression. That is the advantage that we as a company offer. For example, our 6,000 liter per day, 30 kg hydrogen unit at Jamshedpur sits about a kilometer away from their blast furnace. That's what we are talking about, not needing compression. It's just one pipeline, it's 5 bar pressure, purification is simple. Simple is a relative term, but let's say it's simpler than usual. And that means that our customer doesn't have to discover a use case because there is policy driving him. This is use case based on baseline. Having said that, we are not naysayers of electrolysis. It just so happens that we bridge the gaps that current hydrogen ecosystem faces, which is until the problem of storage and compression and how to bring the costs and the carbon footprint of the entire process goes down, we are simply the ones who are producing hydrogen today and not waiting until 2025 or 2030. But this probably is complete contrast to everything we're going to be speaking about tomorrow. You know, pyrolysis, biomass has been around for a long time, and once again, it's a question of how to make it cheap and yet maintain a green carbon footprint. But we're different, you know. Most of our exposure has been on the industry side, and you know, we're looking for forums such as these to now expand. And you know, for us, one of the most important things is industry calls us green hydrogen, but if you look at the policy definition, it's just water splitting. Where does that leave us? So we're hoping that tomorrow would be an interesting conversation. Our CTO, Suhail, will be presenting, and I'm looking forward to it.
Sure, thank you. Dr. Sandeep from BRC, you know, BRC has they are visionaries, and they started work on hydrogen maybe a decade back or beyond, and different aspects of hydrogen, electrolysis route, thermochemical route, using nuclear energy. And so what's your take, Dr. Sandeep?
Yeah, since there are a lot of students over here, I would like to mention about the academia and industry interaction. So right now we are interacting with many industries, including BPCL, HPCL, Adani, then Reliance. So there are 3 questions what industry normally asks. First question, what is the cost? Second question, again, what is the cost? Third question, again, what is the cost? So the academic institutes, basically, we need to focus on how to decrease the overall cost. And if we look at the present scenario, the investment cost per kilowatt, so this comes to be around $1,000 per kilowatt. And if you are able to bring down this to around less than $1,000 per kilowatt, close to 500, then only we'll be able to achieve a target of hydrogen cost around $1 per kg. So these academic institutes, they can think about many aspects. So they can work on electrocatalyst, they can work on this diaphragm development, and there are certain innovative concepts as well in order to decrease the overall cost. So basically, there are certain electrolyses which are membraneless, and if you know, in order to avoid the balance of the plant, there is one more concept which is basically the capillary electrolysis. So there are a lot of aspects, and if we come up with some certain good geometry based on some CFD analysis, which can eventually decrease the overall cost, that is also beneficial. So academic institute like IT Jodhpur, we should look into these aspects, and we have to come in line with the industry. Thank you.
Dr. Hardik.
Thank you, Professor Tiwari. So I am basically working on the transport side. So connecting the producer towards the end user. And as the quote say, well begun is a half done. So we already, like everybody started talking about the hydrogen. We already come to in the news that so many big industries are investing so many amount of the money. So ultimately our main aim is that how the India can become a global hub. So, moment that everybody will start talking about it, the price by default goes down. Like it's about the publicity. That is where currently the media industries are looking at. You do not have to do anything it, you just make it public, and then I know you will get so many other ideas where the students, the public, even common public will start interventing it. And ultimately that is the main aim, to reduce the price and to increase the users. So it's ultimately the win-win situations. Now, the academia, I feel that the academia is the main part which play a crucial role to reduce this price. As the people say, the India is a young country, so most of our population is towards this younger side. Most of in this academic institution where they are doing the engineering or different fields, we are ultimately wasting their energy if we not use it. So, and academia will be the ideal part where the industry can give some problems where they are have to use their manpower. So instead of that, if they can give it to the students, ultimately students will learn it and we will give up the output of that. So it's become like, the learning part where the students can improve their knowledge, plus the output can directly translate into this industry. And there we have this organizations like BRC and other people who help us to translate the research from TRL 1, 2, 3 to TRL 8, 9. So academia has to be there who produce those kind of solutions at a TRL 1 to TRL 3, 4, and then we can give it to this organization, and which leads to ultimately the final part, the end users part. Safety again, if say problem will be there with everyone. Okay, even if you use the fuel, the fossil fuel, there are the drawbacks of that. PV again, the storage is the main problem. Why we will not make a PV at a large scale? While hydrogen, I was just discussing with one of my colleagues who was using it for a combustion part. So the benefit of hydrogen is its weight. Again, it's problem for me to store it, but for safety wise, it's become its benefit. So in case of any leakage, before the combustion or the burning will start, okay, the hydrogen will escape the space. We have to ensure we have to give it some space to vacate or to empty the tank. Even in the vehicle, okay, even if we go with this high pressure tank, okay, the moment any accident is happen, okay, with smart leakage, and you will see that it will not burn it. Compared to petrol, it's much cheaper, it's much easier also. Like even if anything has happened to the petrol car, the petrol will remain on the surface. But if anything goes wrong with this hydrogen car, the hydrogen will escape, and because of its weight, you will see that there is very less chances of the combustion. But still, why we fear about the safety? Because we are not aware about that part. The people are not using it. The moment the people will start using it, people will feel that it's not that much the problem about the safety what initially we were thinking about the safety part. Yes, there are a few concerns related to hydrogen, but compared to fossil fuel, compared to PV, those problems are not that much large. And the last is about the main part. The as Dr. Sonde is also telling, okay, why not hydrogen or why hydrogen? Okay, we have to ask why not. Okay, we have better options. Okay, PV looks embracing, but the problem of the PV is again storage. Okay, battery. Even if you look about the EV batteries, the main problem with EV battery is about the battery part. So if you purchase a vehicle of 70,000 rupees, you will feel that the 30,000 will go to the battery. And after 3 years of uses, the battery will become useless. And then you see that your price of the vehicle, the scooter by default will become half. While the hydrogen, there is no much problem about that. You can directly convert from PV with water and you can use it for hydrogen. You can store it with hydride, and even you can store it with the storage tank also. People are already using a CNG tank. You have to increase a little bit high pressure part, but still you can store it and you can use it as a vehicle. Even government also start looking, like we just recently heard a news about the hydrogen train and hydrogen car is by default, everybody know about that part. So I personally feel that, not because I'm working in that area, but if we look, all the options and if we, tick mark the advantages and disadvantages, we feel, okay, that hydrogen, it still look a brighter chance compared to, as Professor Sunday also told, that CSP. Yes, we made a mistake, but just because we, instead of choosing PV, we choose a CSP, okay, we can overcome or we can correct it now by choosing the correct option. That is the hydrogen part. So that is.
Thank you, Dr. Radik. Open to house now. There, I know very important and learned people are here in the audience. Open to house. Yeah, Professor Vadera, please.
Yeah, I was listening here. The challenges are production, storage, transport, and then finally uses. These are the kind of things and the kind of challenges are there. But then, there can be ways, like she was discussing that, many a times you can find the uses in a way that some of these challenges can be overcome by. So you have to, be innovative to see that what you produce, how do you use and where do you use. So that is something I think a lot of thought has to be put behind those things also. Because every time thinking that, no, we have to compress and store it, or we have to store it in the hydrides or all those things, not necessary that for everything. Or can be used in a decentralized manner in a way. And good part perhaps seems to me is that if we are producing from water, it is available everywhere. Suppose you talk of fossil fuel, you have to at least see that where the well is, where the fuel is. So many of such things. So here, you see that where the fuel is means where is the basis of the fuel is, which is everywhere. So one particular good thing is that water is everywhere. And since water is everywhere, can we innovate to see that, no, we can, minimize those kinds of requirements if possible. So this is one of the approach or thought there also we can focus on. That's what my comment is. Thank you.
Thank you, Professor Vadera. Any other comments?
Good evening, everyone. So I have just one question. Like it is a continuation of the last session where you were talking of sustainability, taking it here for hydrogen economy. We are talking of electrolysis of water. Though we know worldwide water is a challenge to get pure drinking water. So why not we use some of the pollutant like H2S to get hydrogen? Because if you see, those are pollutant, number one. Number two, it is thermodynamically more favorable than electrolysis of water. So why shouldn't we go in that direction? Because ultimately we'll get sulfur, which can be used in other downstream processes.
Yeah, please.
Of course, this demands a very long answer, but I'm not going to bore you with a long answer. You are right to an extent that why we use H2O, why not other chemical which could be used? Understand that even if you're using water, ultimately when the hydrogen is utilized for any energy, you are going to get the water back. So water is getting conserved. Is only that the Rajasthan water may go to Kolkata. I don't think there should be any dispute between the two states where the water is going. And it's not a big number. But where you come from, I also have been thinking about it. Hydrogen sulfide is one other way, but the amount of hazards and the safety issue of hydrogen sulfide, the corrosion and the managing that sulfur coming out of the cathode is a big problem. I would put this proposal to you that look at the chemistry, you look at your electrochemical scale. Problem like what Dr. Sandeep is saying is that ultimately we need electricity. Okay, you are generating electricity, you are using electricity. Hydrogen is made as a carrier of for that particular thing. And that is where the current technology of a water electrolysis, where you need a over potential is about 1.6 or 1.8, is actually inefficient way of doing a water electrolysis. Water is not the right molecule because in the fuel cell, you have to use 0.78 volt to get a good efficiency. And here you are putting 1.6 volt. I mean, it's more than that. So when I was looking at it, why only water? Hydrogen bromide. If you look at hydrogen bromide, H2Br, according to me, it is the best molecule. You can do this hydrogen bromide at about 85% in the water electrolysis because it's just about 1.1 or something. So at 1.23 volt, you can get your system. But the problem is that you have to carry bromine at the level where you are going to use your hydrogen back into electricity. Because end of the day, you have to understand that the future, which I'm going to talk tomorrow, future energy requirement will still remain in the electricity form. Mobility, industries, residential, everything. I mean, I wish it is not, but maybe 80% of the electricity will be electricity. Generating because the solar and wind is electricity. You have to use a round trip efficiency of a hydrogen, and therefore water electrolysis and a fuel cell combo does not really work very well. But since it is available, since it is abundant, that is something which you should go for it. I won't really propose H2S, but I would request you to look at the other molecules. But then the logistics is that you have to carry bromine at the place where you break hydrogen bromide and carry it there and get your hydrogen bromide and carry it back in a circular manner. I've been doing some work on this, and we can discuss that as a part of LOHC, liquid organic hydrogen carrier, and HBR. Fundamentally, at a scientific level, it works well. I want to add one thing, that look, the way the market accepts is not simply because the technology is great, there's a disruption there. Market works purely on cost and cost only. And hence, the gallium arsenide, which was having 38% efficiency, did not find even 1 megawatt is produced gallium arsenide today. It is a low efficiency silicon, which is the king in the solar district. And hence, similarly in hydrogen also, it may so happen that the best of the technology may not be best in terms of the efficiency, may not be the one which will proliferate. What will proliferate later on would be something which is going to be working on not simply efficiency. So I'm not crazily after efficiency, which can use the abundant safe materials. So earth abundant safe materials, whatever technology is going to use will win. Otherwise, again, going away from a crude will end up in another white petroleum and get into difficulty. So we have to be very careful. So my request to the academia here and the industry is, let us understand and set the targets before finding a solution. That is extremely important. We are just going because DOE is saying $1, 1 kg, 1 decade, 1. And that becomes why? I feel India cannot afford $1 hydrogen. If you look at it today, India's energy, we get coal at 0.6 rupees per kilowatt hour. And if you say 33 kilowatt hour is hydrogen, India should talk about hydrogen available to at 18 rupees. I give a carbon dioxide capture about 12 rupees. So our target is not $1, should not use $1, not 100 rupees. It is just 30 rupees. So if I put this challenge, 30 rupees, can I get a hydrogen? That is, I think what we should do today and tomorrow is let us set targets for this country. And Atmanirbhar can happen only when we target what is relevant, what is appropriate, what is most effective for our country, and just don't borrow the target set elsewhere and try to adopt those targets as the target that we have to follow. Though no gospel to us. They are no gospel to us. We need to put ourselves together, and probably industry academia should set these targets. Otherwise, I mean, no target, 5 million tons per annum by 2030. 5 million tons per annum, if somebody puts a back of the envelope calculation, you need 125 gigawatts of renewable energy. Today, India produces about 70 gigawatts of energy. Are you going to tell me that by 2050, all renewable energy which is done by solar and wind will be converted into into hydrogen? No way. So where is the 5 million tons going to come from? Now, these questions, let us debate tomorrow and see how we can do that. And therefore, when I was in BRC, I said that I am for colorless hydrogen. I don't want to create a racial hydrogen saying that this is touchable hydrogen, this is untouchable hydrogen. And we need to have the guts and gumption to say that this is the way that India should follow. And coming from academic institutions, I hope our politicians and our bureaucrats will listen to us. I hope only.
Open to house and yeah, that backside.
Hello. Thank you for a very nice that have a discussion is going on here. So my question is like that, like thank you for first of all the Corona from my side, because before Corona no one talking about the kind of hydrogen and this kind of things. They are talking, but very few people are talking about all over the world. But when Corona comes, people know about the importance of nature and importance of people lives and other health concern about that. And before also people jump from wood to coal to fossil fuels and other nuclear, so many on jumping on different source of energy. So how much is the surety about that is, as people are mentioning that in all over the world, like hydrogen is environmental friendly and it can be used and that can, so many issues that. So, and also here panelists also discussing about all other issues regarding transportation, cheaper price and everything's on concerned about that. But no one looking behind that, like saying that only that is environmental friendly is not have a side effect on that again. But definitely have some side effect of using the hydrogen as a fossil fuel in further future after 10 years, 20 years, 30 years. They have some drawback on the nature. But now because we are using a very less in the trial status, so people doesn't know about what is the impact on the environment and the people health. So whenever you go on the future, again you have to shift to hydrogen to other things. Maybe it goes to the 50 years. Just like the professor also mentioned that the government have a 2050 to have a self-dependent on the energy concern about that. But if you make that much high energy for the self-dependent on that, definitely have if something goes to saturated, then have an impact on the other side. It's not like that, like is just going on as the saturation will be and that will be this, definitely have some side effect on after that. So my question is that I never heard about that in all over the world. As you mentioned that train and China is running on very fast on the hydrogen in all over the world. Production, utilization, recently they use for the high-speed train also. India is also using a train. The question is, no one concerned about what is the side effect of hydrogen for the environment after 20 years and 50 years. So there is no any questions behind that. Even as for my concern, industry people think about that, how can I sell my hydrogen? Academic people thinks like, how can make the good things and do it that. But no one think about the common man, what they want for the health. After 50 years, just like plastic we are, when it comes, everyone is easily utilizing and that kind, now is a garbage for the everywhere. But no one, same thing is the kind of hydrogen, I think 50 years, 30 years, whatever the people will use a huge amount, this definitely saturation is definitely have a side effect. So do you have any this kind of like any, because you people are doing as a kind of industry and other things, this kind of research is going on the world or not? That is my question.
Yeah.
I don't know why I have to fall on the sword for this one, but you are right. Can you name two greenhouse gases? Do you know any two greenhouse gases?
See, I know whatever the greenhouse gases is doesn't matter. I'm talking about the saturation level.
No, 1 second. Let me just finish my point. So you would have heard of CO2, methane being
Yeah,
a
yeah, yeah.
greenhouse gas, right? Do you know water vapor is a greenhouse gas?
Yeah.
So what do you think if you start to use hydrogen at such a large scale that the whole world is looking to do you think water vapor will then become the new CO2 or methane? We don't know.
We don't know. That's my question. I don't also know, but we have a theoretical perspective. We can do it on
So
that
there are
base.
people who are doing life cycle analysis on this. everywhere in the world where this is a question of relevance. It's the same with cell towers and installing cell towers in highly populated areas.
No, 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 no. Cell towers, whatever you people are still showing to the cell power for the beneficiaries, but still the frequency is high. That's the reason we are losing our birds. Nature birds is hardening. That's the reason the wind power, they have mentioned the height, we cannot go to more than 10 feet in the most of areas. That's the reason they're decreasing the wind energy and the people are looking towards the horizontal wind power, not the vertical wind power.
Absolutely. You've answered your own question. There
Yes.
is a good and a bad to everything that we
That's-
do. We're currently in the middle of an existential crisis where we have no other option but to move away from fossil fuels.
No, no. I have a suggestion. Only one thing. Like in same way, if we have a put our little bit thought in every corner, not for the industrial side, in the academia side also, to look on the side effects of maximum timing uses of anything like hydrogen. What is the impact on the nature, yeah, surrounding, yeah, any kind of things in the any kind of living organisms even. Then we know that what is the effect or not.
I think your point is.
Sir, if just one small point I would like to add. Yeah, sure. Sir. So just one small point to add to what ma'am just said. There is also one more aspect which we should think about, all of us. Because most of the green hydrogen discussion is revolving around electrolysis right now.
Yes.
Electrolysis in some form or the other requires rare earth metals. Till the time some research comes up which says that, okay, steel is a good electrode or normal iron is a good electrode. Till that time, at least all of us are talking of things like platinum, palladium, rare earth metals. That is also one point to be considered, that the scale with which we are thinking about, that much quantity of rare earth metals is not easy to come by, because by definition they are rare. I mean, it's not so easy to come by. But again, all this brings back, probably in the previous session, Professor Charyan was talking about sustainability, right? Less is more. I think if we, take this thought forward, what we are discussing right now, probably we'll end up at that point that whatever we do, we will create a problem. So can we do less? I mean, is this probably where we'll end up going? That is what is my thought. I mean, I'm not answering your question. I'm only adding a question to what you already said. So I'll give it to Professor Sonde.
Can I take a minute and just answer? Your question is valid, but don't get angry. I mean, because you're getting angry does not help us also.
No,
We're not
it's
here
not
to
like
answer.
angry, it's not like angry.
See, the question is, totally you are absolutely right, and therefore I'm saying that we must discuss.
I just want to say one sentence.
No, just let me just listen to you, because I understood where you come from, and I absolutely legitimate concern that you have. 115 years back, when Henry Ford punched his fist saying that here is a solution to solve the hot shit on the New York Manhattan, and saying that I got an internal combustion engine, and he was so arrogant. I mean, you know what the story of that Henry Ford, and he built billions, and in 10 years' time, the all horse shit on the New York was just disappeared. Horses were used as a meal, then as a transport vehicle, and now 115 years back, we realized that the villain of all this climate change is because of that bloody internal combustion engine or the steam cycle. So the question you're asking is very philosophical, not for hydrogen. Anything that humanity is doing today, how can we actually ensure that long-term impact of this? Do we have the wisdom to understand this? And the answer goes to what he said, that if we want to answer that question, all of us should live the way that we are living, like this in an air-conditioned room, leave all our comforts, that we want cars, we want planes, we want to. So each humanity, 7 or 8 billion people, which is going to about 9.2 billion people, are willing to actually go back to the days of our saints and sages who lived. The question is not that very easy to answer, because that frugal living, if you want India to do 1.6 billion people, everybody on the road will ask that question. You allowed Western people to live whatever life, and now when we want to enjoy some fruits of a good lifestyle, now you're saying live in a very saintly manner. So therefore, please, this is this question what you're answering has no easy answer. The way Harari says is that the world will go to a place where maybe 100 years, the human species will come out. And you don't have to be worried about that we are the greatest species by the God. So the whole thing is that we are in a self-annihilation mode. All this hydrogen is only may allowed us to make maybe another 50 years more. So we are in that mode. I'm not being pessimistic or giving a gloom doom kind of a scenario. So it's all right. The way that we're looking at is, can we do something so that this ecological disaster waiting to happen, can we slow it down? Inevitability of this whole thing is going to be happening 100 years, 200 years, at best that can happen. And that's not only the energy, there is the artificial intelligence, there's a nuclear button, there are this kind of there are many things which may allow this humanity to go, and the universe will be very happy that this species has gone out, because this is the species which has killed 98% of the sentient beings. So it's our time to move out. So therefore this question has to be looked at, is humanity ready to live in the way that we are going back to the caves and do that wanderer and thunder living? No answer. Nobody will do that. There's a equity. There's a huge philosophical question, and therefore we have to accept that what we are finding today is just see what best we can do to allow that 6 degrees, as she says, will not be reached, and a certain level of a temperature, maybe we can prolong the survival of humanity on the planet Earth for a little longer time. That's all.
Good, thank you very much. I think this will continue. We have, our time is fitting. Nice discussion. It's very, very important and very nice discussion which has taken place from the floor as well as from the panelists. What we come to conclusion is, and that's very important, the need of academia, R&D center, and industry working together, because academia is very good in R&D. R&D centers are very good in the demonstration level. They are excellent. And industry is very good in the commercialization and deployment. If all these three work together, it's possible to reduce the timeline. Reducing the timeline means reducing the cost. So that's very important of working together of all of us, including the environmentalists. Environmentalists are also very important. We have to see the long-term effects also and work out the solution, sustainable, best possible sustainable solution. It may not be ideal solution, best possible sustainable solution. With this, I thank you all. Thanks to the panelists and the audience. Thank you.
Thank you very much, all panel members. So I would like to thank all panel members for giving very detailed thought about this important topic, and which will continue this discussion on the tomorrow's one-day workshop on the hydrogen. So with this, I would like to thank you all. Thank you for joining us, and I'll give you special thanks to the Professor Sonde for joining this panel discussion. Thank you, sir. Thank you for joining us. Thank you. So now we have come up to the end of the session. So now we would like to Okay, so now we would like to, sorry, I forgot that thing. So we would like to present a memento as a token of our gratitude to the panel member. So I would like to invite Dr. Sandeep Casey to come on stage, and I will invite Professor Tiwari to please present a memento. Yeah, that's fine, sir. Oh. Now I request our Deputy Director, Professor Sampath Raj Badera, to present a memento to Dr. Surichi Roy. Now I'd like to invite Mr. Pranay Bakshi, and I request our Professor Sampath Ras Badera to present a memento to Pranay Bakshi. Thank you, sir. Thank you for joining us. And we, from the IIT Jodhpur, we would like to thank all the speakers and invitees for joining us for this session, and all the colleague and student who has came for this session. So with this, I would like to conclude the session. Thank you. Thank you for joining us.